Good morning, everyone. We'll call this meeting to order. First, like to thank the Native Peoples Action for the wonderful reception last night. And really appreciate the invitation. It was a very fun evening. So thank you. We are beginning our day with presentations on agenda item C2 based on the timing of the presentations at the SSC and AP. I wouldn't anticipate completing all of them today. Maybe we'll come close, but would encourage members of the public wishing to testify on this agenda item to follow the discussion, and please do sign up as we progress through the presentations today. Thank you. Dr. Hapla.
Thanks. Good morning, Madam Chair, members of the council. For the record, Kate Hopla with council staff. I'm just going to introduce the C2 agenda item for you because there's several different components under it. So first, the council is going to receive a presentation from Dr. Patrick Berry, who's a geneticist with the Alaska Fishery Science Center's Auk Bay Labs. Dr. Berry will be presenting the 2023 chum salmon and Chinook salmon genetics report for the Bering Sea. I would just note that Dr. Berry's presentation is going to provide you with 2023 data in context with historical information, which is different from what you will see in the preliminary DEIS, where the genetics information is focused on 2011 through 2022. The council will then receive a presentation from myself, Dr. Diana Stram, and Sarah Marinin on the preliminary draft environmental impact statement, as well as the social impact assessment. These documents analyze the proposed alternatives as well as the potential impacts as the council considers measures to minimize chum salmon bycatch in the Bering Sea pollock fishery. There are two cooperating agencies for this action, the Alaska Department of Fish and Game, as well as the Kuskokwim River Intertribal Fish Commission. The C2 action memo provides you with a list of contributors that are available for questions in addition to council staff. But with us in person today, we will of course have Dr. Berry as well as Dr. Katie Howard with Alaska Department of Fish and Game Salmon Ocean Ecology Program, Miss Alita Trainer with the Division of Subsistence, and then Miss Therese Vincente with the Kuskokwim River Intertribal Fish Commission. Finally, there's several NMFS Alaska Regional Office staff that are available to help answer questions. And Mr. Doug Sheftel will provide you with a short presentation on the agency supplement for alternatives considered but not moved forward. And those slides have been incorporated into the staff presentation. Following the staff presentation on the analytical documents, the council will receive a report from the Agency on Tribal Engagement and Consultation related to salmon bycatch. And then there will be two IPA presentations, the CV Fleets 2023 IPA performance, as well as the proposals under Alternative 4 will be provided for you by Mr. John Hendersheet and Ms. Susie Zagorski. And the CP Sectors 2023 performance and proposal under Alternative 4 will be provided by Ms. Stephanie Madsen and Austin Estabrooks. So unless there's any questions, I'm going to turn it over to Dr. Berry.
Good morning, Madam Chair and members of the committee or the council. For the record, my name is Patrick Berry, and I am a research geneticist at the Alaska Fishery Science Center in Juneau, Alaska. Today, I'll be presenting the results from our genetic stock composition estimate of both chum and Chinook salmon from the 2023 Bering Sea and Aleutian pollock trawl fishery. And so you should have received two reports, one for chum salmon and one for Chinook salmon, in which the Chinook salmon covers both the Bering Sea and Gulf of Alaska. I won't be going over the results from the Gulf of Alaska, but I can answer any questions that you have for that report. And so for this presentation, I'm really going to focus on chum because you're going to be hearing a lot about the draft environmental impact statement. So we'll go through chum pretty in detailed and then go into the Chinook results for the Bering Sea. And so within the federally managed Bering Sea and Aleutian Islands walleye pollock trawl fishery, chum salmon are managed as prohibited species catch, which I'll refer to as bycatch for the rest of these presentations. And here we have the amount of chum salmon bycatch in thousands on the vertical axis and years on the horizontal. And so this is just a time series of the total bycatch in the Bering Sea from the A and B season. So A is graphed in green and B is graphed in orange. And what you can see is that through time, pretty consistently, the majority of the chum salmon bycatch is taken in the B season, approximately 99.6%. And so typically we only analyze the bycatch from the B season because we don't have very many samples from the A. There are rare examples when we do analyze the A season, but I won't be talking about that this year. The average bycatch here is indicated with the horizontal dashed line, which averages about 190,000 chum salmon over the time period. You can see through time that there's pretty high variability in the amount of bycatch. Starting early in the time period through about 2003, bycatch was very low. It reached a peak in 2005 at just over 700,000 fish, but then declined to about 2010. And from 2010 to about 2021, it rised pretty linearly until the last 2 years, where we've experienced pretty large declines in the overall bycatch. And so in 2023, the total bycatch was just under 112,000 fish, which is under that long-term average. And so when we think about the genetic stock composition of the bycatch, when bycatch is encountered in the Bering Sea can influence what genetic groups are taken as bycatch. And so to look at the timing, we plot in two different ways. So on the left is just the total number of chum salmon that are taken as bycatch throughout the B season. And on the right is the cumulative proportion of the bycatch over that B season, with statistical week indicated on the horizontal axis. And so looking at the left graph, you can see the 2023 data plotted in red, and we've plotted all other years in gray to give you some kind of historical context as to when the bycatch is encountered this year. And so you can see that in 2023, there were two peaks in bycatch, one that occurred in July and then one that occurred in August, late August, around statistical week 34. And so it's bimodal this year, where it occurs in kind of two peaks. And if we look at the right-hand graph, we get an idea of when about half of the bycatch is occurring by looking at where that red line crosses the 50% area. And so that occurred at week 32. And if you look at the historical context, this timing is about average. So it's not early and it's not late compared to all the other years. In addition to when the bycatch occurs, where the bycatch occurs can also influence what genetic groups we see in these stock composition estimates. And so I'll walk you through this map because we're going to see it quite a bit in both my presentation and council staffs. And so here's just a map of the Eastern Bering Sea with the ADF&G groundfish statistical areas indicated with the smaller square boxes. And so we aggregate these ADF&G statistical areas to analyze the bycatch. And so one way we aggregate them are by these 4 different clusters indicated as 1, 2, 3, and 4. Going from the eastern to the western side. And so we've also indicated the CVOA area, which is the capture vessel operational area, in red, which is right off the Alaska Peninsula, mostly in cluster 1. And so within these ADF&G statistical areas, we calculate the total amount of bycatch and then represent it by these circles. And so the circle, the diameter of that circle, is proportional to the total bycatch. So a large circle indicates a lot of bycatch, a small circle indicates very little bycatch. And so what you notice is that there's one particular statistical area that is much larger than the others. In fact, 49% of the bycatch came from that particular statistical area, which equates to about 44,000 chum salmon. And so just looking at the clusters themselves, you'll see that the majority of bycatch occurred within cluster 1, 51%, and the next largest was cluster 4 at about 32%. So this doesn't give us any idea of how much effort the fishery puts into each of these. So another way to look at the distribution of the bycatch is to take into account the amount of hauls that the trawl fishery does within each of these statistical areas. So we're correcting for effort within them by looking at a bycatch rate. So that's the number of chum salmon per metric ton of pollock that is harvested. And so when we look at the harvest or the bycatch rate, you'll see that in cluster 1, those large circles go away, indicating that despite there was a lot of chum salmon bycatch, there was a lot of fishing effort in that area. So a lot of pollock was harvested, making those circles smaller relative to the overall amount of bycatch. So the largest bycatch rates were actually encountered in cluster 4, pretty far out to the northwest. And the largest bycatch rate was 1.49 chum per metric ton of pollock. And so again, I've given you some indication of the overall bycatch rate by cluster. Despite the largest bycatch rate being out in cluster 4 for that NPFMC statistical area, overall as an average, cluster 1 was the second highest bycatch encounter rate. Cluster 2 was the largest bycatch encounter rate on average for these statistical areas, followed by cluster area 4 and 3. So again, the fleet is broken up into 3 different processing sectors with very different mobilities and abilities to disperse on the pollock grounds. And so we look at the average location where they encountered bycatch by each of these processing sectors. So here I have each of those graphs with the average location of the bycatch indicated with each of these circles with the 2023 data in red. And so for each of these 3 pieces of the sector, the CPs on the left, the mothership in the middle, and the shore side on the right, you can see the difference in their spatial distribution where they encounter bycatch. And so it's very clear that in 2023, both the CP and the mothership sector were fishing, well, they were encountering bycatch much further northwest than they typically do. So all the other historical average locations of encounters of bycatch are much further to the east relative to 2023. In the shoreside sector, however, you can see that red dot is smack dab in the middle of all the other years. So they encounter their bycatch in 2023 on average in a typical location. So the observer program, the council staff will go over observer coverage in their presentation. However, I'll go into it a little bit because it's important to understand how these samples are collected. So observers are deployed and they have a systematic random sampling design for the bycatch. And so for chum salmon, their goal of sampling is 1 in 30 fish encountered. And so to make sure that when we're running these analyses, there is good representative sampling over both space and time, we plot the sampling proportion by nymphs area and by statistical week. And so here we have sampling proportion on the vertical axis and bee season statistical week on the horizontal. And so the black dotted line represents the 1 in 30 goal. And each of those points represents the sampling proportion or how many fish of the fish that the chum salmon that they encountered did they sample. And so if there was perfect sampling, all of those dots would line up on that black line. So there is some variability. And so the size of those dots, again, is proportional to the total bycatch. And so any of those dots that fall above the line will be oversampling. So they're taking more than 1 in 30, and anything that falls below is going to be undersampling. And you'll see that only once in one NIMS statistical area did they undersample, but it was pretty slight. In fact, on average, they sampled 1 in 31 fish, which is pretty amazing for, all of these observers on multiple boats sampling this many fish. So we don't think that there's going to be any kind of major bias in these results. So it seems like the genetic samples that we receive are very representative over both space and time. So when we do these stock composition estimates, we can estimate the contribution of 6 different genetic groups. And so those genetic groups here are plotted in 4 different maps to give you an idea of the spatial representation that we have within our genetic baseline. And so just walking through each of the maps on the right, so each of these dots represents a collection within the genetic baseline. So it's a group of samples that is collected to give us an idea of the genetic variability that characterize that region. And so in the plot to the upper left, in orange is the Northeast Asia reporting group. And so this represents both wild and hatchery production from Russia. In red is the Southeast Asia reporting group, which we can think of as primarily Japanese hatchery fish. In C, on the upper right, is going to be Western Alaska in yellow. And so this is a pretty large reporting group. And it extends from Kotzebue Sound in the north down through the Nushagak. So it includes all of the watersheds from Kotzebue Sound, Norton Sound, the Yukon, the Kuskokwim, and the Nushagak or Bristol Bay. And so we can distinguish that from the upper middle Yukon. And so we estimate in blue the upper middle Yukon's contribution to the bycatch as well. In D, on the lower left, is the Southwest Alaska reporting group, which is most of the Alaska Peninsula, including Kodiak Island. And then a very large reporting group that we estimate in E is going to be the Eastern Gulf of Alaska, Pacific Northwest in blue. So pretty much extending from Cook Inlet all the way down through BC. So the main results of the 2023 bee season, so the total bycatch was just under 112,000. We analyzed 3,277 samples. And so here I provided for each of the 6 different genetic groups, the estimated number, the estimated confidence interval around that number, the mean proportion, its uncertainty, so the 2.5 to 97.5 confidence intervals around that, a statistic called p=0, which is an indication whether or not any kind of estimate of 0 for our mean is actually 0. So all of those are 0 probabilities, indicating that all of the different genetic reporting groups are actually contributing to these mixtures. And then SF, which is the it's a convergence diagnostic to give us an indication of whether or not our estimation method did a good job. And so all of those indicate that we have no reason to worry about convergence of these estimators. And so just walking through this, you can see that on the top, the Southeast Asia and Northeast Asia reporting groups combined are about 68% of the bycatch in total. So that Northeast Asia reporting group was the largest contributor at 52%, or about 58,000 fish. Southeast Asia was a little bit more reduced at 18,000. For the Western Alaska group, it contributed 8% to the overall bycatch, or 9,200 fish. The upper middle Yukon was much smaller at 2%, or 2,500 fish. Southwest Alaska was very similar at 2% with 2,200 fish. And then the Eastern Gulf of Alaska, Pacific Northwest, was the second largest contributor at about 19%, or 21,000 fish. So how do those numbers compare to what we have seen in the past? And so here I've plotted the stock proportion on the vertical axis and the years from 2011 to 2023. And so we constrain it to 2011 to 2023 because that is the time period over which this representative sampling of the bycatch has occurred. And so we can look at kind of the fluctuations across time for each of these reporting groups. I've plotted the Eastern Gulf of Alaska, Pacific Northwest, and the Asia reporting groups on the left, and all of the other Alaska reporting groups on the right. And so walking through this, you can see in the left-hand panel that both the Northeast Asia and Eastern Gulf of Alaska, Pacific Northwest are typically the largest contributors to the bycatch. and they range from about 20% to about 55% annually. They also vary inversely related to one another. And so as the Northeast Asia reporting group goes up, the Eastern Gulf of Alaska Pacific Northwest goes down. And so they oscillate kind of inversely related to one another. You can also see that for the Southeast Asia reporting group, it varies, but not a lot. It's typically about 18% of the overall bycatch. And it's been consistent through time. In the right-hand graph, we can look at the Western Alaska component, and you can see that between 2011 and about 2019, it was consistently about 18 to 19% of the bycatch, but it was reduced overall in 2020 and 2021 to about half of that, but then bounced back up to one of the largest estimates in 2022. In 2023, we see again that it's one of the lower overall contributors to the bycatch, more similar to 2020 and 2021. For both the Upper Middle Yukon and the Southwest Alaska groups, overall, they are low contributors. They are often less than 10%. You can see with the Upper Middle Yukon that it started around 10% in 2011, but it's been reduced overall. The Southwest Alaska reporting group pretty much fluctuates from 2 to 5%. Again, this year it's at 2%, so pretty small contributor overall.
Dr. Berry, before you move on, I have a quick question. Do you know whether or not these seasonal observations are consistent with what we're seeing haul by haul or delivery by delivery as far as, is there a high degree of mixing at that haul by haul level, or would we see one haul that has a really high proportion of hatchery chum and another haul that would be, in a different time and area concentrated on Western Alaska chum? Thanks.
Through the chair, thanks for the question. So it's rare that we're able to compare individual hauls because there's a requirement that we have at least 100 samples. We can probably get by with about 75 to accurately estimate these stock contributions. And so as we start to reduce sample size, uncertainty in the estimates go up, and kind of the power to make these estimates declines. When we do have the ability to estimate individual hauls or individual deliveries for the shoreside sector, because often the shoreside sector, they make multiple hauls on a trip and then deliver to a shoreside plant. So we have kind of a mixture of hauls within those shoreside deliveries. When we do estimate those individual hauls, typically they look more similar to smaller aggregations of these statistical areas and weeks, but it's never going to be just a single reporting group. What we have never seen in our data, a single reporting group contributing disproportionate to like a smaller aggregation. So they're very similar to the smaller aggregations that we analyze on the scales of multiple weeks or like a few statistical areas. We did do a pretty elaborate investigation of this, I believe, last year and presented it. And so I think in a few years ago, there were independent scientific trawls that evaluated a salmon excluder device. And so we had pretty high power to do those individual haul level analyses. And again, we really didn't see any kind of disproportionate contribution by a single reporting group compared to kind of the overall analyses that we typically do. We can use those mean proportions and multiply them by the overall bycatch that occurs within the bee season to estimate the total number of chum salmon by year. And so here you can see that despite kind of there's a lot more variability in the estimated number of bycaught chum salmon by reporting group than the mean proportions because of the overall, both the variability in the mean proportion, and then you multiply that by the variability in the number of fish that are being taken as bycatch. But again, you can see that Here, the Northeast Asia and Eastern Gulf of Alaska Pacific Northwest are typically the two reporting groups that contribute the most fish to the bycatch. And that's been, it really increases from that 2013 to 2021 period when we saw that increase in bycatch overall. The Northeast Asia reporting group has been pretty consistent through time, fluctuating around 40,000 fish. If we look at Western Alaska on the right plot, you see that early on from 2011 to about 2013, overall, it was pretty low. And that's a reflection of the overall low amount of bycatch because the proportion between 2011 and 2019 really didn't vary much. But from about 2014 to 2022, the average bycatch of Western Alaska fish was around 50,000. That's greatly reduced in 2023. Overall, both the upper middle Yukon and Southwest Alaska reporting groups contribute very little to the overall bycatch. In 2017, there was that little bump, but pretty low contributors overall. We can start to break apart kind of the distribution of the bycatch and look at spatial trends. And so one way we do this is to analyze all samples that came from the west of 170 degrees west and those that were caught east of 170 degrees. And so these are results from those two different analyses. And so we're really comparing kind of this large scale spatial trend east and west of 170. You can see here that, in the west of 170, the largest contributors are going to be the Southeast Asia and Northeast Asia reporting group. And their contribution is much larger to those catches west of 170 than they are to east of 170. If we look at the Western Alaska and Eastern Gulf of Alaska Pacific Northwest, that's the exact opposite. So we see a much larger contribution from Western Alaska and Eastern Gulf of Alaska Pacific Northwest east of this 170-degree line. For the upper middle Yukon and Southwest Alaska reporting groups, there's a slight increase in the mean proportion. However, we see that those 95% credible intervals overlap. So there's really no statistical difference between them. So on a very broad spatial scale, we do see pretty distinct trends in the contribution of these groups to the overall bycatch. We can go a couple steps further, and instead of dividing things just in half, we can start to split these ADF&G statistical areas into these 4 different clusters that I mentioned earlier. We can also introduce a time component. And so here we have split the B season into the early and late season, and that division occurs at statistical week 32. And so that's pretty much exactly when 50% of the bycatch this year occurred. We can step through this plot, which is just the stock proportion over those clusters in the early on top and the late on bottom. For the Southwest or the Southeast Asia reporting group, there's a pretty clear spatial trend where they contribute much more to mixtures or bycatch that occurs in cluster 4 relative to clusters 2 and 1. For Northeast Asia, it's a little less obvious, this declining trend from the west to the east. They contribute a lot over all of the different clusters. So it seems like the Northeast Asia reporting group is dispersed over this over the pollock fishing grounds quite substantially, at least in the early season. You see that in the late season, the estimate for the westernmost cluster, cluster 4, is much higher than the late estimate for cluster 1. So there is a spatial signal that's pretty distinct in the late season. For Western Alaska, again, we see a pretty consistent trend in the spatial aspect. So an increasing contribution to the bycatch as you move from the west to the east. Again, we don't see a very strong signal from the upper middle Yukon or Southwest Alaska in either the early or the late period. Pretty much they're low contributors throughout. I will note, though, that you see that there is no bar for cluster area 3 in the late period, and that's because we don't have enough samples to do that analysis. It's not because they're zeros. And then for the Eastern Gulf of Alaska, Pacific Northwest, there's both a pretty strong spatial and temporal component to their contribution. You see a much larger contribution to the bycatch on the easternmost clusters compared to the west, and a little bit higher contribution in the late, particularly in that cluster 1.
Dr. Berry, a question for you, Ms. Kimball.
Just a quick question, and I think in previous documents, we were very used to seeing it broken out by early, middle, late temporal time periods. And so can you remind me what week you're dividing? I know it's in the document, but I can't find it. Between early and late, which week is that? Week 32 or week 34 or August?
Through the chair, thanks for the question. So the issue we have with, again, breaking out multiple different strata in both space and time as we start to erode that sample size. And so we do produce stock composition estimates for the early, middle, and late period with no spatial component to it. And so if we want to introduce that spatial component, we need to aggregate into both the early and late. And so it's consistently analyzed as statistical week 32 as the breakpoint for these early and late periods.
Thank you. And that, so through the chair, that's different than every year, what the actual calendar date would be, but that's around mid-August. Is that correct? Thank you.
Thanks for the question through the chair. So if I could roll back slides and I indicate it's late August, I think the 23rd this year, but because how we do statistical weeks, kind of when the year starts, the second statistical week is the next Saturday. So it fluctuates by a couple days every year. Okay, so to give you some context as to the variability among years, so this is these results are specific to the 2023 bycatch. If we want to contextualize these, kind of looking at the variability among years, we can, ignoring the uncertainty in those estimates, we can plot the mean estimate for each of these reporting groups for their time and spatial cluster, representing them as box plots. And so within these box plots, we have a very distinct line in the middle, which is the median estimate. And then the boxes represent the interquartile range. And so a large interquartile range suggests a lot of variation in that estimate. And anything that kind of falls outside of that and is represented as a dot is just an outlier. And so stepping through this, we have, again, stock proportion on the vertical. And so we have spatial cluster on the horizontal axis. And the early estimates are going to be in red on the left-hand side of their late period estimate on the right. So again, for the Southeast Asia reporting group, we see a very consistent spatial trend where we have large contributions kind of to the northwest in cluster area 4, which decline as you move east into cluster 1. We do see, on average, a slight increase in the mean estimate for this reporting group in the early period relative to the late for kind of cluster areas 3, 2, and 1. So typically they comprise a larger proportion of the bycatch in those areas early in the season. For the Northeast Asia reporting group, you can see that those box plots are really wide. So there's quite a bit of variation in their contribution. And if you think back to that plot for the overall bee season, we saw really large oscillations in their contributions from 2011 until 2023, which are kind of inversely related with that Eastern Gulf of Alaska, Pacific Northwest. And so this large amount of variation occurs because of that oscillation. We don't see a really strong trend in the mean. Looking at these clusters, they typically comprise a very large proportion of the bycatch overall, slightly lower contributions in cluster area 1 relative to the other ones. For clusters area 3 and 2, it kind of seems like the median estimate for the late period is smaller than the early. But again, there's really high variation in these estimates. We're going to skip Western Alaska right now because in the next couple of slides, we're going to step through that one in much more detail. For the upper middle Yukon in the lower left, you can see that overall pretty low contribution, less than 5% on average. We don't see a very strong spatial or temporal scale in this reporting group. Pretty high variability as well, but overall pretty low proportions. Southwest Alaska, there does seem to be a slight trend of increasing proportions as you move from kind of the western clusters, cluster 4, 3 to the eastern side. Again, we see a slight increase in the contribution in the early period relative to the late in cluster area 1, but not a super strong signal. For the eastern Gulf of Alaska, Pacific Northwest, there is a very, very strong temporal signal, as well as a pretty strong spatial signal where they contribute more to the bycatch moving from the west to the east. They generally contribute more in that cluster area 1 relative to 4. And you can see that the late estimates are much larger than the early, particularly in clusters area 3 and 2. So diving into the Western Alaska component a little bit closer. Again, we have stock proportion on the vertical axis and those spatial clusters on the horizontal. You can see very clearly that they contribute more to the bycatch in spatial area 1 relative to all the other areas. There is some variability in these estimates. And so here I want to highlight that these 3 outlier points represent the estimates from 2020, 2021, and 2023. And so those were the 3 years where instead of the Western Alaska component representing about 18% in the B season overall, that's when we see those drops. So in each of those years, the overall B season estimate was, on the order of about 8 to 10%. Whereas in all the other years, it was around 18 to 20%. But again, we can see a pretty strong signal in the spatial component, and then a lot of variation, but there is some evidence of them contributing more in the early period relative to the late, particularly in cluster areas 1 and 2. So it does seem like there is kind of a temporal component to their contribution to the bycatch, at least in cluster areas 1 and 2. We can multiply those stock proportions by the total number of bycatch of chum salmon within those spatial areas to get an idea of how many chum salmon from this reporting group are taken as bycatch. And so very clearly you can see that the total number of chum salmon taken in cluster area 1 is much higher than in all other cluster areas. And that is because there's a lot more fishing effort in cluster area 1 compared to cluster area 2 and 3. So kind of this subtle increase in stock proportions, however, because there's a lot more fishing effort in this cluster area 1 relative to the other ones, we see a much larger estimate overall for that number of Western Alaska fish caught. As I said, each of the different fishing sectors, so the 3 different processing sectors, the shoreside, mothership, and CP, have different abilities to disperse on the pollock fishing grounds. And some of that is specific to the type of vessels, but additionally, the existence of the CVOA makes it such that the catcher processors can't actually fish, right off the Alaska Peninsula in the B season, unless they're performing tows for the CDQ groups. And so both, regulation as well as kind of the dynamics of each of these sectors influence the spatial distribution of their bycatch. But here on the left, I've plotted the average location of their bycatch for the 2023 season. And so you can see a very distinct difference between both the catcher processor and mothership sectors relative to where the shoreside sector picked up their bycatch. On the right-hand side, we have plotted the stock proportion for each of the sectors, for each of the different 6 regional groups. You can see that for both the catcher processor and mothership sectors, the Southeast and Northeast Asia reporting groups contribute a lot more to their bycatch, and that's most likely a product of where they are fishing relative to the shoreside sector. Additionally, the shoreside sector, both the Western Alaska and Eastern Gulf of Alaska Pacific Northwest reporting groups contribute a much higher proportion to its bycatch. Again, most likely because of this difference in spatial distribution. We can multiply those stock proportions by the estimated number of fish that each of these 3 different processing sectors encountered to get an idea of the estimated number of fish that each of the different processing sectors caught from the regional groups. And you'll see that despite kind of the larger proportion of Southeast and Northeast Asia reporting group by the catcher processor and mothership sector, the total number of fish from Northeast Asia for the shoreside sector was much larger despite that difference in proportion. And that's just because of the difference in magnitude of bycatch. Again, we see that the shoreside sector with a higher bycatch number also caught more Western Alaska and Eastern Gulf of Alaska Pacific Northwest fish.
Dr. Berry, this might be apparent in there, but I'm not quite seeing it. Are you able to break out the Western Alaska component from the CP contribution in the CVOA versus other clusters, or is that somewhere further on in your slides or information? Do you understand my question, or do I need to repeat it in a different way? Okay. Are you able to delineate the Western Alaska component of chum that's caught by the CPs in specific to the CVOA relative to other clusters? Does that make sense? Thanks.
Through the chair, thanks for the question. I think it makes sense. So you're asking if we can run an analysis that is specific to the CP sector, comparing the contribution of each of these reporting groups to its bycatch between the CVOA and all other areas. So we've performed retrospective analysis for council staff to estimate the contribution of each of the different quota groups. So breaking out the CDQ group from the CP and mothership and shoreside sector. Typically, the CDQ group's bycatch is caught by the CP sector. And so we weren't able to do that analysis for a couple of years. I'm not sure there are enough hauls by the CP sector when they are fishing for the CDQ group to do a specific analysis within the CVOA. But I think that the analyses that we do that are that don't break out each of the different sectors, but that look at the individual cluster area and time, can probably be used to inform some of that. I could definitely look into our ability to break out those with the understanding that we can't do it if the sample size falls between our minimum requirements. One thing that we have been asked to do by C-State, who manages the rolling hotspot closure system for the pollock industry, is to reanalyze some of our spatial strata. And so often we produce these estimates for the 4 different clusters for 2 different time periods. And they had suggested that those don't represent the pollock fishing grounds as well as they could. And so they redefine those statistical areas into these 6 different fishing grounds. And so we've reanalyzed all of our data and passed those off to help inform the rolling hotspot closure system. So here I've represented again the pollock fishing grounds, and they're all colored by these new fishing ground specific areas. The issue again is as we start to break up those spatial areas more and more, we're not able to analyze all strata every year. And so you see that in orange, kind of at the top of the Unimac and shelf edge is the shelf, and not a lot of bycatch occurred from that area. And so we weren't able to analyze that this year. There aren't huge differences either. So I'll say that these individual fishing cluster areas that were developed by the Auk Bay labs, I think around 2014, were informed by an analysis that was conducted looking at kind of the economic and climate drivers of the pollock fishery. And so these clusters that we analyze are based on kind of an analysis in the literature and generally reflect some of the considerations for the pollock fleet. You'll see that they don't really differ substantially. There's kind of a breakout of cluster area 4 into the Zemchug and Provenance Canyon. And then that shelf edge is broken off from cluster area 1. But overall, the trends that we see in both space and time are pretty consistent between these fishing ground analyses as well as the clusters. And so again, with the Northeast Asia, relatively large contributor overall fishing grounds, slightly decreased in the Unimac area relative to the others. The Southeast Asia reporting group, you can see a pretty consistent decline in the relative contribution as you move from west to east. Western Alaska, very clear signal moving from Provenance Canyon in the west to Unimac in the east. Upper middle Yukon, you'll see that there is slight differences in the mean estimate, but because of the confidence intervals around that, there are really no statistical differences. That's similar to Southwest Alaska. Those credible intervals are very large. And that's also a byproduct of breaking up these statistical analyses into smaller and smaller sample sizes. The uncertainty around those estimates will grow. But very consistent signal of that space with the Eastern Gulf of Alaska, Pacific Northwest, from Provenance Canyon in the west to Unimac area in the east.
Question for you, Dr. Berry. Ms. Kimball.
Thank you, Madam Chair. I just hadn't focused on this slide very much, but now I am. And so I recognize the scales are different for each of okay. But if I still wanted to focus on our Western Alaska component and the upper middle Yukon component, it's solidly in the Unimac area where we're talking about a higher trend toward catching more Western Alaska fish in Unimac area. And there's quite a distinction then when you start to include the shelf and the shelf edge, where I wouldn't really make that same statement. Is that correct?
Through the chair, thank you for the question. So looking at that Western Alaska component, the Unimac area is much higher. So the credible intervals don't overlap with any other area that we're able to estimate. We weren't able to estimate that shelf area in orange. So there's no orange bar there. The estimates for the shelf edge, Pribilofs, and Zebchug Canyon, there's a slight increase in the mean proportion, but because we're breaking things out into smaller and smaller chunks, the confidence in that estimate, the credible interval, gets larger and they all overlap. So there's no statistical difference between those estimates. So we're not seeing any kind of consistent difference in kind of that spatial aspect there. We do see a statistical difference though from Provenance to Unimac. And I think from Provenance to the shelf edge. So shelf edge is larger than the Provenance Canyon.
Thank you. So very crudely, I'm just adding up all the green bars and adding up all the pink bars and looking at quote unquote whether I should kind of care about bycatch in those areas because it looks pretty solidly non-Western Alaska, non-upper and middle Yukon. Okay, thank you.
And so I think
Sorry about that. We have another question. Mr. Down.
Yeah, thank you, Madam Chair. Thank you, Dr. Berry. when I'm looking at the scrap, just before we go on, I can see pretty clearly why you left the shelf off of the colored bar graphs. But it would seem like something would show that there's some catch there. Is it just because those numbers are so close to zero, it was a decision point? Or I'm just wondering, I was kind of following this along with Ms. Kimball's question as to when I look at that, why seemed to me like the area would be the yellow area and the orange area, and the orange area is not shown in the bar graphs. Is that because we should just kind of assume that's pretty much zero, or why is that?
Through the chair, thanks for the question. So there is bycatch that occurs, and that's represented in those circles. With the circles, the diameter is proportional to the overall bycatch. But because we have systematic random sampling, we sample 1 in 30 chum salmon. So we do have some genetic samples from there, but it falls below that minimum number of 75 fish that we use to estimate the stock composition estimates. So we don't have the power to accurately estimate the stock proportions with a sample size less than 75 fish.
Yeah, thank you, Madam Chair. A follow-up question, Dr. Berry, then. Is that just 2023 that you see that, or is that consistently?
Through the chair, thanks for the question. We are able to make estimates for the shelf in other years. And so it all depends on kind of the distribution of the fleet within the fishing grounds. And so I believe for 2022, the shoreside sector they encountered more of their bycatch further to the east and northeast. So there was a lot more fishing effort in that area. And so with the 1 in 30 sampling, we had enough samples to make those estimates.
And Ms. Kimball.
Thanks. This was based on Mr. Downs' question. Did you see the same trends in previous years that you applied these kinds of spatial refinements to?
Thanks for the question. Through the chair. They're pretty consistent trends over time. I haven't plotted the full time series for both the kind of the overall bee season as well as the early and late. These are analyses that we perform each year, kind of on a short time scale. So we're still receiving samples in our lab. It could be like late January. And so we process the 8,000 plus genetic samples, analyze all the data, and try to get a report for your consideration by these April council meetings. And so I haven't looked at the consistency of the 2023 data for this analysis relative to all other years, but that spatial signal is pretty consistent for at least the data over which I've looked at it.
Thank you, Mr. Twite.
Thank you, Madam Chair. Appreciate the line of questioning. It's helping me see something. Dr. Berry, the genetic cluster 1, 2, 3, 4 construct is a relatively new attempt to begin to give us a clear picture of the spatial distribution. But I'm wondering, based on, as I think about your answers and the questions on this chart, if we should actually already be moving beyond that sort of interim attempt with 1, 2, 3, 4 and more and towards an even more finer grained approach such as you're proposing here, recognizing, as you point out, that leaves you vulnerable in some years to issues of just not enough samples for whatever reason. So what I'm asking is, how much utility really is there to genetic clusters 1, 2, 3, 4 when you're really showing when you're already showing that at least on some years it's really a much finer, it's an even finer grained spatial pattern.
Through the chair, thank you for the question. I guess it goes to kind of the uncertainty in these estimates, right? And so as we break things down into these finer scale clusters, you can see that kind of the air around them starts to expand. And so we might see differences in the mean proportion as all the credible intervals overlap. That's something that we see at least here with kind of the middle areas within Western Alaska, right? So we do see a difference in the shelf edge, which is a larger proportion, but because of the uncertainty estimates around that mean proportion, there's really relatively no difference in the Zemchug or Pribilof estimates. And so I think we analyze these data at different spatial scales, starting at kind of the aggregate of the B season overall for the Bering Sea. And then we can take that one step further and split it down the middle into that west and east of 170. And I think they're complementary analyses, not necessarily, we need to move away from the other analyses, but I think that by performing each of them, it adds to the analysis to help inform you all to the relative scale of the variability in these estimates and kind of the interannual variability in the trends that we see.
Thanks. I appreciate that. But I guess I'd like to push back slightly. As we really try to stay focused, in particular on measures that will have the most impact, the most benefit for Western Alaska, there's relatively little information for us when we, for instance, look at the B season as a whole across the Eastern Bering Sea. It's interesting, but it's not particularly relevant. And in fact, if we only looked at that, we could end up allowing fisheries to proceed in areas that had, without ever knowing it, without ever being able to really assess our performance, we could continue to have much higher impacts on Western Alaska stocks of chum than a similar level would have in a different year based on differences in the interannual. So it's not a piece of information that is helpful. And in fact, it's a piece of information that we could end up patting ourselves on the back for reducing the overall chum catch, but not changing or even perhaps having a higher impact on Western Alaska. So we go from that type of information what's my question? I'm really struggling with the presentation at different spatial levels. In terms of, because it's not chum, it's Western Alaska chum here. And so I guess I'd like your thoughts on the value of starting, as you described, starting off with the overall picture and then bringing it down. Is it really the right place to even start off? I guess is my question. With overall chum, shouldn't we be going right to the a level of spatial and temporal granularity that gives us the information around Western Alaska chum in time and space? Shouldn't we be starting there?
Through the chair, thanks for the question. I think I know where you're going. And there is absolute value in doing kind of this overall B season estimate. I think that when we do that estimate, we have representative sampling, an amazing effort into having this representative sampling over the entire B season, representation over space and time. And so when we make those estimates, we're including all of these areas, right? And so we have a very accurate estimate over the number of Western Alaska fish, right? So when we do these smaller analyses, we're leaving off areas in the shelf. There is bycatch from there, but we don't know what the Western Alaska component is. So I would say that for an accurate estimate of knowing our relative impact on Western Alaska, that overall estimate is critical.
Thank you. Ms. Carroll and then Ms. Kimball.
Yeah, thanks. Through the chair, Dr. Berry, I actually really do like this analysis by area, but I get what you're saying, that you could look at these bars, think there's a trend, but your confidence intervals indicate there's not. but we had incredibly low catches of chum in 2023. And so I guess I'm wondering, maybe for a future presentation, would you be able to go back? I believe you take genetic samples every single year, right? We've got pretty low abundance of Western Alaska chum right now. That could be related to the very low catches and very low sample sizes. Could you go back to some of those higher years and start to see if this trend exists in those years, or whether we're seeing, shifting around? I mean, that would be really interesting to look at by these same areas. Because if like Ms. Kimball was pointing out, if the UNIMAC is a honed in area, then we should see that same trend in those higher years when the bycatch was up, when our runs were in the millions. So that'd be a really neat analysis to do. Just continue to look at these areas, but go back into your years when you probably are going to get larger sample sizes. And then a follow-up question would be kind of related to the way you were going there with Mr. Twite's question is, can you, okay, if we're looking at the whole bee season catch as a whole, we've got to do that. And then you're breaking it into these tiny areas or these stat areas. But for instance, let's say the whole point is if someone wanted to reduce fishing in the UNIMAC, thinking that would save Western Alaska, by doing that same analysis of the higher years when we did have the higher Western Alaska sample sizes, we could then also see in those exact years, do we also see these very large catches of the Asian fish? And so then it would start to, I think we would get to see if that trend is consistent. So instead of this 1 year approach compared to historical, look at 4 or 5 very high years and then see if these trends exist. That'd be a slide I'd be really interested in seeing. Future.
Through the chair. I guess I'll address the first question. I'm not sure I got the second question. So we have performed all these analyses from 2011 to 2023. There's very little time to include everything in these presentations. And so if all of this will be covered in our annual technical memo. And so it seems like there's a lot of interest in these fishing ground analyses. So in this year's annual tech memo, I can definitely make sure to include kind of a historic analysis and go through the fishing grounds compared to the clusters. That's something we're able to do. And so there's a trade-off between, complexity of the technical memo and presenting the fishing grounds broken out by time period. And so we're trying to reach this balance of what to actually present to inform you all on these decisions. But that's something I can definitely include in the next iteration. And if the council would rather see these fishing ground analyses versus the cluster analyses, that's definitely something that we're able to do.
Okay. Thank you, Dr. Berry. I think we'll be able to expand on this discussion a little bit too in our main presentation on the draft EIS. We'll see some of that more historical perspective from my understanding. Ms. Kimball.
Yeah, I think just in part, all I wanted to ask was, would we see this same breakout for 2024? Like, do you expect to put this forward annually in each genetic report? Because I think you're getting from the council how useful it is in potential decision-making analyses. And it's very easy for us to forget that this is a genetic report on 2023, it is not a decision-making document by any means. And what we're getting is a taste of what's available to then use for analysis in a DEIS or in some other document in order to inform decision-making. So I think it's a testament to the work that you're doing that it's becoming so much more useful and practical for management. But I'm taking very seriously the comment that this is a 2023 genetic report. And I'm just asking, would we see this same level, given the interest in 2024 going forward? So we'd break it out by pre-season, cluster, and then the actual kind of more fishing areas that the industry would delineate.
Through the chair, thanks for the question. Absolutely. We perform these analyses, and as we're making them at the end of really at the start of April, we're in touch with C-State as well, and we pass off all of these analyses so that they have the most recent genetic data to help them as the next bee season starts. But yeah, absolutely. Continuing forward, we will perform both the fishing ground and then the fishing ground broken out by early and late. So those are analyses that we do every year now. Yep.
Thank you. Ms. Carroll?
Thank you. Through the chair. Sorry to reiterate what my second part question was supposed to be about is if you had done that historical analysis in years when we have more samples and you could determine that there was a statistical significance and maybe there were higher catches of Western Alaska or upper middle chum in Unimac, for instance, to deal with that sample size issue where you have the shelf versus the shelf edge, and so we can't break those out. Could we then, if we determined in high abundance years there is an issue there, could we then switch the sampling instead of being that every 30th fish to hone in some newly improved sampling just by fishing area? Because then that might be a way to shift the costs of that widespread sampling and hone it in on an area. Would that be something that's possible or something? Maybe you thought of it already.
Through the chair, thank you for the question. So we have thought quite a bit about the sampling design, and it's something that the SSC has talked to us about. It's hard to have a variable sampling rate for the observer program because during deployment, I don't think the skipper might have an idea of where they might be fishing on the grounds. But to change the sampling rate for an observer on the fly, if they're going to a particular fishing ground, it may be very difficult. And I'm not sure that FMA division wants to try to integrate a variable sampling rate. It might confuse observers, and the overall the power in this systematic random sampling is that we have a very good estimate for the overall number of Western Alaska fish that are encountered. And so if we introduce a variable sampling rate, we'll then have to make sure that when we receive the genetic samples in the lab, we then have some kind of way of systematically making the oversampling and the undersampling that occurs representative of the overall bycatch. And that's something that could be done. But again, the time frame at which we're making these estimates, we're receiving samples up until January and then have to extract all the DNA, amplify markers, analyze it, and write a report. It's a pretty large task. And so adding another layer of complexity would either increase the turnaround time or potentially decrease the quality of the work that we're producing.
Thank you, Dr. Berry.
One thing that was brought up to us recently was the idea that returns in Kotzebue Sound for chum salmon were kind of different than the overall abundance of Western Alaska from Norton Sound south to the Nushagak. So there's some evidence that these Kotzebue Sound populations, their abundance was increasing despite the catastrophic declines across most of Western Alaska. So here I have plotted the harvest of chum salmon, the number of permits fishing, and the harvest per permits. And so the harvest per permits can kind of be thought of a catch per unit effort, which occasionally is proportional to the overall abundance of a population. And so you can see here with that harvest per permits on the bottom, there is a trend of increasing kind of harvest per permits through time from 1960 to 2023. So some indication that the abundance of Kotzebue Sound might be increasing through time. When we switch from our genetic baseline that we used from 2011 until 2019, previously we didn't have the ability to break out this Kotzebue Sound population. When we switched to the new SNP marker panel that was developed specifically for Western Alaska, we gained the ability to break out just this Kotzebue Sound populations. So we can't break apart Western Alaska more than what we're showing here. So to investigate this, we now estimate the contribution of Kotzebue Sound relative to other areas of Western Alaska. We don't just show you this at the start because we have a long-term time series from 2011 to 2019 where we don't have this ability. So to make historical comparisons, we keep this Kotzebue Sound reporting group rolled into the coastal Western Alaska group. So looking at the B season estimate for the Kotzebue Sound area, again, I have kind of this plot of each of the different reporting groups and their stock proportion. Here we have Kotzebue Sound in light purple. You'll see that Kotzebue Sound in the 2023 analysis was about 1% or just over 1,000 fish, which is a pretty low contribution to the overall bycatch. So as we pull out that Kotzebue Sound, Western Alaska drops to about 7%. So not terribly surprising. It's still about the same percent. If we look at the contribution of this Kotzebue Sound through time, from 2020 to about 2022, there is some evidence of an increasing contribution of Kotzebue Sound relative to Western Alaska. So there was some evidence to suggest that this population or groups of population were increasing in abundance and their relative contribution to the bycatch. But then in 2023, that contribution dropped pretty dramatically. If you look back at the harvest per permits, there is also a drop in the harvest per permit. So, it might be large variable population sizes, and this is reflected in the contributions, but this could also be kind of reflective in the overall distribution of the bycatch. We did see a huge shift in both the catcher processors and motherships to the northwest. And so disentangling those two kind of effects of both the fleet's behavior as well as kind of the variability in chum salmon population abundance, we can't really do that. So we will continue to do these types of analyses with the understanding that for the overall time period where we relied on this other baseline where we can't pull it out, we'll still roll Kotzebue Sound into this Western Alaska group going forward for the overall B season estimates that we produce. In summary, for the 2023 chum salmon bycatch, overall, it was a lower number in total bycatch that was encountered. Additionally, it was a lower proportion of Western Alaska chum salmon. So if you combine both the Western Alaska and Upper Middle Yukon groups, it was about 11% of the total bycatch, which was just kind of under the 12,000 chum salmon that were encountered. We do see a consistent trend of greater proportions of Western Alaska fish in the easternmost fishing grounds, that Cluster 1 and Unimac area. And the shoreside fleet definitely had the highest proportion and number of Western Alaska fish, most likely because of their spatial distribution. So I think that is the last I have for chum.
Oh, excuse me, Mr. Sakata.
Yep, thank you. Thank you through the chair. Thank you for the presentation. I'm just trying to get a feel for using the numbers. Okay, 12,000. I noticed in slide 9, your the different 6 genetic reporting groups, which are listed in Appendix 2, Table A2. Looks like Western Alaska and Middle Upper Yukon shows something on the order of 110-ish. And I was just kind of counting them, so I don't have it exactly. Different populations. So is not foregoing things like AEQ and other things. Is it my understanding then that I could take those 12,000 chums and the average number of chums per population would be the 12,000 divided by this 110, or and of course that's not accurate because you have much larger systems like the Yukon and frankly those aren't listed in this table because I'm sure it's the tributaries. I'm trying to get a feel for the dispersion of these Western Alaska chums. Yeah, can you maybe address that? Yeah, exactly.
Through the chair, thanks for the question. So when we consider the genetic baseline in these graphs with the Western Alaska group in the upper right colored in yellow, so this genetic group has, as you said, quite a few genetic collections that the Alaska Department of Fish and Game went and collected. And so they're the genetic collections are a representation of the genetic variability for this region in general. And so there are genetic similarities among populations that are close geographically. And so despite the fact that we might be missing populations that exist, the populations that we do have in this genetic baseline are a good representation of ones that don't exist in our baseline. And I don't think we have, a great understanding of chum salmon population abundances for all of these populations or the ones that are unsampled. But when you look at that B season estimate of, 9,246, and that estimate has uncertainty. There's 95% credible interval going from 8,000 to 10,500. And so those Western Alaska fish most likely originated from, river systems that are characterized in this map, not necessarily those individual populations that are in the baseline. So do we know exactly where those, 9,240 fish originated? No, but I think that it's safe to say that, from Kotzebue Sound down to the Nushagak and extending up the Yukon to, I think the break point is like the Salsha-Chena area. They would have, barring natural mortality or any other, natural mortality that would have happened in the ocean, they would have likely returned to those regions. We can't say with any certainty, if 80% of them would have gone to a particular watershed within that. And so we don't have the ability currently to break up that kind of coastal Western Alaska reporting group, but there are efforts right now to develop new genetic markers to help break those apart. And so the genetics program has an application for a grant to use new genomic techniques, low coverage whole genome sequencing, to try to develop markers specifically for that region, to try to start to break apart like Norton Sound from the Kuskokwim, from the Summer Run Yukon. So there is a lot of interest in trying to break up this Western Alaska component further. There's been a lot of effort in the past, and it's a very important line of research, but we're currently not there yet.
Do we have an idea whether, I was trying to look at the anadromous stream mapping project, whether the total number of anadromous streams that have been identified as holding chum salmon, how that is relative to the 300 the populations that are represented in this? Is it more? Is it, well, it's got to be more, I would assume, because there's unsampled, but do we have an idea of what the magnitude is?
Through the chair, thanks for the question. I failed to mention this. So the Alaska Department of Fish and Game's Gene Conservation Lab has just updated this genetic baseline that they use. And so we're using the most recent genetic baseline that the Gene Conservation Lab has updated with increasing numbers and representation in Western Alaska. So they have recently gone out and identified certain streams that weren't represented in the baseline. So it's kind of an iterative process of identifying potential streams that are missing and then going out and collecting, a representative sample. It requires at least 100 fish to represent one of these collections. And sometimes, you might want to compare among years for a particular stream too. So they'll go out and repeat sample. And so if there are changes in the genetic kind of composition of a stream, then you can either update the representation within the baseline, or if there's not a big difference, you can just roll those samples into the existing baseline. Did that answer your question?
Yeah, I think it did. So just finally to clarify, the number of Western Alaska chums identified as being caught in bycatch, the average. No, I guess that's not correct. No, okay, I'm going to rescind that. I think you answered my questions correctly. Thank you.
Through the chair, I think so. I think the idea is that could we use this number from Western Alaska and then just divide by the total number of populations in the baseline to get an idea of the average number of fish that would have returned to a given system in the absence of any natural mortality or bycatch? Is that the question?
Yeah, that's
I think, we don't have a really good handle on the number of streams that are potential contributors to, the Western Alaska reporting group. I think, we do have as you said, the ADF&G produces the anadromous fish catalog where they go out and sample streams to find out if there is representation from a certain Pacific salmon species within the stream. There are just so many streams that are probably unsampled that and then like you said previously, there are certain streams that are much larger producers, like the available spawning habitat in certain streams is probably orders of magnitude larger in certain systems than others. And so, I think it's probably unwise to just make a division.
all right. Thank you very much.
And Mr. Curlin. That wasn't on purpose. I think you're unplugged there.
Thank you. Madam Chair, Dr. Berry, this relates to your first answer to Mr. Sukata. You alluded to the lack of abundance level information for these different chum populations. And maybe a naive question, but I wonder if you could give me a sense of how we should view this genetics information in light of changes in abundance over time. In other words, if marine survival of Western Alaska chum were twice as high or 3 times as high, should we expect that we would have seen kind of proportional results here in your analysis?
Through the chair, thank you for the question. So I think that these proportions are definitely an indication of both the relative abundance of these genetic groups, but also, as I show in some of the spatial and temporal analyses, they're definitely informed by where the fleet is fishing as well. And so if you look at the time series for these groups, you'll note that we do see a big drop from 2019 to 2020, and that coincides with kind of the really low abundance or the indexes of abundance in Western Alaska. So there's definitely a correlation that we see between the contribution of Western Alaska in the bycatch and the overall indices of abundance that we have. However, if you look at the 2020 estimate, so if you look at the 2020 estimate, I don't think that you can say that Western Alaska has potentially increased in abundance in 2022. In fact, we really don't see that in any of the indices of abundance. But it's the second highest, contribution to the bycatch over this time period. In that year, we also see the shoreside fleet fishing much further to the east than they did in previous years. And so there's definitely a signal of relative abundance, but it's also informed by where the fleet fishes. I'll add that in future years, with an increase in relative abundance of Western Alaska fish, we would expect the estimates not to stay at this 8%, but return to the estimates that we see over the course of the longer time period, which was about 18 to 20%.
Okay, thanks for that. And so relatedly, like we see bycatch numbers down this year, but I guess how should we be viewing that relative to sort of fleet performance and efforts to avoid bycatch versus just sort of tracking the overall trends in abundance?
Through the chair, thanks for the question. My specialty is in genetics, and I am not really an expert in fisheries management. And so I would probably defer to somebody that is more of an expert.
That's a fair answer. I apologize for the question.
Thank you, Mr. Carlin. Thank you, Dr. Berry. I think we're ready to move on to Chinook. Thanks.
For Chinook salmon, we did the reports for both the Bering Sea and Aleutian Islands, as well as the Gulf of Alaska in a single report this year. I don't have any slides on the Gulf of Alaska, but as I said, I'm more than happy to take questions about it. I think there's maybe one bullet point at the very end. For this report and presentation, the report is a full report. For the presentation, we just have a few slides that go over the major trends through time. So we'll just start with the total number of Chinook salmon as bycatch through time. So again, we have the Chinook salmon bycatch in thousands on the vertical axis, and time in years on the horizontal. And so here I've plotted the bycatch of Chinook salmon for the total, the A season and the B season, with an indication of kind of the time period pre-Amendment 91 and post-Amendment 91 with a vertical dashed line. You can see that overall there's pretty high variability early in the time period and overall Chinook salmon bycatch. And you can see that in the A and B season total bycatch, those fluctuate pretty greatly, with neither the A or the B season being the majority of the bycatch each year. So in one year, there might be more bycatch in the A season relative to the B season, and then it flips. And that's pre-Amendment 91. Post-Amendment 91, with kind of these regulatory changes, we see an overall reduction in the overall bycatch, and a consistently, we see more of the Chinook salmon bycatch in the A season. And each of those horizontal lines represents the mean over that time period. So you can see that pre-Amendment 91, on average, there were about 40,000 Chinook salmon taken as bycatch. And then post-Amendment 91, it's about half of that at just over 20,000.
Yep. Thank you, Mr. Twight.
Thank you. Thank you, Madam Chair. Dr. Berry, I have sort of a nitpicky question / point. I think it's really important to show the impacts of the techniques that were used to actually minimize bycatch with the Amendment 91 sort of framework, but actually I'm wondering if you're drawing, I know you're drawing the right line in terms of the actual date that Amendment 91 took effect in the rule books, but actually the industry began using many of those techniques a year or two earlier. As I said, it's nitpicky, but it does actually affect kind of how you calculate the average for the pre. And I'm wondering if just a bit of discussion with industry, as well as council staff analysts about when that right inflection point really is. Because at least from my perspective, the techniques that they were beginning to implement before the regulations were actually in place are essentially the same techniques they use throughout the regulations. And what we're really trying to measure is the effectiveness, not of the rule, not of the actual Amendment 91. We're trying to measure the effectiveness of the actual management measures that are implemented, correct?
This also might be a question for the next presentation as well. Thank you for that, Mr. Twite. But point noted. And maybe we can move on unless you have another question on the slide. Okay.
Thank you for the question. Duly noted. Again, we can graph the spatial distribution of the Chinook salmon bycatch. And so here I've broken it out by both the A season and B season. Again, we have the CVOA here represented in green. I've also included the maximum sea ice extent in A. And so that's that white area that is kind of to the north. You can see that in the A season, the spatial distribution of the bycatch is really centered close to the North Alaska Peninsula, kind of in the upper right-hand corner of the CVOA, but there's still some bycatch that occurs kind of south and east of the Pribilofs. As I said before, the A season bycatch was much larger. So while the scale of the circles is the same, they are represented by different numbers, with the maximum size of the bycatch in the A season being represented by 2,300 versus 300 in the B season. In the B season, the distribution of the bycatch over the fishing grounds was much more diffuse, but the largest bycatch did occur within the CVOA. For the Chinook salmon estimates, we can break the reporting group, break the baseline into 11 different reporting groups. I won't go over each of these in detail, but they're represented by Russia, coastal Western Alaska, a middle Yukon and an upper Yukon group, so we can break those two apart. The North Alaska Peninsula, Northwest Goa, the Copper River, Northeast Goa, coastal Southeast Alaska, British Columbia, and West Coast US. And so for the A season, as I said, the bycatch of Chinook salmon was largest in the A season, just over 10,000, of which we analyzed 1,002 samples. And so here again, we have the estimated number, the confidence interval around that number, the mean proportion in its credible interval, that P is equal to 0 statistic, which gives us an idea of if the mean estimate is actually 0, and then an idea of how well our estimation method worked with SF, or the shrink factor. And so you can see that in some of these estimates, there are positive values for P is equal to 0. So that means that there is some probability that the mean is actually 0, despite the confidence interval potentially expanding to a positive number. And so for that Russia estimate, we see that the upper confidence is 11 fish, but there's an 84% chance that it's actually 0. So it gives us an idea of, if 0 is actually 0 or not. And so the largest contributor to the A season bycatch was coastal Western Alaska at 50%, or about 5,000 fish. And that was followed by the North Alaska Peninsula at 25%, or 2,700 fish. The third largest contributor was British Columbia at about 19%, which equated to just under 2,000 fish. So those are the three largest contributors to the A season bycatch. For the B season, again, much lower bycatch overall at 1,200. We analyzed 104, so our ability to start to break apart the B season into different spatial and temporal strata is much less because of the overall sample size. Here we can see that the major contributors are BC at about 39%, or 482 fish, coastal Western Alaska at 30%, or 378 fish, and West Coast US at 19%, or 235. We can look at the time series of the stock composition for both the A and the B season to get an idea of the relative fluctuation in the contribution of these reporting groups. So for the coastal Western Alaska group, which was the majority of the A season bycatch, you see that that's typically the main contributor to the A season bycatch and fluctuates, up to 50% in most years. That's followed by the North Alaska Peninsula. You can see that from 2022 to 2023, there was a relative large reduction in the overall North Alaska Peninsula, but this new estimate is more in line with what we've seen historically. There was an increase in the British Columbia contribution from 2022 to 2023. But again, that estimate that we see in 2023 was more in line with the estimates from 2017, 2018. If we look at the B season, again, we see that the British Columbia is the main contributor, and that's true pretty much across the entire time period. Sometimes West Coast US is a much larger contributor. But pretty consistent trends through time. The one big thing that we do see is the relative decrease in the coastal Southeast Alaska contribution. Typically, it's much larger, and we see a larger reduction this year relative to last. But that is probably a reflection of the overall abundances. Coastal Southeast Alaska Chinook salmon populations are obviously declining. And so we see that in the stock composition estimates. A quick summary of the Chinook salmon. So for the A season, 95% of the bycatch was attributed to the coastal Western Alaska, North Alaska Peninsula, and British Columbia reporting groups. The middle and upper Yukon were a very low proportion, less than 1% in number of fish. The B season, British Columbia, coastal Western Alaska, and West Coast US were the majority of the bycatch at about 88%. Again, the middle and upper Yukon were a very low proportion and number. There was an 82% chance that 0 fish were caught. And for the Gulf of Alaska, which I haven't shown here, there was a high probability that no fish from coastal Western Alaska, middle or upper Yukon, or the North Alaska Peninsula were caught. And that's pretty consistent among years. One new development in our lab is that we'll be moving to a new Chinook salmon baseline next year. And so we're moving from a marker set that uses 37 SNP markers to one that has 299. And the main development here is that we're able to break out the lower Yukon River. And so currently we're able to break out the upper and middle components, but now with this new marker panel, we're able to break out the lower river. And so there's a large collaboration between many labs, including the Gene Conservation Lab at ADFNG, DFO Canada, and NOAA. Some of the southern populations have already been genotyped by other labs. We're identifying populations that are lacking and filling in those genotypes and starting to kind of optimize the panel. Right now, the marker set stands at 299, but because we're combining genotypes from multiple different labs, this is probably like an overestimate of the final marker panel. It's probably going to end up being around 260 to 270 markers, but still with that ability to break out that lower Yukon River reporting group. And so I'd like to acknowledge really the fishery observers. So there were over 60 observers deployed sampling over 8,500 hauls and deliveries. It's a Herculean effort to get us samples from all of these fish. And then FMA does a great job of debriefing all of the observers, collecting the genetic samples, shipping us genetic samples, and kind of making sure that all of the fishery dependent data is collated and QC'd before it's aggregated by the Alaska Fisheries Information Network, ACFIN, which manages our database and pretty much allows us to turn around these analyses on a really short time frame. We also collaborate quite intensively with the Gene Conservation Lab at ADF&G, particularly on developing these baselines and kind of the tools that we use. So with that, I take any more questions.
Thank you, Dr. Berry. Ms. Kimball.
Thank you, Dr. Berry, for that presentation. It wasn't in this PowerPoint, but I think I recall that the Observer Program did meet the sampling goal for Chinook. 1 out of every 10 Chinook were sampled. And then was the ability to genotype those also that rate or just below that rate? Did we meet our goal, I guess, in terms of samples, which I know was much higher than chum?
Through the chair, thank you for the question. So here is the actual Bering Sea and Aleutian Island genetic sampling of Chinook salmon by week. So the goal for Chinook salmon is 1 in 10. And so you can see that here I plotted the black line, which is the goal, and the red dash line, which is what they did. And they pretty much are right on top of one another. So very little undersampling for a couple of different NIM statistical areas. There was pretty high oversampling for NIM statistical area 521 in like week 29, but overall it was a really small amount of the bycatch. So they did a really, really good job of sampling Chinook salmon.
I have just 2 more. I'm kind of quick. It's exciting to hear about breaking out the lower Yukon River. And so would we continue to see the tables as you had it and have lower, middle, upper still delineated? There wouldn't be any kind of combination of those once we see the data?
Through the chair. Correct. In the tables, we'll break out the lower Yukon River. I think in kind of looking at the historic trends over time, we'll still kind of roll that estimate into the coastal Western Alaska reporting group so that you can see the trends over time, because we don't have the ability to break it out for, the 2011 to 2023.
And then my final question is for 2023, I'm reading that the total for the middle and upper Yukon, the total number of bycatch from those systems was 27 individual fish, with a 80% probability that that's an accurate number. It just seems very low. I think the coastal Western Alaska component seems really similar to previous years. We're always expecting to see about half of the bycatch from the full coastal Western Alaska group, but the 27 fish from the middle and upper Yukon combined seemed very low. So I just wanted to ask a little bit about that.
Through the chair, thank you for the question. Yeah, so in the A season, here we have the estimated number. So the middle Yukon, we estimated that there were 0 fish, and there is an 81% chance that it is an actual 0. For the upper Yukon, it's 27 fish with a 95% credible interval going from 8 to 79. So they are very small estimates for the A season. And then looking at the B season, very high probability that those are actually 0s.
Not seeing any further questions. Thank you for your presentation, Dr. Berry. So before we move on, I think we'll take our mid-morning break. We'll come back at 10 a.m. and resume our presentations on C2. Thank you. Council members, please come back to order. Okay, we are continuing our discussion on agenda item C2. We have Dr. Hoppala back up with us.
Thanks, Madam Chair. Good morning, members of the council. Again, for the record, Kate Hoppala with council staff. With me is Dr. Diana Stram and Sarah Marinan. All on council staff will be providing you this morning the presentation on the preliminary draft environmental impact statement, as well as the social impact assessment. While there's two documents available for you on the e-agenda, we've combined them into one presentation today. Thanks for your patience. So this is just the outline of the presentation that we're planning to provide today. First, we'll begin with the action timeline, which also includes the council's purpose and needs statement. Then we'll move into a description of the alternatives, which reflects Chapter 4 of the DEIS. The third section of the presentation covers the methods used for impact analysis, which corresponds to Chapter 5 of the DEIS. And then we'll move into the impact analysis. The organization of the presentation today is a little bit different from what you see in the document. We've tried to work to provide the presentation in a narrative format, recognizing there's no executive summary for these two documents. So you can expect that we're going to talk through the potential impacts on chum salmon, given that this action is focused on minimizing chum salmon bycatch in the Bering Sea pollock fishery. We're also going to then talk through pollock in terms of both the environmental effects, the AFA sectors, the CDQ program, and communities. And then we will move into a conversation on Chinook and herring under the status quo, as well as the potential impacts under the proposed action alternatives, and then move into a discussion on staff's assessment of the IPA proposals under Alternative 4. This slide provides for you a high-level timeline of the current action through the council's process. The council last considered this issue at its October 2023 meeting, and at that time, the council received a preliminary review analysis on the relative feasibility of the alternatives initially adopted in April 2023. In October, the council modified a set of alternatives and requested that analytical staff bring back an initial review analysis, which is where we are today.
And Dr. Hoppala, before we get too far into the presentation, I just want you and others to feel free to, if we, I think, pose questions that might be best, for later on in the presentation, just please feel free to ask us to hold them, considering how lengthy this presentation is. Thank you.
Sure. Thank you, Madam Chair. This slide will just walk through the summary of the action before the council at this time. We did try to provide some of this information for you in your action memo as we walk through this. That's also a point of reference for you all. One task is that the council may choose to modify or refine its alternatives. We've worked to try and outline some questions that could help the council in its consideration within that action memo. A second task for the council is that it may also determine if or how it would like to move this action forward. One approach would be to request additional review of this analysis. And if the council would like to do that, it could expect a revised analysis to come forward in October 2024. A second pathway for the council to consider is whether it would like to recommend the preliminary DEIS and have it be revised based on the input at this meeting and released for publication by NMFS as the draft EIS. If the council would like to pursue that pathway, it may also consider identifying a preliminary preferred alternative. The council is not required to identify a preliminary preferred alternative prior to recommending the DEIS be published. However, doing so prior to the publication of that document would provide the public an opportunity to consider the council's preferred course of action and also an opportunity for more specific comments to be provided to the agency. If the council would like to schedule additional review, That would be in line with the interim guidance from NOAA, and this is important to note because the timeline that we had provided you with in October of 2023 had suggested that the 2-year time clock for this action would end if you were judging it by conservative planning with the publication of the record of decision. But the interim guidance states that the 2-year time clock would end with the publication of the final EIS. So that allows for a little bit more flexibility within this time frame to schedule that additional review. But the council would need to take final action in April 2025 to accommodate that timeline. Under this action, the council is considering management measures to minimize chum salmon bycatch in the Bering Sea pollock fishery to the extent practicable, consistent with National Standard 9. A priority for the proposed action is to minimize the bycatch of chum salmon that are of Western Alaska origin in particular. The council has also expressed that it intends to consider the proposed additional regulatory measures while maintaining the priority objectives of the current Chinook bycatch avoidance program, which is largely established under Amendment 91 and 110. The council is considering this action in light of the recent chum salmon declines across Western and interior Alaska, which have resulted in restricted management actions on subsistence, commercial, and personal use harvest of chum salmon. The next part of the presentation provides you with a description of the alternatives, and we're just going to work through them in order. So alternative 1 is the status quo. This slide depicts for you the chum salmon savings area, which is shaded in pink and encapsulated within the catcher vessel operational area, which is outlined for you with the dashed line. The chum salmon savings area is a time area closure in the southeastern Bering Sea. The time area closure would be triggered by a chum salmon PSC limit of 42,000 chum salmon, which is apportioned among the CDQ and the AFA fisheries. This area has not closed since 2004. However, because industry began using the rolling hotspot system for chum salmon avoidance in 2001 under a voluntary intercooperative agreement, the rolling hotspot program was developed because data in the early 2000s was showing that chum salmon bycatch rates were higher within the area than outside of the area, so it was counterproductive. The savings area currently exists in regulations as a backstop measure because subsequent and now current regulations exempt the pollock vessels from the closure area if they're governed by an IPA, and all vessels as well as CDQ groups are. The next couple of slides provide more information and a little bit of background on how the rolling hotspot system for chum salmon avoidance works. The purpose of the rolling hotspot system is to identify areas on the pollock fishing grounds where chum salmon bycatch rates are high and move the fleet to new areas to target pollock. Unlike the chum salmon savings area, which has fixed spatial boundaries as well as timing implications, these are dynamic area closures, which means the time and when the closures come into effect vary year to year. The rolling hotspot closure areas are identified by evaluating chum salmon bycatch rates across the fleet as a rolling 3-week average compared to a base rate floor, which operates as a minimum threshold to compare those calculated rates against. And that floor is stair-stepped throughout the bee season. A key component to how this program works is also the local knowledge of fishermen, cooperative managers, and Sea State, which is the third-party entity that manages the program for industry. And the 2022 hotspot closure areas for the sectors are shown here for you on the right-hand side of the slide. And a reminder that you will receive a presentation on the 2023 IPA performance following the staff presentation. In addition to evaluating the bycatch rates at those different scales, there are other components to this program, some of which do vary by the sector or the IPA in place. These include the duration of rolling hotspot closure areas, differences in measures for vessel level bycatch performance standards, as well as application of genetic information. And on that last point, the current regulations require each IPA to describe how the IPA ensures that the operator of each vessel governed by it will manage that vessel's chum salmon bycatch to avoid times and areas where chum salmon are likely to return to Western Alaska, and the two measures that are incorporated under the status quo program to meet that provision are that the combined size of closure areas are largest east of 168 degrees west longitude, so near to the Alaska Peninsula, and that the base rate floor, which is that minimum threshold value, is lowest in the early part of the bee season. This slide captures some of the monitoring requirements under the status quo. And I would note that the remainder of the presentation doesn't cover monitoring in depth because at this time, NMFS has not provided input that there would be any substantial changes to the way that monitoring occurs in the pollock fishery or the way that salmon bycatch is monitored under the proposed action alternatives. So in that sense, the status quo program would continue. Moving on to alternative 2, which is for an overall chum salmon PSC limit. Just a reminder that in April 2023, the council identified the year set for the status quo period as being 2011 to 2022. We've used salmon bycatch data from this period as it reflects the time in which the Amendment 91 regulations have been in place, which implement the Chinook salmon hard cap, as well as the systematic genetic sampling protocol and program for salmon caught as bycatch in the Bering Sea. Under option 1 of alternative 2, the council is considering a range of numerical values that it could apply as overall chum salmon PSC limits during the bee season pollock fishery. Overall refers to the fact that all salmon caught as bycatch in that non-Chinook catch accounting category, which is over 99% chum salmon, would accrue to this limit. If a sector were to reach its apportionment of the overall PSC limit during the bee season, it would be required to stop fishing. And this slide summarizes for you the range of potential PSC limits, which vary from 200,000 to 550,000, as well as the council's rationale.
Good morning, Madam Chair, members of the council, Diana Stram, council staff. The alternative 2, option 2, then provides for indices that could be considered whereby an overall PSC limit would be in effect if an index failed to meet its threshold. So this slide right here, table 4.4 on page 72 of your analysis, provides you with the range of the indices. This is again an action that you took in October with the preliminary analysis to look at the data that was available by river system and index, and to look at a way of indexing a PSC limit to some or multiple of these different indices. So for Yukon summer and fall, this provides you the available data and the rationale for the council's decision in selecting it. Yukon summer and fall both have full run reconstructions. So that means that there is a total counting of catch and escapement within the drainage for each of those stocks. The other 2 areas considered, the Kuskokwim and Norton Sound. For Kuskokwim, the council selected the Bethel Test Fishery cumulative CPUE over WEIR data because it's less impacted by weather conditions compared to that WEIR assessment. It is used by salmon fishery managers, and that data are readily available for that. For Norton Sound, then, the council chose to use a standardized index that was put together just for this analysis, which uses the escapements from 5 different river systems plus the total Norton Sound harvest. And that is considered to be representative of the chum salmon returns across several management districts in Norton Sound. In terms of the index thresholds and the rationale, this is table 4.8 in your document. And based on the preliminary analysis, this was how the council selected these index thresholds by each individual river system. So for Yukon summer, the index threshold of 950,000 fish was the rounded value of the midpoint of the Yukon River drainage escapement goal range shown here on your slide, as well as the midpoint of the ANS. Similarly, the fall index threshold of 575,000 is the rounded value of the midpoint of the drainage escapement goal for that stock, plus the midpoint of the ANS. For the Kuskokwim, then, an index threshold of 2,800 was selected. This is essentially the value that's derived from rounding to the 25th percentile, but it does meet a management threshold in that when CPUE is less than 2,300, the run size typically fails to meet ANS. So those are the considerations the council used in estimating that number as a threshold. And then finally, for Norton Sound, where there is no ANS, the number selected of 57,000 is the rounded 25th percentile from the standardized index that was put together. This is table 4-8 in your document. So this is how these index thresholds, again, under this selection of this option, a PSC limit would only be in place under these conditions. So 3 different sub options. One is the 3 area index, which would include all of the Yukon, Summer, Fall, Kuskokwim, and Norton Sound. And I would note that as the council discussed in October, each of these is to be treated as an independent test. So the thresholds are associated with each individual river system. This is not a summation of those river systems. This is an independent test by river system as to whether or not that river system is above or below the index threshold. When all 3 areas are considered, the council specified that if all 3 are above those thresholds by river, there would be no PSC limit in place. If one of the 3 systems, and there is no prioritization between them, was below the threshold, then there would be a PSC limit. The council did not specify at this time what that limit would be. If 2 or 3 of the areas are below the thresholds, there would be a PSC limit in place that would be incrementally below the one selected in the middle range of that. But again, no value was associated with that. For sub option 2, then looking only at Yukon Summer, again, if that Yukon Summer run is above the threshold, there would be no PSC limit. If it's below the threshold, there would be a specified PSC limit that has yet to be determined. Similarly, if you're looking at both Yukon Summer and Fall, if they're both above their thresholds, no PSC limit. If one or both are below their thresholds, there would be a PSC limit. A couple implementation issues with this, and then I'll go into the analysis that was requested by the council on looking at how well these trend with each other. The idea of this threshold, if the index is selected, this is something that would take place during the specifications process, somewhat similar to the way that you receive your letter from ADF&G to the National Marine Fisheries Service and is posted to your agenda item for the Chinook 3 river index. For this, the ADF&G would do something similar depending on the threshold, depending on the river system and sub option selected by the council. We would note in an analysis, then we would look at the fact that only preliminary data for some of these runs would be available in time for October. You do your proposed specifications in October, your final in December. And it's possible that depending on the index selected, you would only have preliminary data in October or you would only have preliminary data in December upon which to make the determination as to whether it's above or below the threshold. This is a particular consideration for the Yukon Fall chum stock, in that those data would still be preliminary in December, but the ADF&G could provide, based on expert opinion of the harvest that has not yet been completed by October, they could provide something in October, but it would still not, those estimates are not final until the following year. Otherwise, this is not so different from how we do our specifications. If we don't have the complete data in October, we used to not have complete data for crab at the time that we did proposed specifications. We now do, but we do not get our herring estimate until December. So it would be more similar to when you receive your herring estimate. The council then in October requested that the staff bring back an analysis of how well the Yukon area indices and the overall 3 area index would trend with each other. So there were 2 different analyses that took place. One is a dynamic factor analysis whereby all of the indices were combined through dynamic factor analysis into a single trend. So on the left-hand side of this graph, that black line that you see is the combined index of all of them. And the purpose of combining them with this dynamic factor analysis was to look at how well each individual index trends with the overall trend when they're combined together. So on the right, then you see the factor loadings for each of these. The top in green is the Bethel CPUE. The top in green is Norton Sound. The beige is Bethel CPUE. And then blue is Yukon Fall red is Yukon summer, and this is looking at each individual index and how well they trend with the overall. And as you can see that the Yukon summer and fall have the highest factor loadings, followed by Bethel, followed by Norton Sound. The second analysis that was done that's not pictured on here was a cross correlation using the actual sub options. So cross correlating whether how well Yukon summer as a sub option trends with the overall DFA trend, and a cross correlation of Yukon summer and fall and how well they trend both with each other, with the other indices, as well as with the overall combined trend. And the results of that are included as Appendix 7 to your document. But the overall take home was that the highest cross correlation is when you combine Yukon summer and fall, but followed very closely behind that is the cross correlation to Yukon summer. So I think that the combined is 0.96, summer alone is 0.9, and the others are significantly below that. So that's to provide the council the information that if you wanted to go with less than all of the areas for complexity purposes, that the two that would be most likely would be either Yukon summer and fall or just Yukon summer.
Question, Dr. Stram. Ms. Baker.
Thank you, Madam Chair, and thank you for describing that, Dr. Stram. The analysis, the subsequent analysis and takeaway that you just described, however, was retrospective as I understand it. And based on the previous slide that you mentioned in terms of with the index that would use Yukon summer and fall, the availability of the data for, Yukon fall, getting my thoughts together in terms of for the council process, we would need to use preliminary data if Yukon fall is included. And so I'm trying to weigh those two things in terms of the added value of an index with Yukon summer and fall, considering the data availability issue. And do you have, I know that's a really difficult question, but is there any way you can help me understand that a little bit more?
Through the chair, Ms. Baker, thank you for the question. I can try. It's my understanding. So going back a little bit, when we looked at the difference between using preliminary information and final information in establishing the Three River Index, we looked at what the effect was to get a sense of whether or not there was a large difference there. It is my understanding from communications with the state of Alaska, that kind of analysis for Yukon fall would not be possible because the preliminary estimate and the information that would be used in October does not have a history that can be gone back to compare with the final estimate. The final estimate is available in January, but there would be no way other than in a one single year to look at the difference between them because they would have to recreate the data that would go into the October preliminary analysis, and it does not otherwise exist. For the others, I believe you could look at the difference between preliminary and final.
Ms. Kimball.
Thank you. Thank you, Ms. Baker. Asked my question as well, but is there then a staff recommendation based on those trade-offs, whether NIP staff or council staff or ADFNG staff recommendation on what's most appropriate to capture the trend across all coastal Western Alaska, but to use, best available and consistently robust data? Do we have that kind of a recommendation?
Thank you. Through the chair, Ms. Kimball. I guess two things to that. One, we were not aware of the data limitations in Yukon fall at the time that we were publishing this document. That was information that we were able to communicate with the state about afterwards. We did communicate that information to the SSC, and I believe, I have not seen their minutes, I believe they have a recommendation. I think that given the circumstances, what we were just we do not have a staff recommendation. We didn't go that far, but what we did try to indicate is that the difference in the cross correlation, which is not what you see here, but the cross correlation between the sun versus the summer is that there's not a very large difference in that cross correlation coefficient, 0.06 between the two. So it does seem that if the council is concerned about the data availability or the use of preliminary data that can't be easily compared historically against the final, that Yukon summer would alleviate those concerns.
Okay. Moving on to option 3 of alternative 2, the council is considering 4 different approaches to apportioning the overall chum salmon PSC limit among the various fishing sectors. These 4 sub-options are mutually exclusive, meaning that if the council were to move forward with alternative 2, it would only pick one. This slide is table 4-7 from the DEIS, which provides you the apportionment percentages that were applied throughout the analysis. In October, the council requested that staff use an adjusted blend bycatch rate for the apportionment percentages, and this table does reflect that analysis. This slide just briefly highlights for you some of the other components for alternative 2 that the council has already provided input on, namely that the inshore sector and the CDQ programs apportionments would be further subdivided by the inshore cooperatives as well as the CDQ groups. And the council has also specified that the apportionments of the overall PSC limit would be transferable and mirror the Amendment 91 program. Moving on to alternative 3. Alternative 3 would establish an annual Western Alaska chum salmon threshold of 40,000 to 53,000 Western Alaska chum salmon. The council intentionally chose to set this as a range to account for uncertainty in the estimated mean proportion, which was demonstrated in table 4-1 of the DEIS and is also here on the right-hand side of your slide. Alternative 3 must be implemented in conjunction with alternative 2. And while all chum salmon caught as bycatch during the B season would accrue to the overall PSC limit under alternative 2, only those chum salmon that are caught as bycatch during the B season and then estimated to be of Western Alaska origin would accrue to this threshold. Under alternative 3, the council has indicated the annual Western Alaska chum salmon threshold would be apportioned among the pollock sectors. This is table 4-12 of the DEIS, which provides a summary of the apportionments that each sector would receive based on the various sub-options of option 3 of alternative 2. And again, the apportionments to each sector are specified as a range to reflect the overall or the annual Western Alaska chum salmon threshold. There are 2 different options under consideration for alternative 3. Under option 1, an overall chum salmon PSC limit of 450,000 chum salmon would be in effect. And there's also a performance standard included under alternative 3, where a sector's performance against the Western Alaska chum salmon annual threshold would be assessed the following year. And if a sector's performance exceeded its apportionment for a 3rd time in any 7-year period, it would operate under a lower PSC limit in the future. And under option 1 of alternative 3, that lower limit is 200,000 chum salmon. Option 2 of alternative 3 is similar, but with 2 different numerical values for the PSC limits. The Western Alaska chum salmon threshold in and of itself would not require a sector to close if the threshold was reached, which is different from alternative 2. And the Western Alaska chum salmon threshold is static, meaning that a sector would not receive a lower apportionment of the threshold in the future if they exceeded the performance standard. The council did include that performance standard as a way to incentivize the pollock fleet to avoid Western Alaska chum salmon in season. However, as noted in the analysis, sectors would need to balance their operations under both the overall PSC limit as well as the threshold in the future. There are several policy considerations before the council at this time if it would like to move forward with alternative 3, many of which are related to implementation. One issue that was raised by the agency during the preparation of this document is the mismatch in timing with the harvest specifications process. And this is because the genetic information from chum salmon caught as bycatch during the B season would not be available until April of the following year. So if the council would like to move forward with alternative 3, the agency would need to accommodate that within the groundfish harvest specifications process. And a possible solution would be to delay fishing sector's formal evaluation against the threshold by a year and the effect on the overall chum salmon PSC limit in place by potentially, by 2 years. As an example, the B season fishery would occur in 2025. Genetic information would be available for the 2025 B season in April 2026. The fishing sector's performance would be assessed in the groundfish harvest specification process in October 2026, and the 2027 B season fishery would potentially be affected by the sector's performance in 2025. Okay, moving on to alternative 4. Under alternative 4, the council is considering modifications to the current regulations that implement the chum salmon bycatch IPAs. It's analytical staff's understanding that the council's overarching intent with alternative 4 is that it would modify the regulations so there would be additional measures in place to avoid times and areas when Western Alaska chum salmon are more likely to be encountered on the pollock fishing grounds. In order to move forward with alternative 4, the council would need to specify the provisions that would be added to the existing regulations for the salmon bycatch IPAs. And the issue at this time is exactly what would be contained within those provisions that the IPAs would be required to respond to. And at this time, we would be looking for the council to provide its priorities for those specific points or measures that would be included in the existing regulations. And our intention would be to work with NPFMC to bring back some draft language for those regulations in consideration by the council at a future meeting. The next couple of slides are going to be covered by both myself and then Doug Sheftel from the agency. And we're going to walk through the alternatives considered but not move forward. This slide highlights section 4.5 of the DEIS, which covers alternatives considered but not moved forward by the council. As mentioned at the start of this presentation, the council has taken an iterative process to getting input on the development of alternatives, and the council received recommendations from its Salmon Bycatch Committee on concepts for alternatives in April 2023. This slide displays 2 high-level alternatives that were considered but not move forward. And one is that in October, the council had considered the original concept of a chum salmon reduction plan agreement and whether area closures based on certain bycatch rates or genetic proportions could be managed by either NPFMC or the IPAs. And in October, the council had received information on the different approaches that the IPAs and NPFMC could use to issue these kinds of time and area closures. NPFMC would not be able to replicate the dynamic rolling hotspot system as the spatial boundaries of the closure areas and the timing of when they come into effect vary year to year. So at that time, the council had determined that it would be more appropriate to use a dynamic management tool for chum salmon avoidance, which could be accomplished under the IPAs. The council also received a recommendation from the Salmon Bycatch Committee to consider an overall chum salmon PSC limit. And the recommended range was a PSC limit of 0 chum salmon, 22,000 chum salmon, and 54,000 chum salmon. In October, the council considered a variety of information on historical chum salmon bycatch numbers and selected a range of PSC limits from 200,000 to 550,000. As it felt these numbers balanced public testimony requesting a lower PSC limit with practicability considerations. And again, I would remind you of the table that was presented under option 1 of alternative 2 that provided each limit and the corresponding rationale. Finally, NPFMC Alaska region has prepared a supplement to the alternatives considered but not moved forward, which evaluates overall PSC limits below 200,000. And that supplement is available for the council's consideration in Appendix 1. But with that, I think we'll turn it over to Doug.
Good morning, Madam Chair and members of the council. My name is Doug Shaftel. I'm a fisheries management specialist located here in Anchorage. We have just a few slides on Appendix 1 to the DEIS, which as described is a supplement to Section 4.5, alternatives considered but not analyzed further. I'd like to provide a little bit of context for the appendix and then briefly describe the methodology and then the results. If you do have any questions about the methodology, we do have Josh Keaton, who is the monitoring branch supervisor with NPFMC, also available online. So as you may recall at the October 2023 council meeting at which the council received the initial analysis on this action, the council heard from many members of the public and representatives, including representatives of Alaska Native organizations, that overall chum PSC limits down to 0 PSC should be considered. Given the considerable public interest in limits between 0 and 200,000 PSC, NIMS decided it was important to have some review of impacts at levels below 200,000. So this appendix that was prepared is really addressing a different question than the DEIS itself. Whereas the DEIS is intended to be a thorough examination of a broad suite of impacts of 3 action alternatives relative to the status quo, here by quantitatively examining 2 types of impacts, potential foregone pollock and avoided chum, the appendix is intended to be a comparison of impacts of PSC limits below 200,000 to a PSC limit of 200,000. The intent is that this summary review would provide the council and the public sufficient information to decide whether further analysis of any limits below 200,000 is appropriate to include in further iterations of the DEIS. It is not intended to be, nor is it a thorough review of direct and indirect impacts arising from these limits. That review would only be done if lower PSC limits were included in a further iteration. So this is what is included in the appendix is a retrospective analysis of overall PSC limits below 200,000 over the same time periods as was performed in the DIS, which you'll see in Appendix 6 and here described further later in the presentation. And that same time period is 2011 to 2022. We selected 50,000 increments to provide a representative sample of the results across the spectrum analyzed. And as analytical metrics, we used foregone pollock and avoided chum. We only used a single apportionment approach, pro rata. And using a catch accounting data, we answered the following questions for each sector. When would that sector, on what day of the year would each sector have met its apportionment that would have triggered a closure? And once a sector had met its apportionment, how much pollock and chum had yet to be caught? The results of this retrospective analysis are summarized in Table A2 to the appendix. And what it reveals is cumulative foregone pollock, as well as associated estimates of gross ex-vessel and first wholesale values that we calculated using ACFIN pricing data applied to that foregone pollock. We also present cumulative avoided chum, including WAC proportions. In the narrative, we provide some context and outline the limitations of the analysis. For the purposes of comparing PSC limits, the most useful data in the table A2 may be the relative reductions in foregone pollock and overall bycatch at each PSC limit. I will note that there are some minor differences between the cumulative numbers in Table A2 and Appendix 6 at 200,000. Those were attributable to a difference in the day that was assumed fishing would have stopped for the exercise of calculating foregone pollock and avoided chum. We did provide a very limited qualitative analysis of what impacts these PSC limits could have on the fleet communities and the ecosystem. But for the most part, the qualitative analysis redirects the readers to sections of the SIA and DIS in which these impacts were extensively discussed. So to summarize, this appendix is intended to provide information that would allow the council and the public information to assess whether the impacts of PSC limits analyzed in the DAS are indicative of impacts of PSC limits below 200,000. And with that, I'd be happy to field any questions about the analysis itself.
Thank you, Ms. Kimball.
Thank you, Mr. Shaftali. I appreciate the presentation. You were clear. I think that we could talk on the side about the methodology used, but it's certainly a different methodology than was used in the draft EIS. Is that Is that why you're providing that statement?
Through the chair, thank you for that question. What I was trying to clarify is while we generally follow the same methodology as was used in Appendix 6 to calculate foregone pollock and avoided chum, we selected a different day when we were calculating the day that each sector would have reached its apportionment to start calculating. So we used the day that the actual apportionment number would have been hit to start calculating foregone pollock and avoided chum. Whereas I believe in the DIS, the end of the week would have been selected. So if a day had been hit, let's say in midweek, the calculation would have started at the end of the week. And when you look across cumulative numbers, that difference does become significant because can be quite a large volume of pollock caught in a matter of days.
And then a follow-up, I don't know, because these are such long presentations, if you had a chance to listen to the SSC discussion, any of the staff really, if they were already in the advisory panel, there was quite an extensive discussion about a lack of analysis of benefits of the action, either between alternatives or within options to alternatives. And quite an extensive discussion about how better to characterize potential costs or harms, more than just picking a date and saying this much pollock will be foregone. And is that, once we see that SSC report, is that something that you plan to bring into this supplement, or is this supplement kind of a standalone as it stands to help inform the council for some decision making at this meeting?
Through the chair, thank you for the question. I think the intent of this supplement is to provide the information in the supplement for decision making at this meeting. If the SSC has further recommendations as to what it would like to see with regard to further analysis in the DIS, and if any of these PSC limits were incorporated into the DIS, then I presume that same analysis, additional analysis on potential benefits would be expanded to those PSC limits, should they be incorporated.
Well, last question, and then was the supplement only done in the context of additional options under alternative 2, or did you also consider its effect on other alternatives like alternative 4? Were these additional options put in place? It's pretty, I think, important distinction, given that we don't have many alternatives right now that really focus on our purpose and need, which is to avoid Western Alaska chum. And any of these options don't do that. So did you think about that, how those alternatives might work together, or was this really kind of analyzed in isolation at this point?
Through the chair, thank you for the question. No, this was limited just to alternative to option 1.
Thank you, Ms. Baker.
Through the chair, thank you for your presentation. And Madam Chair, please tell me if this is out of order, because I think my question is related to one of Ms. Kimball's questions. So if it's too much of a duplication, I certainly will retract it. But Mr. Shaftel, in your presentation, you were clear that the intent of this supplemental analysis was to answer the question, are the impacts at a 200,000 chum PSC limit indicative of impacts at lower limits? But you were clear that this high-level analysis of the lower limits is not the same as the analysis of the limits in the analysis. So how are we supposed to answer that question? We seem sort of set up to fail to do that very question. So can you help me give some guidance as to how we're supposed to do that? And really how we're supposed to use this with decision-making at this meeting, like you indicated to Ms. Kimball. Thank you.
Through the chair, thank you for the question. Yeah, I recognize that the numbers at 200,000, there are some, what I would describe as minor differences, but I think that this document is intended, because it includes 200,000, to allow you to compare, using our methodology, the different impacts just in these 2 analytical metrics of foregone pollock and avoided chum at those lower PSC limits relative to what we would see at 200,000 using the methodology that we used. So I think that's the scope of the information that we've been able to provide, and given the limited time frame and the scope of the analysis.
Thank you for that. And yeah, I recognize that my question wasn't so much about the different metrics with the main part of the analysis. It was really the limitation of the supplemental analysis on those two metrics and those two metrics alone. And just the real shortcoming of that in terms of what this council is supposed to do to analyze impacts, and not considering some of the impacts that Ms. Kimball mentioned in terms of potential benefits to chum salmon returns and things like that. I guess I just wanted to point out the challenge there. So not really a question, but do I have that correct? And I guess I'm confirming one of your slides. For the supplemental analysis, really for each PSC limit, what we have is really limited to those two questions. What day would each sector have met its apportionment? And once the sector met its apportionment, how much pollock and chum had yet to be caught? That's what this analysis is limited to, correct?
Through the chair, thank you for the question. Yes, generally that's what it's limited to. I mean, we did calculate valuations associated with that foregone pollock, and like I said, and we did qualitatively try to describe how some of these impacts might reverberate through communities. But again, most of the qualitative discussion is kind of piggybacking on the analysis that was done in the SIA and the DEIS. So yes, this is a limited analysis. And I think that if the council decides that it wants to include any of these PSC limits in further iterations, then all of the additional analysis that would be included in the DEIS itself hopefully would shed some light on the limitations that this particular scope of work has, and may lead to different conclusions about eventually whether or not those PSC limits would be advisable to implement.
Thank you, Mr. Chaptal. Not seeing any further questions.
Thank you.
The next part of the presentation is going to move on to the methods used for impact analysis. And given the conversation just had, I'm not going to reiterate this slide. But I would note that while we use a retrospective analysis in the DEIS, we do assume that fishing behavior would change if an overall PSC limit were in place. We stop short of trying to quantify those changes, but rather try to qualitatively describe the expectations of different fishing behavior in the future. This table displays, it's table 6-38 from the DEIS, which shows the estimated number of Western Alaska chum salmon caught as bycatch by fishing sector in each year under the status quo period. To estimate the number of Western Alaska chum salmon caught as bycatch by sector, a new analysis was conducted wherein the sector-specific annual mean proportion of the Western Alaska regional group, which is the combined coastal Western Alaska and the upper middle Yukon proportions, was multiplied by the total non-Chinook bycatch that would have been avoided in all statistical weeks after a sector had reached their apportionment of the limit. As mentioned previously, the council intends for this threshold to be implemented as a range. To move forward with alternative 3, NMFS would be looking for input on what the council would use or intend to use for determining whether or not the sector had exceeded their apportionment of the threshold. So for the purposes of the analysis, staff selected the upper bound of that range given the uncertainty. So Table 6-38 that is shown here, you see each column where the sector's apportionment of the threshold and the range is displayed. The orange cells indicate those years where the sector would have been above the upper bound. Yellow cells indicate when a sector was within the bound, so over the lower bound of the range, but had not exceeded. Gray cells indicate years where the estimates were not able to be run and provided.
Madam Chair, we're just going to walk through a little bit of an environmental scan to better explain what environmental categories were included for impact analysis and why others were not included. So this is the way that we looked at this, looking at all the environmental categories, PSC species, other marine resources, and then specifically ecosystem and ecosystem considerations. And then the range of categories beneath that, looking at our PSC species from crab, halibut, Chinook salmon, and herring, other marine resources of seabirds, habitat, and marine mammals. For ecosystem, we look primarily through the lens of climate change on the resource categories, including chum and pollock. I would note that one thing that we did not include here, and we could look at, we didn't include squid in our environmental analysis. And when I get to the PSC species, I'll explain it was sort of the same rationale. We certainly could. Again, there are chapters on habitat, seabirds, and marine mammals in your analysis. They're included here for this purpose, but not described in our presentation today because there are no anticipated impacts under this set of alternatives for status quo. So but we're happy to answer questions on those, but that's not something that we were presenting. As it relates to PSC categories, again, these are the categories that we initially looked at. For purposes of this analysis, then, neither crab nor halibut have constraining PSC limits in the pollock fishery. And therefore, because we were looking at this through the lens of how this would affect fleet behavior, which we'll get to a little bit later in this presentation, we did not include crab or halibut impacts of that under this alternative set. Both Chinook and salmon have PSC limits for the pollock fishery. Obviously, as you know, Chinook salmon PSC limits can be constraining by sector and definitely affect fleet behavior. Herring is a time area closure, which we will get into again later on in this presentation, but also is something that affects behavior. So we included that. With respect to the environment, again, we're looking this mostly through the lens of climate change. And so what you see is that the impacts to the environment, rather than as a separate chapter, are touched on in various chapters across different resource categories. Under chum salmon, when we get to sections talking about decline and climate change and warming waters, there's a section in the habitat that discusses the impacts of potential climate change on habitat. And then we looked at the impacts of the environment on the pollock stock, as well as the impacts of the alternatives on both pollock and food web interactions. And again, this is where we could include squid in another iteration should that be desirable. Madam Chair, we're going to move on to the impact analysis sections then of this document. Starting off with chum salmon. And again, as Dr. Hapola indicated, we've combined the sections from in our presentation of both the DEIS and the SIA in order to try to provide you through our presentation a more executive summary version of both documents. So to the extent possible, we've tried to cross highlight in every section where we're pulling this information from, where it's coming from the SIA, where it's coming from the EIS. So the first thing that we're going to do is walk through the impacts under status quo, beginning with the status of chum stocks and the causes of decline, and then moving into other aspects in terms of subsistence harvest, commercial chum salmon fishing in Western Alaska, and then the impacts to communities and regions that are engaged in subsistence and commercial chum salmon fishing. So the first section then on chum salmon biology, status, and distribution. This chart, this figure in your document is from the NPFMC Atlas of Pacific Salmon. And the intention of this is to try to start to narrow down the areas over which we're looking at salmon stock status. So beginning with looking around the whole Pacific Rim, and then we narrow in to Western Alaska. But the point of showing this then is to show that in general, so obviously red arrows indicate a decline in the stock, and this is looking between the most recent 3 years included in that atlas was just 2018 to 2020, as compared to the previous 11 years, and across the Pacific Rim, and where things are declining versus where they are increasing. And in general, when you look at that 3-year snapshot across the Pacific Rim, for almost all countries and areas, they do show a decreasing trend in chum salmon abundance trends, except for some specific cases in the US, Washington state, where trends increase for some chum salmon populations. The atlas indicates that the preliminary returns Pacific wide in 2021 also trended downward in all countries and areas, with a few exceptions, an exception in Washington state and an increase in Russia in the Western Bering Sea and Northwest Pacific. I would note that where the arrows are yellow, that just means that there was no difference in trend.
Dr. Stram, a question. Ms. Kimball.
Thank you. Just a quick one, Dr. Stram. I thought you might say if there's any difference between single yellow arrows or the double yellow arrows.
Thank you. Through the chair, Ms. Kimball. This came up at the SSC as well. Dr. Monroe on the SSC was part of who put together this, and he indicated to us that he believes that that's just simply an error in they are meant to indicate the same thing. And I believe that the single arrows should have all been double arrows, indicating it could go either way, but was flat. Next, this is figure 6-4 in your EIS, showing the total hatchery chum salmon production around the Pacific Rim from 1952 to 1921. This is from the NPFMC for 2020. It published in 2022, giving you the chum salmon hatchery releases by country. They've been relatively consistent across the past decade, with the singular exception of Russia, which has increased production by an average of 0.3 billion over the last 3 years, which represents approximately 43% increase over the previous releases. This summary figure does not exist for NPFMC for the most recent year, but I went through the data, and that trend in Russia does continue for the estimates that they have for 2022. Moving in then to talk about Western Alaska stock status. We have an entire section from ADF that ADF&G contributed on stock status in Western Alaska. This is just pulling 2 of the tables that are included on pages 120 and 121 of your document to provide a snapshot. But in general, the stock status was declined in 2021. There's marginal improvement in 2022, continuing into 2023, but still, as you see, in terms of the abundance, almost every stock, with the exception of Kotzebue, was below average. Kotzebue dropped in 2023. And then this just gives you the indication of escapement goals, whether they've been met. This is in general overall, so that there are specific information that you'll hear more in this presentation on the SIA with respect to specifics on subsistence fisheries and commercial fisheries. But this is just giving you a snapshot of the overall stock status in those stocks. And then again, pulling forward just some trend information. We just pulled forward the trends in the stocks for which the council is looking at in terms of your indices. So you're looking on the top left, you see the Yukon River chum salmon for both summer in blue and fall in red, and the decline that you see noticeably in 2021, and then the information for 2022 and 23. Norton Sound, then this is not that combined index for your the 5 rivers plus the commercial harvest. This is just looking at the Quinnipiac River to give an idea, just a snapshot of Norton Sound chum stock status. And again, very low, has declined from highs in previous years. And then for Kuskokwim, here we're showing both the Bethel test fishery in black, as well as the Kagrila River weir. For your index, you selected to use the Bethel test fishery, but we show both of those informations, and obviously they do trend together in this graph in terms of stock status there. Madam Chair, moving on then, this is section 6.1.3 in your document, looking at environmental factors related to chum declines. So I'm going to use this figure for the discussion purposes of this. I would note that the figure that you see here is a life history of chum salmon. This was modified from the Alaska Salmon Research Task Force. They included a very similar figure in their document. We modified it slightly. We also use it to show in yellow in terms of the age of the chum salmon that are encountered as bycatch in the pollock fishery. So that's what the yellow indicates. And then we'll just walk through what some of the causes of decline by life history stage, and which are, if you look at the rings around the inside, which are happening in the freshwater environment, which are happening in the marine environment, as well as how predation factors in, and different food limitations and potential impacts. That's what the inner circles are meant to represent there. So beginning with spawners and the freshwater environment, the warmer water in the freshwater environment causes increased metabolic needs. That spawning success then is affected because it is often that the temperatures are outside of the optimal range for spawning success. Moving down into the egg stages, the changes in stream habitat can affect egg survival. And then as fries are beginning to move up, there's issues with prey availability and quality. Again, this is a similar thing that you'll hear with pollock as well. Metabolic needs in warmer waters are increased, and there's increased predation. Moving down then to the marine juveniles. In the marine juveniles, again, changes in stream discharge affect the migrating juveniles. Ice breakup timing can affect their prey availability. Between the marine juveniles, immature and adults, then there's issues with pathogen loading, predator density, and competition for prey with Asian hatchery fish. And then in the years in which we've had these marine heat waves, studies have shown that there's decreased prey availability, again, increased metabolism, and that they've switched to lower quality prey items such as jellyfish. And then finally, looking at what this action is based on are the causes of decline in the life history stage in which the pollock fishery is encountering these fish as bycatch. So a summation of all those other factors, but then ages 3 through 5 are the ages that are primarily caught by the pollock fishery in the bycatch. There are also removals from the state of Alaska commercial fisheries catch of these AYK stocks, as well as competition for prey with hatchery fish. And in this, when we get to the impacts in this document, we do try to characterize it in the presentation, not in the document, but since the document was put forward, we've tried to characterize in the presentation all sources of removal of that life history stage in comparison with bycatch as well.
Dr. Stram, a question. Ms. Kimball?
I'm sorry, Dr. Stram, to interrupt you. I'm just trying to, where are we in the document? Did you say we're bouncing back and forth between the background sections in the EIS and the SIA, and you've combined them all into just a big background section? Is that what we're looking at? Okay.
Madam Chair, Ms. Kimball, yes, we just went through 6.1.3 in the EIS, but now we'll be moving into sections that are both in the EIS as well as sections that are in the SIA. And that's why we try to point you as we get to those sections as to which is where.
Thank you.
Thank you. Mr. Twite.
Thanks, Madam Chair. Dr. Stram, on the causes of decline, one of the issues that we've been hearing about more recently is, I'm probably going to mangle the name, but I believe it's ichthyophonus. And I'm not, did I miss that in here? And if I did, is that because it's not widespread? I think I've heard about it largely in the Yukon, but I don't know if it's more broadly, or is it not thought to be a source of either mortality or lowered productivity in the population?
Thank you for the question through the chair, Mr. Twite. That's in the document itself. We didn't pull it forward here. We're trying to just put a snapshot kind of more along the lines of where climate is interacting. But there is a section in the causes of decline that notes the ichthyophonus in river as an issue.
Apologies, but I was really asking why it didn't get pulled forward into these. Is it just then not thought to be on the scale of the ones that did get pulled forward? And I'm asking because I really don't understand it very well, but it sounds as if it's the sort of problem that could really depress productivity of a population.
Thank you through the chair, Mr. Twite. I think that's just an oversight on my part in putting together, culling from that section. The section itself is not written by life history stage, which was a suggestion late in review that we thought would be a really good idea to rearrange that section so that you're doing it more by life history stage here. And so it's probably just something that I wouldn't say that it's not a significant source of decline and possible impact on productivity. I could ask for additional help on it because I don't know to what extent it is as prevalent across all river systems versus more prevalent in the Yukon than across the others.
Ms. Kimball.
I know we have Dr. Howard here, and as this is a staff presentation, she's probably the appropriate person to answer that question, or do it on the side, Madam Chair, if you're not interested in taking that up now.
No, I think that we have her listed as available for questions, so this would be appropriate. Thanks.
Good morning. For the record, my name's Dr. Kay Howard. I'm a fishery scientist at Alaska Department of Fish and Game. And for ichthyophonus specifically, we do see it as a significant issue for Chinook salmon, particularly on the Yukon River, although it's likely in some other river systems as well. The vector for ichthyophonus is believed to be through food consumption of infected prey fish. And chum salmon are far less piscivorous than Chinook salmon are. So they're not believed to be likely high prevalence of ichthyophonus in chum salmon, but we haven't looked at chum salmon as intensively as we have for Chinook.
Thank you. And Ms. Carroll.
Through the chair, I would just follow up that we've partnered on some of the ichthyophonus work, and we don't see the same indigenous knowledge showing us that that disease has been prevalent in the upriver chum species, affecting the meat and whatnot. Since it's mostly the indigenous and local folks that identified that, we're not seeing the same thing in the meat. So while we haven't done as much studies, it hasn't been indicated, at least in the Yukon stocks or in other rivers where we're seeing it so prevalent on the Chinook. So maybe why it wasn't highlighted in that section.
Thank you.
Thanks, Madam Chair. So the next couple of slides are just going to walk through an overview of subsistence harvest trends. And this slide provides you with information on the statutory and regulatory background for Alaska's subsistence fisheries. You can also find this in Chapter 3 of the DEIS, which provides you an overview of salmon fisheries management in Alaska. Subsistence has both a state and federal component, and Alaska state law defines subsistence fishing as the taking of fish, shellfish, or other fishery resources by Alaska residents for subsistence uses. Subsistence uses of wild resources are also defined as non-commercial, customary, and traditional uses. The first priority for management is to meet spawning escapement goals in order to sustain salmon resources for future generations. After conservation, the highest priority for use under state and federal law is subsistence. So this is just important context as we consider the proposed action alternatives. This slide provides you with some background information on amounts reasonably necessary for subsistence. So under Alaska's subsistence statute, the Board of Fish identifies salmon and other fish stocks that support subsistence fisheries. And if there's a harvestable surplus of those stocks with identified customary and traditional uses, the Board of Fish must adopt regulations that provide reasonable opportunities for subsistence. The board is also required to identify the amount of the harvestable portion of these stocks that's reasonably necessary for subsistence uses. And when it is necessary to restrict harvest levels, the statute directs the board to assign a preference to subsistence uses. Figure 4-24 here from the SIA shows the estimated number of summer and fall chum salmon harvested for subsistence from 1988 through 2021 in the Yukon area. In the Yukon, subsistence harvests of summer chum have ranged between 229,838 fish in 1988 and 1,234 fish in 2021. The most recent 10-year average level of harvest for subsistence summer chum was 77,448 fish. Subsistence harvests of fall chum have ranged from 211,303 fish in 1989 and 705 fish in 2021. And the 10-year average estimated level of subsistence harvest was 69,952 fish. Until 2020, summer and fall chum salmon subsistence restrictions largely resulted from efforts to conserve Chinook salmon. In 2020, there were limited subsistence opportunities. And in 2021 and 2022, there were no subsistence opportunities for chum salmon fishing in the Yukon area. In 2023, there was a limited opportunity for summer chum salmon harvests. In the Kuskokwim area, subsistence harvests of chum salmon have ranged between approximately 157,000 fish in 1990 and 10,690 fish in 2021. The more recent 10-year average level of subsistence harvest is approximately 35,000 fish. There were subsistence chum salmon fisheries in 2020 in the Kuskokwim area and a limited subsistence fishery in 2021, 2022, and 2023. Some important context for these subsistence opportunities in more recent years is that in 2022 and 2023, subsistence fishing opportunities provided during the chum salmon run between mid-June and early August were primarily aimed at expanding sockeye salmon harvest while avoiding chum, chinook, and coho. This slide shows trends in the estimated historical subsistence salmon harvests from 1994 through 2021 in the Norton Sound District. In this district, subsistence harvests of pink salmon have comprised the majority of total salmon harvests at 51%, followed by chum salmon at 22%. Subsistence harvests of chum salmon have ranged between approximately 43,000 and 1,681 fish. The 10-year average level of harvest here is 12,545 chum salmon. In the Port Clarence District, subsistence harvests of sockeye salmon have comprised the majority of total salmon harvested at 40%, followed by pink salmon at 27%. Subsistence harvests of chum salmon have ranged between approximately 7,000 fish in 2017 and 1,275 fish in 2000. The estimated subsistence harvest of 1,719 chum salmon in 2021 was the second lowest harvest level on record and is below the more recent 10-year average level of harvest for this district at 4,774 fish. This slide just provides you with a high-level summary of the different factors that can influence these patterns of subsistence harvests. So certainly subsistence opportunities and thus harvest levels can reflect patterns of abundance. However, restrictions on chum salmon restrictions on other species of salmon like Chinook salmon can also affect harvest levels. And that's an important component to understanding patterns of subsistence harvest, which is the patterned use of salmon for subsistence. Other factors that can influence patterns and trends in subsistence harvest over time include the fact that households have different needs and abilities to harvest subsistence year to year. There's also shifts in species distributions, weather conditions, combined with the timing of when subsistence fishing opportunities may be open, among other factors. The next two slides provide an overview of the economic role as well as the cultural importance of subsistence. More information on this topic can be found in section 4.3.5 of the SIA. And I would note that these slides are not exhaustive of the topics and the issues that are covered in the SIA, but they do provide you with context for the potential positive social impacts or benefits that could result from this action. So many rural and Alaska Native communities are home to mixed economies that include a mix of subsistence and commercial activities. And a key point is the interdependence between the economic strategies that households and families will use, from commercial fishing, fur trapping, and seasonal jobs as other forms, as well as other forms of wage employment to support their subsistence activity. And it's that combination of money that's paid from employment and subsistence food production that characterizes these mixed subsistence economies in many areas. The SIA provides a lengthy discussion on the role that subsistence and subsistence harvest of all salmon, as well as chum salmon, play in meeting households' food security needs. And food security includes many components, including access to sufficient quantities of food, as well as different cultural components to food security. As discussed in the analysis, chum salmon can play a unique and important dietary role. And as an example here, chum salmon are sometimes a preferred food source for elders and others that may not be able to digest oil-rich species like Chinook salmon. And this characteristic that chum salmon are less oily can also make them a more desirable species at times because they can be easier for processing and drying on fish racks.
Dr. Hopla, a question? Ms. Kimball?
I just have a quick question, just because it's come up a few times in written public comment about, very legitimate study trying to translate the monetary value, like if you had to replace salmon, what that would cost somebody to go into the grocery store. And that seemed to be a very legitimate study, but also rather insulting to people. I don't think we've seen that in our essays before. And I wondered if that had come up in your presentations already, or there was a way to better caveat that study. I think it said $5 to $10 as replacement. In part, so it could be very clear that it was just trying to replace the level of protein that you would have to purchase, not any of these other values that you just mentioned. Is that making sense, Dr. Hapla, that reference to that study? I only bring it up because it's come up to me multiple times.
Thank you, Ms. Kimball, for the question through the chair. So it's my understanding that the Division of Subsistence, when they would do the year in review report, the last one that was put out was published in 2018 and based off of 2017 information. And we only draw attention to the replacement expense associated with subsistence in one paragraph of the SIA. And we do note that the information that was provided there in terms of the estimate, in terms of a per pound cost, is likely lower than it would be today due to inflation. And then we pretty quickly move on from that because we're not trying to call attention or trying to equate that there is a dollar amount that can be put on subsistence, but rather the value in it lies in all of the other social and cultural context that's there. But given that that's something that was previously put forward or was regularly done within that specific context for that report by the division, it seemed important to include, but we're not trying to in any way say that that's the main value of subsistence.
Just to follow up, and I realize that, and I think it's a testament that people are reading a social impact assessment, and so it is just a very small portion. But what I have heard is it is still not caveated appropriately, and so maybe just one additional sentence to show the basis of that report, meaning just replacement of the protein and no other values, would be helpful. It's just a suggestion so that we could kind of put that to rest. But I appreciate you discussing it on the record. Thank you.
Sure. Okay, so the next slide continues on with that conversation from section 4.3.5 of the SIA. In many communities across the Arctic, the Yukon and the Kuskokwim, sled dogs have played an important role for transportation, hauling goods, as well as subsistence hunting, fishing, and trapping. Chum salmon have long been a primary food source for dogs, although the number of sled dogs have declined, particularly since the rise in the use of snow machines. But there have been recent efforts to teach youths about the caretaking of sled dogs, and we try to capture that in the SIA. Much of the fishing that has historically taken place across Western and interior Alaska has been at fish camps. And fish camps in particular have long been central locales where families come together and cultural traditions as well as traditional knowledge are passed down from generation to generation. However, families are using fish camps less today than in the past as they weigh the amount of time, fuel, and money that it might take in order to travel to and from these camps to check their gear. Fishing, like caretaking for sled dogs, can be an important common ground that brings together multiple generations over a shared activity, allowing for relationship building and knowledge sharing. Extensive sharing networks exist within and across rural Alaska communities, which helps to support the resilience of these communities as they share different resources and help to meet needs. Culturally held values like sharing, respect, and being taught not to waste are central to the relationships that people hold with each other and with salmon. And the analysis spends a bit of time discussing Indigenous worldviews and traditional knowledge systems that place humans in reciprocal relationships with non-human entities like salmon. And many Indigenous cultures believe and hold that humans and animals are equal, that fish and animals are attributed personhood, and that non-human beings have agency. And this worldview is important for understanding these relationships as a starting point for those closely held values like sharing, respect, and minimizing waste.
Madam Chair, members of the council, good morning. Sarah Marion, council staff. This presentation is also going to cover section 4.4 of the SIA. This covers commercial chum salmon fisheries in interior and coastal Western Alaska. These regions align with the geographical region of Western Alaska and upper middle Yukon, the genetic stock groupings. And so therefore they could also potentially benefit from additional Western Alaska chum returns to these river systems. And also, as Kate mentioned, the commercial fisheries, salmon fisheries in these regions and the subsistence fisheries can be interconnected in many ways. So we covered this section as well in the SIA. The commercial salmon fisheries discussed here are managed by the state of Alaska under the ADF&G Division of Commercial Fisheries and the direction of the Board of Fisheries. This map illustrates 5 ADF&G management areas in the region. These regions, as I mentioned, align with the geographic groupings. And as Kate already kind of walked through, ADF&G includes priority for first meeting spawning escapement goals, after which it evaluates salmon available for subsistence uses. And then finally, it considers salmon surplus above these amounts for other consumptive uses, which includes commercial fishing opportunities. Here is a slide summarizing commercial salmon fishing trends in these regions. There's 8 CFEC commercial fisheries entry commission commercial fishing salmon permits that are associated with these management areas. And I'm going to talk more about those. These permits are not specific to a certain species of salmon, but obviously the opportunities within each region depend on the composition of the species composition available. They might be influenced by ADF&G management measures that are put in place to protect a species of concern, like Chinook or chum. Also, the opportunities are largely influenced by the availability of processors or fish buyers in certain regions. Section 4.4.2 of the SIA gives you a brief summary of each region. These are mostly coming from ADF&G area management reports and season summaries. Also, each of these individual descriptions includes a longer time series of commercial catch in each region. We present catch in this section in a number of different ways and scopes of time, just to give you a different sort of picture of what's going on in the region. At kind of a high level here, the commercial, this section highlights commercial closures on the Yukon and Kuskokwim and specific district closures in the Norton Sound area. And it also shows estimated chum catch statistics in the Bristol Bay area appear to have declined considerably since 2018. And as Dr. Berry mentioned in his presentation, the Kotzebue chum abundance may be trending differently, and we see different trends here in terms of commercial harvest for that area. So these are the 8 CFEC commercial salmon permits that are covered in this section. This table shows you with a longer scope of time the relative species diversification for each that's been harvested under each permit from 1976 to 2021. This gives you kind of a good snapshot of some of the overarching kind of species composition. So on one side is the Kotzebue gillnet fishery, which is almost 100% dependent on chum, whereas obviously the Bristol Bay fishery is primarily a sockeye fishery. And then you can see the other permits have a different composition when looking at that high scope. So this table was from the CFEC permit reports. There's a lot of other information about permit activity within those reports, types of transfers and amounts of transfers as well. Looking at those 8 permits, we grouped the Yukon area permits together and the Bristol Bay permits together, but we have another series of tables in this section intended to highlight community and regional engagement in and dependence on commercial chum salmon fishing. We looked at this relative to 2 geographic aspects. So both the fishing area that's associated with the permit, but also the address associated with the permit holder. Those CFEC reports that I referenced have the communities defined as local versus non-local relative to the fishing areas. So we were able to use that distinction in addition to the communities listed. There's limited alternative economic opportunities in many Western and interior Alaska communities. So to the extent that these fisheries are local, it can really contribute a valuable economic opportunity. The first 2 sets of tables focus more on engagement. They show counts of permit holders and ex-vessel value from 2011 to 2022. The annual average, percentage, and unique number of permit holders are shown here in a consolidated version on this slide. And as you can see here, with the exception of Bristol Bay, these are highly local fisheries. You can see 96%, between 96% and 99% of the permit holders have associated addresses near the fishing grounds. So on one side, if you look at the tables in the SIA with a longer time series, you see Kotzebue on one side. The communities that are associated with these fisheries are highly dependent on chum in particular. On the other side is Bristol Bay, highly dependent on sockeye in particular. And then throughout those tables, you can see the other communities fall within that scope, and that longer time series of information with the species diversification also allows you to see how species diversification has shifted over time. If, for example, the abundance of Chinook is lower or there's management measures in place to restrict Chinook fishing, the proportion of revenue coming from one region may shift more towards chum. This section sort of wraps up with a discussion about how, in addition to direct revenues generated from these fisheries, declines in commercial chum salmon fishing opportunities fit into a broader economic and social framework. Some of these dimensions are highlighted in the paper. Many communities across Western and interior Alaska have mixed economies, as Kate spoke to. That means a dependence on both subsistence food production as well as a cash component from employment. And her sections also highlight how subsistence and commercial fishing can be interconnected in many ways. So, for example, how commercial fishing income can be spent on subsistence equipment and or used for both types of harvesting. The literature highlights an overlap in commercial fishermen and also what can be called a super producer or super household, individuals that may harvest a larger amount of fish, subsistence fish, and share it with others in the community. And also it represents a seasonal employment opportunity that allows for more flexibility for accessing subsistence activities, fishing, hunting, fitting into a seasonal schedule. So closures to commercial fishing in addition to subsistence can represent a double blow to food access, not only not having the ability to harvest their own salmon, but also challenges with being able to afford purchasing food at the store, which can be particularly expensive in rural communities. So often economists will use a economic impact kind of framework to contextualize how an event a proposed change or action might affect a community and support sectors. Using this lens here can be a bit awkward because if you just focus on the movement of money through for-profit businesses in the community, there's a lot of other values that are represented here, and we try to just qualify that a bit in this section. So there's limited number of for-profit businesses with goods and services in most of these communities. In addition, as I highlighted in those tables, these are highly local fisheries. And also the literature highlights the cultural importance of sharing, which can include one's labor. So just focusing on the movement of money can miss some values there. Cash can be exchanged for assistance or use of equipment, but also there's bartering and sharing of salmon harvest, and sometimes expectations and responsibility to participate without money exchanged. With the limited businesses available to provide for-profit services in many of these communities, developing skills and knowledge for commercial fishing and boat maintenance and equipment repair is another extremely important value. And then we just highlight here that the presence of commercial processors is another important component for having commercial fishing opportunities in these regions.
Ms. Meriden, before we move on, Mr. Twite.
Thanks, Madam Chair. I'm not sure which staff this question is directed to, but the discussion of Western Alaska commercial fisheries includes Bristol Bay, but the discussion of subsistence fisheries doesn't. And maybe I missed the reason why, but I couldn't go back and find it.
Thank you for the question, Mr. Twite. I'm happy to answer that. So in preparing the SIA and working with the Division of Subsistence, the starting point for determining the areas that would be included was really staff workload and the amount of time that would be available to prepare the analysis. And we knew we wouldn't be able to have consistently available information across all of the regions of Western Alaska and Kotzebue Sound. So we tried to make some prioritization, and we thought about several factors, and one of which was just the geographic distribution of the coastal Western Alaska stock reporting group. And then looking at the council's indices, which identify the Norton Sound, the Yukon and the Kuskokwim areas. And then within the Bristol Bay region, chum salmon is a relatively small proportion of total subsistence harvest of salmon. So those were some of the considerations that we made when we decided which areas to prioritize. But we have several caveats, and I would just put it on the record that we're not trying to imply that salmon or chum salmon are not an important subsistence resource for these communities and regions. It's just trying to be pragmatic about what we could do with what we had.
Thanks, and I appreciate that. I think that kind of prioritization, given the timelines we were working under, is essential. The follow-up question, though, is, do you think that priority hold, depending upon how much time and resources we have to devote to coming towards a final analysis, is that this, if there are sufficient time and resources, will staff include a discussion of Bristol Bay subsistence, or is that kind of a gate we've passed through without going back?
Thank you, Mr. Dwight, for the question. I apologize for not covering it in more depth in the presentation, but it's section 4.3 of the SIA that really walks through some of those introductory considerations. And I think if the council would like to direct staff to provide that information because it's helpful in informing its decision making, then we can go back and try to add that. But I think a caveat and a consideration is the amount of information and requests that are coming to staff and trying to make those balancing choices as we move forward and have to figure out how to work with the page limit consideration. So if we do that, maybe we can expand the scope of regions, but I'm trying to be reasonable about setting expectations of the scope of information that could be there.
And Madam Chair, now we're moving on to impacts on chum under alternative one status quo. This table in your document just gives you the overall chum, salmon bycatch by sector in the fisheries from 2011 to 2022. There's obviously significant interannual variability in this, and there is differences in the bycatch patterns at the sector level, which we'll continue to go over, as you heard in Dr. Berry's presentation as well, with the majority of the bycatch attributed to the inshore CV sector, followed by the catcher processor sector, mothership sector, and the CDQ pollock fishery. Moving on, then, this is figure 610 in your document. You talked to Dr. Berry about this previously. This is showing the 2022 only locations on the left, and then the cluster, the amount. This is total bycatch. So I'm going to try to go back and forth. And as you did with Dr. Berry, it's going to depend. The more you divide things out, the harder it is to give you all of the information at the same time. So we'll go back and forth between total bycatch, Western Alaska bycatch, bycatch by sector, bycatch by time, and genetics. So this here is showing you to the right, figure 610 gives you the total from 2011 to 2022 of the bycatch by sector, by cluster. Again, in this portion of this discussion, we are only talking about the 4 clusters. We are not talking about the fishing areas that you heard in his Dr. Berry's presentation earlier this morning. That is touched on under alternative 4 in the IPA proposals, but the way that the bycatch is described in this section is by those clusters. So again, that previous figure was the total over all those years. This figure is not in your document, but it's the figures that underpin the figure that's in your document. So this is by year rather than over all years summed together, just to show kind of the interannual variability. Again, it's the exact same by cluster, by sector, overall bycatch, just to show you the overall variability as compared with the totals that you see in the figure that's in your document. We tried to summarize. There's a lot of information, so we tried to use a lot of summary figures that often are cumulative, but to the extent possible, we were trying to show the interannual variability and including both additional information in this presentation as well as in appendices to your document. Going then on in terms of status quo, so looking at the number of Western Alaska chum table in your document caught as bycatch by sector 2011 through 2022. This is, you saw a version of this table earlier in the description of alternatives. And it's important to note here that this is where we start to run into trouble. So when we are taking the bycatch overall, looking at it by sector and trying to estimate the Western Alaska component by sector by year, there will be years where the sample size is insufficient to be able to estimate that. And that's what you see for the CDQ fleet for multiple years, as well as in the CP fleet and the mothership fleet, CP in 2012, mothership in 2012 and 2014. So that's an important consideration as you start to try to think about formulating what you're trying to look at in area and time and for Western Alaska, is that there will continue to be, we would assume that there will continue to be sampling size issues moving forward, depending on how you're breaking everything down. This then is going back to looking at the early, middle, and late stock composition estimates. So this is across all of the stock compositions. And then the table below, it tells you what the weeks are and the associated weekend calendar date closure dates that are associated with the early, middle, and late. As you heard from Dr. Berry's presentation, and we have a different figure in the document as well, you can also break it out by just early and late. And that would fall, I believe, around week 33 of the middle. So when you're talking about just early and late, I believe you're combining early with the first 3 weeks of middle, and then late becomes from week 33 on. So this is showing you the relative contributions in 2022 only. So not by year here, just for 2022 only. You heard the 2023 discussion by Dr. Berry this morning. Now taking the same information and looking only at the Western Alaska reporting group. So this is giving you by year from 2011 to 2022, the early, middle, and late for Western Alaska reporting group only, again, for those same weeks. This does not, though, break it out by sector, because this is where we can trade off in terms of time and genetic composition. We can't always trade off in terms of time, sector, cluster, genetic composition, because the sample size isn't sufficient. this figure is also not in your document, but is the same information that is included in other documents, but just to compare the previous discussion by cluster. So this is the Western Alaska by cluster, not in time now, just by cluster, by year. And comparing that in terms of the cluster of the Asian chum, so that you can see the difference between specifically Asian chum by cluster in year and the Western Alaska chum by cluster in year. This figure you'll hear in the IPA report as well, just understanding that throughout all of this, under the status quo, we do have a rolling hotspot that's ongoing and moving the fleet around. So this is just a summation of all of the rolling hotspot closures that the IPAs have put into place between 2017 and 2023. And this is in the report that you'll receive. This is what CState does in moving the fleet out of those areas. So understanding that underpins all of the results that we're looking at for status quo is that the fleet is still being moved out of those areas at that time. Okay.
Looks like we might have a question or two for you. Mr. Twite.
Thanks, Madam Chair. Dr. Stram, when I look at this, I can't, the graphic showing the closures that have been implemented, I can't help but sort of try to compare it to the information, the fairly fine scaled information that we saw, say, in the genetics presentations of areas of higher Western Alaska. And I realize these boxes, I believe, are just based on chum, right? Not Western Alaska chum, but just chum numbers in general.
Through the chair, Mr. Toy, I think it's a mix of both. I think they are informed closures, and that you will hear there's more. I'm sure that you can ask the representatives from the IPAs that in terms of they have some known areas from previous years genetics that they might isolate more, but in general, those rules are based on their rates for overall chum with the underpinning understanding of what they do know of where Western Alaska chum might be more prevalent.
Thanks, that's useful. So, and I should be really cautious about stretching this too far, but that usually doesn't stop me. I'm just wondering, as you look at this, and because you've probably had some of the greatest exposure as a staff person to this sort of presentation of areas of chum concentration versus, say, some of the work from the genetics, are there similarities that jump out at you? Are there differences that jump out at you between this kind of a picture of areas that have had quite a few chum and some of the genetics work that has been summarized on a spatial temporal basis?
Through the chair, Mr. Toy, I think that would be really difficult to take that leap because the compilation of closures you're seeing here are in both space and time. And I think that you would need to start comparing probably annually, but also in terms of, so we were looking at the genetics in terms of space and time, and then by sector. You're looking at a compilation of closures that have a variety of back rationale for when they were put in place, why they were put in place, how long they were put in place. This is only a snapshot of that. So I think it would be, I mean, you can see from the color coding which years they are attributed to, but I think you'd have to look at them on the same time and spatial frame with the genetics if you're going to try to make some inference as to that.
And Dr. Stram, before we move on to too much further, I'm wondering if I really appreciate you putting these slides together, page 79 and 78. Is there, or 79 and 80? And maybe some of the summaries will be similar to what we heard from Dr. Berry, but are there any overall takeaways or just summaries or summary that you can provide on these slides as far as major themes that we should have our attention brought to? Thanks.
Thank you, Madam Chair. So it's very similar to what you were hearing from Dr. Berry this morning in terms of there is variability. So going back to this slide that is in your document, I mean, there is variability in year to year when there's more in the early than the late. We've, in terms of the Western Alaska timeframes, we do see more consistently, when you look at clusters, we do see fairly consistent year to year prevalence in cluster one. It's difficult when you're comparing comparisons in time with comparisons in space. We're trying to pull them all together. But the way that you divide it out, you end up with different, I mean, if we could do early, middle, late, cluster, sector, you would probably be able to narrow in on that, but that's when it breaks down and you can't do all of those things at the same time. So generally, early and middle, higher, Western Alaska, not always completely consistently, generally cluster one, some cluster two, more prevalent Western Alaska. So that's what we've been trying to narrow in on, and then trying to play around as Dr. Berry will be doing more moving forward with more specific areas, as you heard, like fishing ground areas, and then seeing whether the sample size is sufficient to drill down into that further. Madam Chair, moving into, some of these summary slides are not, this information is not necessarily reflected in your document, but was put together given some conversations that have been had this week in terms of how do we look at the impacts of the status quo on chum stocks, and what we can do to better estimate that. So I have a few slides to walk through what is an adult equivalency analysis, what the information is that we have to do it for Chinook, what information is available for chum, and given the data limitations, what we think we might be able to do. So I can go through that now. So generally, looking at adult equivalence, what does that tell us? It tells us the estimate of the number of fish in a given year that will return to a river system based on the number caught, the age of the bycatch, and what proportion by age would return in a given year. This is contingent on the stock composition and the broad genetic breakouts that we have, and they're similar for chum and for Chinook. It also provides information on fish in a given year, as well as a lag of fish in subsequent years following a spiky or higher bycatch event. And I'll go through the information needs to do this. What have we previously done? We've done this for Chinook. It was most recently updated in 2022. And when we get to that later in this presentation, I would just highlight and caution you that the analysis that was done in 2022, which for Chinook brought us through 2021, we did not have the genetic composition estimates in those more recent years. So most recent year in 2021 was estimated based on previous years. You've now heard more information from Dr. Berry because all of those analyses were updated last year. So if we were to rerun the adult equivalency, you might see slightly different results, given that we have the bycatch information that we were lacking at the time. We do have run sizes for Western Alaska Chinook River systems. And so because of that, we can estimate an impact rate, which is the AEQ divided by the run size. What percent of the run did not return in that year? Again, with the issues of being at the scale of genetic stock composition. So I'll return to this later when we talk about Chinook, but I just wanted to put this figure in here to tell you what the utility can be of having an AEQ even without an impact rate. And so this is showing you historically in red the bycatch of Chinook in the pollock fishery. And then from the time that we did the AEQ, and this is again overall AEQ through 2021. And the important part here to see is that while we often say that the number of fish so the Western Alaska number of fish in a given year, not all of those would return necessarily in that year. So that's where you see the AEQ is less than the overall bycatch. But what you're also trying to capture are the dynamics where if there is a high bycatch event, even if you have very low bycatch the next year, which is the difference that you see between 2007 at the top and 2008, 9, and 10 at the bottom, there is also a lagged effect from the fish that were caught in the bycatch in a very high year and the age composition of those. The AEQ is taking into account that not all of those fish would have returned in that year, but they would have returned in subsequent years. And so that's the kind of information that you would get to understand that a very low bycatch year could have lagged effects from previous years. A very high bycatch year may not be as high as what you're thinking it is at the time. But again, the information to understand that there is this lagged effect.
Dr. Stram, a question, Mr. Mesereau?
Thank you, Madam Chair, and thank you, Dr. Stramley. That diagram, it would probably look, but what my question is because the life cycle of Chinook salmon is so different than chum, that lag might be really different for chum because they don't live as long. Does that make sense?
Mr. Chairman, Mr. Mesereau, also taking into account the age in the bycatch. So the ages in the Chinook bycatch might also be closer to when they're maturing than in the chum bycatch. So when we get into data available to estimate this, we'll see we have pretty decent information to try to estimate. We know the ages for Chinook. We have a lot of more information from Western Alaska rivers to make a good assumption of in-river age composition for when they would be coming back. We're going to start to lack that for chum because while we have the ages, we don't have we have to make assumptions on the maturation by year. I don't know if that gets at your. Okay, Madam Chair, moving on then, just for comparison, before I get to chum, and we just talked about this a little bit right now, in terms of what is the data that we have available to estimate AEQ and what's the source of that data. So number of chum caught in the bycatch, as you've already heard from Dr. Hapola, there's a complete census for all salmon, not just Chinook, chum salmon as well. So we have very good, extremely precise census numbers of the chum caught. Age of the chum in the bycatch, there's scale analyses that are done by Ocbay Lab, both for chum and for Chinook, to give us that information. Genetic stock of origin, again, this is what you just heard from Dr. Berry for both chum and Chinook, breaking it out as possible temporally, spatially, by age group. Maturation rates by river systems, we look to ADF&G to give us information on that. What you see in the chart to your right, this is from the AEQ update from June of 2022 to show you that this is the kind of information that we're using and still making some assumptions on. But basically, from this table, we had the in-river age composition from Kuskokwim, Yukon, Norton Sound, Nushagak, and the Upper Yukon. And then what we did was weight those. So rather than considering them all equally, we weighted them by the relative mean run size and came up with a weighting scheme of how we would do the in-river age composition. We also have to make estimates of oceanic natural mortality by age, and that becomes an estimate as well. And here, the estimate was very conservative of oceanic natural mortality, higher at younger years, less at older years, but we tried to err on the conservative side. Then moving on.
Dr. Sherman, I'm sorry to abruptly pause here, but this might be because there are a few slides going over chum, and this might be a good place to take a break for lunch. So appreciate your patience there. So let's do that. We'll come back at 1:10 and reconvene our discussion on C2. Thank you. Council, please come back to order. So we are continuing our conversation on agenda item C2, and we have staff here ready to present. I think we're on slide 85. And any members of the public listening in, just a reminder, we have a couple more presentations to go through, but please do monitor our conversation and sign up for public testimony before the end of this agenda item. Thank you.
Thank you, Madam Chair, members of the council. Just to remind you where we're at near the end of impacts of status quo on chum salmon. And so we're walking through in terms of the difference between what information we use to estimate a Chinook AEQ, and then we'll be comparing it with what information is available for chum salmon and what we can try to do in terms of utilizing that. So just before we move off this slide, just reminding you in terms of the data sources, the data that's necessary and the sources of those data. And one of the main things here as a take-home is that we did use Western Alaska in-river age composition information, weighted it by the relative magnitude of the run sizes, and used that weighted mean in-river age composition to estimate in terms of maturity by age class for the AEQ analysis. Moving forward then in comparison, and sorry, I would just stress that we also obviously have the run size information for the Chinook runs. And when we get to the Chinook section, I'll show more on the Chinook AEQ and the impact rate. But we know that we do not have the run size information that we can use across coastal West Alaska in order to estimate an impact rate that we don't have. So then the question becomes, what's the purpose in estimating an uncertain AEQ if we don't have a run reconstruction to do that? So this table is in your document on page 140, 141, figure 617, and trying to look at, in terms of relative uncertainty, what information that we have, and then we can accommodate the uncertainty. Just we start to layer on assumptions. And so again, as with Chinook, we have precise estimates of the number that's caught. We know from scale analysis what the ages of the overall chum and the bycatch is. We then have the genetic stock of origin, everything you heard from Dr. Berry earlier. And we do not have the same level of information on maturation rates by river system. There are the only estimates I believe that we would have on ocean mortality are limited to Asian stocks, but we could certainly look more into that, keeping the expectation that we cannot do an impact rate. So moving on, what could we do? And again, this information is not in your document. This is trying to build on discussions we had with the SSC and considerations we had in doing this analysis. Is what could we do? Well, for CWAC chum, we do have an estimated age composition by the stock. We would make assumptions of the maturity. We would likely bookend. And if you remember back in June of 2022, we came to you with all the salmon reports. We came to you with a short discussion paper of data limitations and what assumptions we could make to move forward for chum. We would bookend high and low assumptions by age. We would most likely use available estimates from the Yukon summer chum to inform those assumptions and those bookends. We would also make an assumption of ocean mortality by age, probably also in a bookend C. We did do something similar for Chinook. We used a conservative estimate of ocean mortality. We then did a sensitivity analysis, and it was the AQ itself was fairly insensitive to changes in ocean mortality. So we could do something similar to that. Again, we have layers of assumptions. For Yukon fall then, which is not exactly equal to the upper Yukon chum stock. There are parts, so we have the estimated age composition by stock. There's limitations to that as well. But the summer, there are non-trivial contributions in the genetics of the summer run stocks in the area that's currently defined as upper Yukon in the genetic analysis. However, it's my understanding from talking to Dr. Berry that those analyses could be rerun so that what they call the upper Yukon would not include any contributions from other stocks, so that would be a more exact matching of Yukon fall with what they consider to be upper Yukon. So we would be able to do that. We do have assumptions of maturity. It is a run reconstruction for the upper Yukon, for Yukon fall, sorry. So we have assumptions of maturity. We would make an assumption of oceanic mortality, but we do have a run reconstruction for the Yukon fall stock. So you could come up with an impact rate. I would caution that, as we said in June of 2022, the only problem in terms of doing this is a matter of communication. And we don't necessarily know that an impact rate for the Yukon fall stock would be indicative of what else is going on in Western Alaska. So we would work closely with the state to make sure that any of our conclusions or information moving forward, keeping that in mind, that you would only have that impact rate for the Yukon fall stock. Just to take this a little bit further in terms of the age proportions. So I just wanted to highlight for you in terms of the information that we have, how variable it is, and then the information that we don't have that we'd need to make assumptions on. So first, looking at the ages, and you heard some of this from Dr. Berry, there are age estimates for the coastal West Alaska stock composition by age. And so what you see in that second line for the 3, 4, and 5-year-olds are the numbers at age, and then below it, the range. So the variability around that range, which could be somewhat substantial. So understanding that doing this, we would have be characterizing the substantial uncertainty. We also do not have enough, there's not enough samples, as I understand, and the age proportions to estimate by stock composition, the 2-year-olds or the 6+ group. So we would have to make an assumption of what the number proportion by age those are. I believe that is similar to what we did for Chinook for the AEQ, with those outer edges of the age groups where there wasn't sufficient sample size to know the ages of that stock composition. So that's what would be done here. And then again, as with what I mentioned in the previous slide, we'd have to make assumptions of maturity and ocean mortality. Now moving back to what information is currently available. And again, I'm sorry.
Sorry, Dr. Stram. Question, Ms. Vanderhoven.
Thank you, Madam Chair. Thank you, Dr. Stram. If you said I missed the variability line, is that over the 10-year, 11-year period that we've looked at for the analysis, or what was the time period there? Did I miss what variability was?
Chair, thank you so much for the question. That's the information I forgot to put on the slide when I was making it. This is just for 2017. I just picked a year that had a higher number in the bycatch, so there was more likely to be samples. And so I took 2017, and I apologize for not explaining that from the beginning. So this is just the point estimate and the variability around it for those age classes for coastal West Alaska in 2017. The information can be done for that right now. And I might have to look to Dr. Berry for help here. I believe from 2011 through 2019, that is completed. For the more recent years, I think that can be run. Again, you're going to have this variability, and there are some there's some assumptions, I guess, that are made in terms of taking the age and then estimating the proportion and then multiplying that proportion by the numbers. So we can do a number of things. We just will be making more and more assumptions and a little added uncertainty.
And Mr. Mesro.
Thank you, Madam Chair, and thank you. I guess my question is, when I'm looking at this, I'm hearing that there's a lot of variability and a lot of assumptions. And is there some point where there are too many of those things to have a tool that we can use to determine this information? And if there is it appropriate for the staff to inform the council that there's too much variability to do this, or is it a policy call?
Thank you, Madam Chair, Mr. Mesro. I think that's where we landed when we last discussed this, is that we tried to lay out what the uncertainty was. So we did not go forward with doing it. If we are directed to, and it seems that I have not seen the SSC report, nor will we available for their discussion, only their questions directly of staff. But should the recommendation come forward that this would be informative in terms of an impact analysis, and I would also caution that it would be more informative, I believe, as an impact analysis of status quo. When you think about us projecting that through alternatives retrospectively, that even adds more layers. But I think where we're thinking of it is, if we were asked to do this, we can do it. We have always been able to do it. It's just how best we characterize variability and what's the utility of doing it when we cannot give you an impact rate.
Ms. Kimball.
Thank you, question is a variation of Mr. Mesereau's, and I appreciate that you couldn't listen to the SSC discussion, but I'm trying to summarize it and I'm looking for your feedback on whether it's correct that we have a real problem with not analyzing status quo, right? It is impossible, I think, for decision makers to know what impact we might have on of these alternatives if we can't compare it to status quo. And so it is seem like a problem worth solving and spending time on. How I was seeing it is we could do an AEQ as you described with all of those caveats and many assumptions. And it's not the first time you've described those to the council. I heard you also say we could also do, because the information is more robust, an AEQ just for the upper Yukon. And then we would be making the assumption that that would be representative of all of coastal Western Alaska trends. We would be using that as our bellwether. No.
I'm sorry, through the chair, I'm Ms. Kimball. No, what I'm trying to say is that we can do that. We can have that impact rate, but we would not want to use that as an estimate of our impacts to the other stocks. That would be the important part in the communication of it, is that we would not want to use that just because we can calculate it. We wouldn't want that to be taken out of context. And I think that's the fear that's the concern with all of this, is the context within which we are estimating. I do think, since talking this through this week, there is a utility in being able to see how that AEQ can be lagged and getting a better understanding of what happens in a high year versus a low year, where in terms of propagating forward. So that alone as a concept in AEQ, I think is worth considering. And I think that if we have the ability to appropriately caveat the uncertainties and the utility, then perhaps that would help us better estimate the impacts of status quo. But when we've had these conversations before, that has been the limiting factor. Not that we couldn't do it, but whether or not we should do it.
Thank you for that. So I'm crossed out upper Yukon because it's possible to do, but it would be inappropriate for what we're trying to achieve, I think, in our decision making. But the third idea was how we then can take the information we know, not go forward with the AEQ with a lot of assumptions, but put that level of bycatch in what we know about other removals, escapement that we do know for some systems, and put that in context, I guess. So that seems like a third option, maybe, in trying to estimate impacts of status quo. So then we can then say, are we making any difference with X, Y, and Z action alternative? So I heard you say, and that you hadn't heard the SSC. Maybe this is a discussion. Do you think this is a discussion we could return to once we all have the SSC report and really sort through and give some helpful direction, so you're not coming back with all the potential options next time?
Madam Chair, Ms. Kimball, yes, I think it would help us to be able to see the SSC report and then circle back to this discussion. And I didn't mean to say that we wouldn't do an impact rate for Yukon Fall. I think that that would only be in assessing impacts to the upper Yukon, the Yukon Fall chum stock, and not something that we would want communication wise carried forward as well. If it's this for that, then it must be similar for the coastal West Alaska. I do think putting it in the context, and later on in this presentation, and unfortunately not in the document, we have tried to put together some tables that give you some context to the bycatch status quo and bycatch under a restrictive alternative where there's more salmon saved, and what context that fits into with other sources of removals. We didn't compare it against escapement or run reconstructions, but again, we can try to take those results and compare them more against different things. And you'll see you'll see a couple tables of the context of overall removals as compared to bycatch or bycatch under one of the alternatives, if that helps.
Thank you. That does help. And I just started to think about our congressional requirement that we limit the page numbers. I can't remember what it is. It seems really small. 150. Mr. Mesereau just said. And so there is a lot of description, a lot of very good background in this section and in the draft overall. There's a lot of time spent on kind of what fisheries could benefit if there were benefits. And so I'm wondering if you see an opportunity to shift that a little bit, where we spend more analytical time on what are the benefits, and can condense some of the who would they go to. That information is important, but trying to determine whether we can have an impact and what level of impact is also as important.
Through the chair, Ms. Kimball, we've been talking amongst ourselves as staff as to how to meet those page requirements and how to more executive summary the overall DEIS. And I think when we come out of this meeting, that's what we will be doing as staff, is trying to see what's currently in your draft was intended for context, and what of a shorter version with other things available by reference would be most useful in decision making. I think that this might be my last slide as it relates to this, and then I have a couple slides on cumulative effects. So this is just to provide for you. You heard some of this from Dr. Berry, but just looking at the overall bycatch. So this is obviously not including an AAQ, but looking just at the overall bycatch numbers from 2011 to 2022. And this information is all in tables, but I just wanted to put it on a figure here. And then looking at what that translates into in terms of Western Alaska bycatch. And as you know, as you heard previously, the difference between the proportion by year. So that in the upper right here, it's just plotted for you the Western Alaska bee season proportion and how that can change from year to year. And that has a dramatic effect on what you see as the Western Alaska bycatch component. So the difference between 2021 and 2022 is the most noticeable, where you had twice as much bycatch in 2021, but half the bycatch in 2022, and a much higher proportion, over 20%. And so understanding that is also built into what we look at under status quo, and as it relates to your alternatives that are addressing Western Alaska bycatch, that's still variable. This is over all areas. This isn't attempting to break this down by the cluster areas or anything like that.
Dr. Stram, a question for you. Ms. Baker.
Thank you, Madam Chair. And I apologize. I was paying very close attention to your exchange, Dr. Stram, with Ms. Kimball. And I was wondering, you referenced at the end of that discussion the additional information provided in this presentation, but not in the analysis, providing essentially the chum bycatch and the pollock fishery with respect to other removals. And so, yeah, my question, is that going to come later in the presentation, or I wondered if you reviewed slide 88, and I was getting a little lost because I was thinking that looked like another table that maybe contained that information. I'm not sure. I have a question. Can you go over slide 88, please? I think I talked myself out of a question.
Thank you. Through the chair, Ms. Baker. Yes, I would say, first of all, to answer your question, that that information is still forthcoming. I start with it under the cumulative effects looking at area M, but then when we get to the impacts of our alternative 2, we put together a table of total removals compared to estimated bycatch under one alternative and apportionment option. So I skipped over, but you've already heard the recap. We only received the genetics results the day before this draft was published. So we have a very short summary of the genetics results from 2023, but you've already heard that in depth with Dr. Berry, and obviously that would all be included in the next draft. So just a quick summary of impacts then. In terms of the variable and the bycatch for coastal West Alaska, from a low of over 3,000 to a high of over 65,000 over that time frame, and then the most recent years. I already went over the 2021 and 2022 difference. That's completely related to the relative proportion of Western Alaska in the bycatch in a single year. Upper middle Yukon reporting groups are also variable. They can range over that time frame from 0.5% to 8.9%. But the relative contribution in the bycatch tends to be a lot lower. You just heard from Dr. Berry that the last 2 years, that this year, and then we went and checked again for 2022, were statistically zero in the bycatch. So again, these proportions are highly influenced by fishing locations annually by sector. And then this summary is on page 143 in your document, and I just want to reiterate kind of what we've been talking about in terms of our ability to summarize the impacts and the limitations to estimating those. We contain a discussion in there. We know that the Western Alaska salmon populations vary in their productivity and life history characteristics. They may contribute to their sustainability or population viability, which is important for the resiliency of chum salmon stocks, particularly in the face of climate change. But when we received a contribution from a contributing agency on highlighting specific spawning populations and their contribution to genetic diversity and viability. We have limited information in here on the specific spawning populations, and given the data limitations we have, it does make it difficult to understand how each population may or may not respond to bycatch and other environmental factors when we start to drill down to talking about something that we can't estimate any impacts to. So the data to estimate the impacts of bycatch on specific spawning populations of chum aren't available. They'd be very difficult to collect. And if they were available, again, we'd be making a number of assumptions in order to estimate impacts. So we just point you to a footnote on page 143 regarding the potential impacts of discrete spawning populations. We are not able to estimate impacts to these levels, but we do seek feedback on the feasibility of including a discussion of specific spawning populations and the potential of them to contribute to the genetic diversity of the stock in a future iteration. And you may hear more of this in public comment as well. With that, I just have 2 short slides and then I'll turn it back over to my colleagues. This is just a short section on cumulative effects. Again, this is getting at the relative removals. So this is looking at the Area M chum harvest, the South Alaska Peninsula commercial fishery that is on the South Alaska Peninsula Management Area. This slide just gives you there's estimates of stock-specific compositions of the harvest rate of the South Alaska Peninsula. And this is a new study from 2022 in terms of the relative contribution. So this slide shows you in June and post-June. The 2007, 2008, and 2009 estimates are from the WASP study, which is known to be the most comprehensive study of the stock composition of the South Alaska Peninsula. And on average, it was about 57% of the chum salmon harvest in that fishery were of coastal West Alaska origin. This 2023 study that was done was more of a preliminary study, but the relative proportion of the CWAC stocks in that study in June declined from the WASP study. And so the relative proportion was 18% of the overall harvest in that fishery. So in an attempt to put this into the scale that we're talking about, again, this is cumulative effect. This is something that is outside of the jurisdiction of this management action, but likely to continue in the future. We took a conservative estimate. On the left is the overall South Alaska Peninsula chum harvest. On the right, then, looking only at June, because June has the highest proportion of the coastal West Alaska component of that stock, we used the 18% harvest rate from that 2023 study, 2022, and multiplied the total June harvest by that 18% to get some sort of relative contribution of what's removed in that fishery going back to coastal West Alaska as compared to the status quo total Western Alaska chum bycatch. With that, we will return to this aspect of it when we add in the other sources of removals from commercial and subsistence fisheries, all of which are also known mortality on coastal West Alaska stocks.
Thanks. So Ms. Marin and I just have a couple of quick slides here to summarize the potential impacts to communities that are engaged in and dependent on subsistence harvest of chum salmon and commercial salmon under alternative 1. As Dr. Stram has noted, the impact of chum salmon bycatch occurring in the Bering Sea pollock fishery on Western Alaska chum salmon abundance, and consequently the impacts of the status quo regulations on subsistence fishing opportunities is uncertain. And in trying to conceptualize the potential impacts, we walk through these points of uncertainty. Although we cannot quantify these impacts to subsistence users and communities, we would expect that selection of alternative 1 would maintain this level of impact. We also note that fishing behavior can still change under the status quo regulations, wherein bycatch would be or could potentially be reduced from status quo levels. And we try to highlight that the outcomes for subsistence users are uncertain and affected by a variety of factors that are external to this marginal impact analysis that's focused on bycatch reduction measures. And these include environmental factors, in-season management actions, and other considerations that can be unique to each household and community.
Ms. Kimball.
Thank you. I'm just trying to follow along and maybe it's too related to previous discussion with the middle bullet, the little arrow bullet, and then the sub bullet underneath it. And I think you said it as if, although we don't know the level of impacts, we would expect under alternative one to those impacts to continue. I know there's a lot of uncertainty around this, but I'm looking for some confirmation that we will be able to kind of get beyond this as our basis for the next version. I just don't think it leaves us anywhere to really go.
Thanks, Ms. Kimball, for the question through the chair. I think there's some level of specificity that we might be able to walk through in the written document. As Sarah and I wrote the SIA, we tried to describe some of the trends in bycatch, but without the AEQ, without an impact rate, we didn't try to go further than that. I think for subsistence users, we might be able to provide some more specificity, but we're going to be very limited in our ability to break anything out in terms of area or river systems. So in that sense, I don't know how much further we'd be able to go. And I don't know that we've ever really been able to get there in terms of subsistence use in communities, but I hope that answers your question.
Follow up, and yeah, I would not expect you to be able to break it out by system or community. That seems well beyond the data, but being able to relate some level of impact to subsistence salmon fishing. I think you start to try to talk about that in that sub bullet. But we're not just trying to avoid salmon for just salmon's sake. We're trying to avoid salmon in order to provide healthier returns to Western Alaska, more subsistence opportunity. And so I'm hoping we can get kind of beyond the just it's uncertain, you know, try to make a decision, but a little bit more, maybe based on what we talked about earlier in the SSC discussion about trying to put things in context. And if there's any opportunities to come back to these kinds of conclusions, maybe that's something we revisit after we see the SSC report also. Thanks for your indulgence.
Well, Madam Chair, I have similar conclusions here, so there might be some more feelings about them. But for the commercial salmon fisheries, this is, you know, one management step removed for subsistence. So under status quo, we've got the same management system that would be in place, managed by ADF&G, and we can sort of walk through, as we've been doing, the places where we can try to provide more certainty and context. We know the number of chum, salmon, PSC in the pollock fishery. We have good estimates of the proportion expected to originate from Western Alaska and upper middle Yukon. And there's some proportion of adults that would be expected to return to Western Alaska. Maybe we can get closer to those numbers or contextualizing them. The analysis doesn't further estimate the impact on these stocks. And we certainly don't go to the level here of trying to get down to what that means in terms of commercial fishing opportunities on a specific river or tributary. And I think that is the part that in the future too, thinking about the SSC comments, we're still going to struggle with. I do understand the discussion at the SSC and probably more here about further contextualizing and bringing that other level down so we can kind of get closer. But I think that piece is always going to be inherently difficult, is what does this mean for commercial opportunities on a specific river? And having some of that context could help, but we also have a series of management decisions that ADF&G makes when they're thinking about whether there's enough for subsistence opportunities and then commercial opportunities. So there's going to be some pieces in there that will involve uncertainty. Choosing alternative one would be expected to continue this current level of impact as it results from status quo regulations to commercial salmon fisheries. However, like Kate mentioned, the conditions under status quo could change outside of what these regulations would directly influence. So that includes environmental factors that could be more or less favorable. It also includes additional behavioral changes from the AFA fleet outside of what the status quo regulations would specifically require, which could have downstream effects on Western Alaska chum bycatch as well.
Okay, Madam Chair, we're moving on to impacts on pollock and then on the pollock sectors. So just starting was a couple of brief slides on the pollock stock. This is a figure that you see every year in your status of stocks report for the Bering Sea Aleutian Islands. And so we're just pointing out, just to orient you again, that this is on the x-axis, the biomass as estimated in 2023. That's the most recent year of our stock assessment. As compared to its target biomass at BMSY, and then comparing it to catch in the previous year to get at whether or not overfishing occurred or the biomass dropped below a level in which the stock would be considered overfished. So looking at the blue dashed line is your target line of 1. And as you can see from this shows all of the stocks in the Bering Sea, but as you can see from this, pollock continues to be presently well above its target biomass levels. As I indicated a little earlier in terms of our looking at a scan of what lens we were seeing impacts to pollock stock on. So just we're trying to look at general pollock spawning, feeding, and predators under current climate conditions. Understanding that pollock spawn during March to May. They're in the east middle shelf in warm years, west outer shelf in colder years. The eggs and larvae are planktonic for about 90 days. Advection affects the dispersal of these and results in separation from predators. The available feed affects their overwintering survival, and that can vary in warm and cold years. The main prey for juvenile pollock is calanoid copepods and euphausids. Their diets become more pisiferous with age, and the age 0 are less able to avoid the cold pool while the adults move away from the cold pool, and that's always reflected as you see in your biomass estimates that you see annually. With respect to pollock predators then, as you know, pollock cannibalism might be expected to increase as the biomass of older and larger fish increase in the population. There is first seal consumption of adult pollock that generally increases in years when juvenile pollock are less abundant. And then there is, from recent studies as well, chum consumption on age 0 pollock. And then in terms of current climate effects, impacts in pollock, the pollock distributions are affected by the cold pool extent. That is again included in the assessment that you hear every year. And again, the adults tend to avoid the cold pool. During warmer years, the distribution shifts northward. Sea ice also affects the timing of spawning, and pollock move from the inner to the outer shelf as they mature. Warmer years causes earlier spawning and the sea ice, less sea ice. And as we discussed with chum, there is increased metabolic rate in warm years.
This next section of the presentation provides some background information on the AFA sectors under status quo. So this is a diagram that demonstrates how the Bering Sea pollock TAC is allocated. So 10% comes off the top for the community development program after the TAC is set during specifications. And then there's an amount that's pulled aside for incidental catch and other fisheries. That's usually about 4%. And then the remaining portion, 50% goes to the inshore sector, 40% to the CP sector, and 10% to the mothership sector. There is also open access opportunity under the inshore sector. In recent years, there have been 6 active inshore cooperatives. This past year in 2024, there were 5 with registered members, and there were some inshore CVs there are some CVs participating in the open access sector in 2024, just for additional context there. Then NMFS further allocates pollock down to the cooperative level and the CDQ level as well. Additionally, we have background material in section 6.1.10 of the document. Some background information on the AFA sector. It highlights B season pollock revenue under the baseline years, revenue diversification, CDQ revenue dependence, and additional investments in AFA vessels. And there's also a section on pollock products and some of the current market conditions. In terms of impacts from status quo regulations on the pollock sector, these background materials are intended to highlight the dynamic conditions under status quo and some of the external factors that will continue to change and influence the sector outside of this marginal decision points, the marginal decision points that are being considered here in this analysis. However, the status quo dynamics are relevant to the consideration of the proposed action alternatives as they can interact. So we wanted to highlight just a few points here. This slide has a lot of summary information on it from this section. The figure shows the bee season gross revenue. Gross revenue is represented within the document in two different ways in terms of gross ex-vessel value and gross first wholesale value. Ex-vessel is of course associated with the price paid to the fishermen when they deliver, and it multiplied by the round weight of the fish landed. And then first wholesale value is the price that's associated with the primary product that's made when the product is transferred to a outside of the entity that produced it. And both types of values are included in the document to be able to compare potential revenue impacts across sectors and apportionments, but the ex-vessel values and prices are more appropriate for consideration of CVs and catcher vessels, shoreside CVs and catcher vessels that deliver to motherships that are unaffiliated with motherships, CPs and CVs that are affiliated with motherships. They don't generate an ex-vessel price because they're vertically integrated operations. So we estimate them for this background material and also for the revenue impact analysis in the document. The analysis includes information on pollock products and markets. I have some of the information summarized here. For the market information, we pulled from the Alaska groundfish market profiles. These were published in the 2022 Economic Safe. It highlights that pollock accounts for 42% of the US accounts for 42% of the global pollock market. Russia is a main competitor. There are substitute whitefish species. Bee season pollock is mostly focused on producing surimi and fillets, which are primarily sold into export markets. There are domestic markets for fillets, and the analysis also notes an increased commitment from the USDA for purchasing pollock products. They highlighted 15 million pounds in 2024. We draw from a recent Alaska Seafood Marketing Institute letter highlighting some of the extraordinary conditions facing the Alaska seafood market currently. These are connected to many domestic and global forces that have created really a confluence of challenging circumstances. So this slide highlights increased operational costs, including inflation, supply chain issues, high interest rates, and labor shortfalls, supply and demand imbalances with some countries holdover products, devaluing other products, and geopolitical actions that have constrained market opportunities and impacted competition. Also, as we know, declines in other species like crab can affect the resilience of processing plants in these regions. In the last year, we know of there's been delays in planned capital investments, temporary closures of shoreside processing operations, companies listing assets for sale, among other factors that are driving changes in business relationships among entities with full or partial ownership in shoreside processors. So overall, this leaves the processing sector and also the harvesters and communities that are associated more vulnerable than they may have been relative to marginal changes.
The next couple of slides provide context for the CDQ program, the CDQ groups, as well as their constituent communities in the regions that they represent. As Sarah mentioned, the CDQ program receives a 10% allocation of Bering Sea pollock, and this slide shows the average gross first wholesale revenues that are associated with allocations of Bering Sea pollock, as well as BSAI crab, halibut, Pacific cod, and other groundfish for the status quo period. On average, the CDQ pollock allocation has generated approximately 147.5 million in gross first wholesale revenues accounting for approximately 59% or so of the total revenues from all BSAI fisheries allocations for all CDQ groups together.
So as Kate mentioned,
Dr. Hopper, just a quick question. The last bullet here notes in 2022, that value accounted for 67%. Is that increase attributed to crab closures?
Yes.
Okay. Thank you. So it's showing an increased dependency because of the reduced participation in other fisheries and CDQ portfolios.
Through the chair, yes. And that value is specific to CDQ crab, but some of the CDQ groups have also invested in both harvesting and processing quota share associated with the crab fisheries, but outside of the CDQ allocation. And that's not represented in these values, but that is part of the broader picture of dependency on pollock, that as both the CDQ allocation of crab, the value is less. Also, additional investments in crab are producing less royalties, and so more of a dependency on pollock.
We have another, excuse me, Ms. Vanderhoven.
Thank you, Madam Chair. Thank you, Ms. Marinan. I guess the other part of that too then is that this would not account for non-CDQ pollock harvests from investments that CDQ might have, correct?
Yes, Madam Chair, and that's this slide. So good transition to the next slide. So all of the groups have the CDQ allocation of pollock. Some of the CDQs, 5 of the 6 CDQ groups have additional investments in non-CDQ AFA vessels. Some of these vessels also harvest CDQ, but these are additional access to non-CDQ pollock through vessel ownership. The CDQ groups are uniquely positioned to invest in these operations. The AFA requires that vessel owning entities be at least 75% owned and controlled by U.S. citizens, so they're eligible. And given their allocation of CDQ pollock, there can be economies of scale, particularly if they can harvest their own quota. We don't have a systematic way of assessing ownership, so it's not possible to quantify CDQ groups' revenues, nor is it possible to precisely estimate the relative contribution of royalties earned from Bering Sea pollock. But representatives from all the groups worked with me to capture ownership in table 629. And this is updated in the addendum. There's a few corrections there, and it's just visually represented here without the percentages associated with the vessels. But so 5 out of the 6 groups have additional investments currently. And this shows 32 catcher vessels, 4 catcher processors, and 1 mothership that are connected to CDQ groups through partnerships and some level of joint ownership. And this is outside of the pie chart that Kate showed, which is the CDQ pollock.
As Sarah has mentioned, all of the CDQ groups are engaged in the Bering Sea pollock fisheries through their direct allocation, and many of the CDQ groups have also made those investments into the AFA sectors. And so the SIA considers all CDQ communities as indirect participants in the Bering Sea pollock fishery with varying levels of dependence. The CDQ groups and the communities that they represent are diverse. They range in their geographies across the coast of the Bering Sea, and they have different regional economies and engage their residents are engaged in subsistence. Their geographic dispersion is shown here on the left-hand side of the slide, as well as the groupings by the CDQ groups. And to capture some of this social and economic diversity, the SIA provides high-level summaries of the CDQ regional economies, as well as different indicators for their governance structures and socioeconomic indicators for each community. Section 4.2.7 of the SIA also provides information on the social and economic benefit programs that are provided by CDQ groups. One of the most tangible economic benefits the CDQ groups have been able to provide are various employment opportunities and vocational training programs for residents and non-residents alike. Many of the CDQ groups also support local fleets and participation in small boat fisheries, provide opportunities for community development and infrastructure grants, as well as financial support, subsidizing fuel, fishing gear, and other equipment that's used for commercial and subsistence opportunities. One of the nuances we also tried to tease out in the SIA is that many of these communities, while they're engaged in the Bering Sea pollock fishery and have varying levels of dependence, are also engaged in subsistence and commercial harvest of chum salmon. The next couple of slides move on to providing some background for you on those communities that are engaged and dependent on the bee season pollock fishery under the status quo. So this slide provides for you a summary of community engagement by the registered ownership address of the various harvesting or at-sea processing entities that are engaged in the fishery. And as shown here, as well as in the document, the ownership of vessels is concentrated in Seattle across the various sectors. But there has also been a consistent level of engagement from catcher vessels that are affiliated with Kodiak and Newport. And those Kodiak CVs participate in both the inshore and the mothership sector, whereas the Newport vessels are affiliated with the inshore sector. This slide just summarizes for you a series of quantitative indicators of entities' dependence on the bee season pollock fishery. Of course, dependence is a complex concept with multiple dimensions, but here it's characterized by comparing the gross ex-vessel or the gross first wholesale revenues earned from the bee season pollock fishery to the total revenues that are earned by the same entities in all other areas, gear types, and fisheries. The harvesting and at-sea processing entities exhibit a high degree of dependence on the bee season fishery. You can see that for the CPs and the motherships and floating processors, as well as the CVs that are affiliated with the Seattle MSA, it's over 50%. Under the status quo, deliveries of bee season pollock from inshore vessels have been made to processing facilities in the communities of Akutan, King Cove, and Unalaska Dutch Harbor. As noted in the SIA, there's 6 physical facilities that have accepted deliveries of bee season pollock from 2011 to 2022, and 4 of those processors are now located in Dutch Harbor, Unalaska. On average, the bee season pollock fishery contributed just over 43% of these processors' total revenues, which have been grouped for confidentiality and shown by community. All bee season processing facilities are multi-species plants that have historically taken deliveries of BSAI crab, halibut, as well as other groundfish fisheries and salmon. And section 4.1.4.1 of the SIA provides information on the annual processing round for these facilities, including information on various levels of employment and how that can fluctuate for the facilities depending upon the fishery.
We have a question for you, Ms. Kimball.
Thank you. Thank you. I'm just still having trouble going back and forth between sections. Is this kind of the overall description of, are we in the background information part, not the impact part right now? Okay. My second question is there an opportunity to at least talk more in depth with some of the processing plants or the community leadership for these folks to talk about not just the contribution of pollock in terms of total first wholesale revenue or tax revenue to the communities, but it's like what is needed in that community to support the plant even being open? Because it's a lot different type of impact when you have some sort of trigger for closing a plant than just fewer revenues going to a plant. And when you close a plant, then it's not open for every other fishery that's dependent on it. Fixed gear fisheries, halibut, sablefish, everything else that's landed in these communities. So I hope I'm asking the question in the right section.
Thanks, Ms. Kimball, for the question. I'll see if Sarah wants to add on, but we've definitely received that feedback, both in public comment and then throughout the process, just getting feedback from the SSC and the AP as well. And I think the short answer to your question is yes, we can try to provide some additional information, but what we've done is we can't quantify for you the potential foregone revenue that could be affiliated with communities or the avoidance costs that might be affiliated with communities. So we try to provide a picture of dependence in various forms under the status quo. And then we talk through some of those issues that you're raising in terms of what high volume fisheries like pollock mean to a plant and various dependents more under the action alternatives rather than just the status quo. So some of that nuance will come out later in the presentation. But also, yes, we've received that feedback elsewhere.
The only follow-up is on the, even in the action alternative portion, I wasn't seeing the extension to kind of other fisheries, other folks that are dependent on the plant. So that's a part I think that no matter where it goes, as an impact is very real and should be included. Is that something we can pursue?
Madam Chair, Ms. Kimball, yes, we are going to talk about, it could have been pulled out a little bit more, I think, in the analysis, but we are going to talk about that in the impact section for processors and communities. Kate does have pretty extensive descriptions of the processors from the community profiles, which includes describing the different species that they process at their plants and some description of the seasonality associated with that. We have gotten some of that feedback of having a more robust discussion in the analysis, and I think we can do that. One of the things that was difficult with this timeframe was additional outreach and engagement with industry and processors. And we have limitations around confidentiality with the landings and revenue information that we can show. We don't have access to cost information. So us using what we have at this iteration of the analysis to try to understand where there might be a tipping point for a processor is pretty difficult without additional time for outreach and engagement. I mean, I think we've already gotten quite a bit of that at this meeting that I've heard in testimony. I heard a representative from Trident saying that they're 95% dependent on pollock in the bee season. We can't say that with our data because it's confidential, but they can say that in public testimony. And if we have time to have more outreach with them, I think we can contextualize some of that as well.
I appreciate that try. I think otherwise it could be skewed as if those folks are unaffected, fixed gear fishermen, for instance, because they're not in the bee season pollock fishery, and they would, as we are experiencing across Alaska right now, if people are paying attention, everybody's affected when a plant closes, and so I think making that connection, and I'm not asking you to define the trigger point for individual businesses, but making that connection in terms of impacts is important. It's important to those communities. Thank you.
Thank you, Ms. Kimball and Mr. Twite.
Thanks, Madam Chair. Is another way of getting at that, using the real world experience of 2023, just as an illustration of the ripple effects of plant closures on an entirely different reason. I know the problems with the seafood supply, not supply chains, but seafood supply overall. But in essence, we saw something pretty similar in the latter part of 2023 in terms of oversupplies on a couple species caused processing to essentially come to a halt prematurely in several places. And can't we get just a quick snapshot of what other fleets were expected, were impacted by that? What happened to tax revenues into shoreside communities? Wouldn't that be another way of just using a comparable situation to provide some illustration? Maybe you can't get fully at the magnitude and things, but it gets you something we lived through.
Through the chair, Mr. Twite. So we do provide that section on Alaska seafood markets, and that provides some additional context at a very high level of some of the things we've seen in the news with plant closures and challenges. We talked through the analysis about some things that have happened in 2024 with Peter Pan closing and with that fleet. We could spend more time looking at those examples and seeing the impacts of them, and we could be directed to do that think we're going to have a few data requests coming out of this. So it's really a matter of where you'd like us to spend our time putting more effort into. But those examples are things we could certainly pull out.
Thank you. And Mr. Down?
Thank you, Madam Chair. Thank you, Sarah. Really just piggybacking a little bit on Ms. Kimball's question and Mr. Twight's clarification too. I think when would we see the 2023 numbers? Because I've had people from the Pollock industry and market people that have just given me kind of general information saying that, you know, the market's down by 40%. And so if that's not shown in what you show here, but it could very well be shown in 2023. And you don't have to be a very smart business person to know that 40% of your revenues is generally more than 100% of your profit. So, so I think that when will that 2023 numbers be out? Because that's going to tell this picture along with what we hear from the public. Thank you.
Thanks, Mr. Downs. I can take that question. So we worked with ACFIN in preparing the analysis and trying to figure out what data was available to us, and price and revenue information for the prior year is preliminarily available in April. And then that data is finalized in October. So we were not able to provide 2023 revenue or price information for this iteration of the analysis because those are being made available to ACFIN now in terms of the preliminary estimates and information for that. So we can do that in a next iteration, but wasn't possible for this.
Just a clarification, you said the next iteration there at the end, but previous to that, you'd said October. Would we won't see that till October? We'll see that earlier than that? Like if we had a paper that came out earlier than October, would we see this?
Sure. Thanks for the question. Through the chair, if you put this on your schedule before October, you would see that then.
Thank you. With the preliminary data that's coming out in April, correct? Okay. Thank you.
Okay, this slide provides information on the estimated revenues derived from the B season pollock fishery within the bounds of confidentiality. So this shows you the estimated tax revenues derived from the fisheries business tax, the fishery resource landing tax, as well as the city raw seafood tax. As shown across the status quo period, the community grouping of Accutan, King Cove, and the Aleutians East Borough derived significant public revenues from direct fishery-related taxes levied on deliveries of B season pollock. The estimated revenue that's generated from this fishery has ranged between $2.03 million in 2016 and $2.60 million in 2019. Unalaska Dutch Harbor also has received or derived significant public revenues from fishery-related taxes levied on B season pollock, ranging between $5.70 million in 2012 and $4.46 million in 2017. Unalaska is unique in its scale. This city derives public revenues from the fishery resource landing tax, as well as the fishery business tax and the local raw seafood tax. It's a primary location for CP and mothership product transfers, as well as those inshore processing plants. And this slide tries to summarize some of the potential effects of alternative one on community engagement and dependence on the B season pollock fishery, trying to take into consideration the context of the preceding slides. So under the status quo period, Seattle, Kodiak, Newport, Accutan, King Cove, and Unalaska have been identified as communities that are substantially engaged and dependent on the B season pollock fishery. Additionally, all CDQ communities have received a wide variety of social and economic development programs, as well as other residents within these regions. And those programs have been funded in part by the Bering Sea pollock fishery and the B season allocation. But ultimately, the exact effect of the status quo salmon bycatch regulations on community participation and engagement on the B season pollock fishery is uncertain. And what we mean by that is that it's not possible for us to disentangle the extent to which community participation or dependence on this fishery is affected by the current measures, such as the rolling hotspot system for chum salmon avoidance. However, the analysis also describes how these communities are undergoing their own forms of transitions. So we describe how the conditions under status quo are changing, and even under selection of alternative one, the footprint of community engagement in the Beeses and pollock fishery could change. Some of the specific examples that we talked through in the SIA include the fact that, as Sarah has mentioned previously, the Peter Pan Fleet Cooperative didn't file for an AFA cooperative contract in the 2024 fishery, and Trident has announced plans to transition its Akutan facility to Captain's Bay in Alaska, although the timing of that is uncertain. And so the point of this being that the information is relevant to understanding the conditions under the status quo regulations, although the dynamics themselves are outside of the potential impacts that could result from the proposed action alternatives.
Madam Chair, now we're moving on to the analysis of impacts of alternatives 2 and 3, starting with chum salmon and impacts to chum salmon. This is going to be kind of a high level, trying to point you to where this information, again, our analysis of impacts was limited to a retrospective look at when closure dates, assuming no change in behavior, would have taken place by sector and apportionment over the range of cap levels. And so I would just point you to a couple of tables, but they're the tables for all of the alternatives. We tried to pull forward an example by year, as well as examples over all of the apportionments. We've tried to pull summary cumulative tables, but the point is that, first of all, again, with the caveat that we know that we would assume that there would be a change in behavior, but these numbers do not reflect there being a change in behavior. They just reflect retrospectively when the fishery would have closed and what amount of chum would not have been caught following that closure, as well as for the other PSC species and pollock. But all of the tables for all of the alternatives for all of the years, as well as all of the cumulative tables, are in your document, as well as in the appendices. So if you see a summary table, but you want to know more about what the interannual effects are there, we have all those tables in the appendix. Having just a moment here. Okay, thank you for your patience. I'm going to walk through the sub option to alternative 2 in terms of the PSC limit index to indices of Western Alaska chum abundance. I would note that we'll go through the years in which these thresholds by different river systems and options were reached. And I'll use this one summary table to show you those years for each of the different sub options. But I would note that a decision point, as you heard for Dr. Hapla going through this alternative, a decision point for the council is to select the step down provisions that would apply when the indices meet their thresholds. For purposes of this analysis, we assumed that the position of a PSC cap under sub-option 2 of alternative 2 would be the same as the imposition of that PSC cap. It just is in the number of years in which it is imposed. And so we use for illustrative purposes, 450,000 as the PSC cap, and then a step down provision to 200,000 under the 3 area index. So starting with sub-option 2A, then the 3 area index, and the years in which those would have been reached. So in 2020 and 2021, all 3 were below their threshold, and that's why you see those highlighted. In 2022, the Yukon River summer and fall and the Bethel Kuskokwim threshold were reached. The sub option B then is looking at just Yukon summer chum, and here it's just a lever whether or not it's below the threshold. If it's below the threshold, there's a PSC limit in place. Again, the council decision point is what PSC limit that would be. So this just shows you that in 2020, 2021, and 2022, that river was below the threshold that was selected by the council. Sub-option 2-3 then looks at both Yukon summer and fall. Again, they have separate thresholds for each, but in those same years, 2020 through 2022, those thresholds, the ones specified for the Yukon River fall chum and the ones specified for the Yukon River summer chum, were both below that threshold. So in summary then, and again, we do not treat this any differently. Looking at the implication of those, you would have to go to the tables of the caps applied in those years. Under these sub-options then, under sub-option 1, which includes all 3 areas and their specific thresholds, there would have been no PSC limit in place from 2011 through 2019. And then in 2020 through 2021, 2 of the 3 areas below the thresholds, there would have been a limit at a higher level. And then, at a lower level. And then in 2022, then 1 of the areas was below. So you would have had a PSC limit. Again, a decision point for the council. Similarly, for both sub-option 2A, the Yukon summer, and then 2B, looking at Yukon summer and Yukon fall independently, there would be no PSC limit in place. Those indices were all above their thresholds from 2011 through 2019. And then both of those indices then similarly were below their thresholds in 2020 and 2022. So there would have been a PSC limit in place in those times. We treated the Western Alaska chum salmon threshold under alternative 3 in a similar manner, in which we assume we provide this table, and there's tables for each of the different apportionments. This just gives you the sub-option 1 apportionment. And as Dr. Hapola described when she was describing this alternative, it is specified as a range. And what we did was assume that if you remember when you were creating this alternative in October, you were looking at the point estimate of a percentage accrued to Western Alaska, and then you tried to take in the variability like we just talked about. And so that's specified as a range. So for purposes of this, we assumed that exceeding the Western Alaska threshold meant that you exceeded the upper end of that range. So what we try to show you in these tables, if it's in yellow, it's within the range. If the year is specified in orange, it is above the range. If the year is here in these tables is white, it is below the range. And if it is in gray, again, we're in that area where the data is insufficient to calculate the Western Alaska component to an individual sector. I would note that as indicated in this alternative, if that Western Alaska threshold is exceeded for the 3rd time in any 7-year period, a lower PSC limit would be in place. So for option 1, the PSC limit is 450,000. If that threshold is exceeded, it drops down to 200,000. And for option 2, that PSC limit is 550,000, dropping down to 300,000 if the Western Alaska threshold is exceeded a 3rd time in 7 years. However, we do know, and Dr. Hapola indicated this in discussing this alternative, that we would need the council to provide some guidance on what it would take to get out of that lower cap limit once you've triggered it, we're looking for additional input on what would constitute the 3-year period for a sector to be able to operate under the higher cap after they have exceeded it within that 7-year period. Is it 3 consecutive years? Is it 3 out of a certain number of years moving forward? So we just note that in the discussion.
Dr. Stram, a question. Ms. Gimbel?
Thank you, Dr. Stram. And I apologize if this again isn't the right spot. I can't really figure that out. But how would someone know, or a sector know, if they've met the threshold?
Thank you. Through the chair, Ms. Kimball, this is what Dr. Hapola was alluding to earlier when she had a slide on the implementation of this in the lag period. And so I will turn it over to her to walk through what these are. Again, we have a number of issues with both the application of this alternative, the fact that the sector does not know if they've exceeded it in that year. And there's in fact a significant lag period between when the sector would know that they'd exceeded it and when any action as a result of it could take place. But Dr. Hapola walked through this when she was describing the alternative, and those would all need to be resolved in our understanding for this to be a viable alternative.
Yeah, thank you, Dr. Stram, for that. So right now, the issue remains with alternative 3 that there's no in-season genetic information available. So in order to accommodate the ground fish harvest specifications process, It's our understanding that NIMS would work to implement this alternative if the council wished to move forward with it, where the bee season fishery would be prosecuted in the summer months. The following year, in April, the genetic information would be made available and sectors would know their performance against the threshold in October during the groundfish harvest specifications process. So it's effectively delayed by over a year.
Chum salmon compared to our ability to do that kind of forecasting for Chinook is that when we're talking about chum salmon, they're spread out across the entire Eastern Bering Sea shelf by the time those surveys occur. And so we need to assess chum salmon both in the Northern Bering Sea and in the Southern Bering Sea. And as you know, while we have annual estimates in the Northern Bering Sea, the survey in the Southern Bering Sea is now every other year. And it's also further offshore than where it was when it was initially conceived as a more salmon-centric survey. So those are things that we're wrestling with right now. And we think there's a lot of potential there because we've been able to do that. We've been able to have leading indicators for Chinook as well as for sockeye salmon and pink salmon. Chum salmon's a little bit harder, and it's going to continue to be harder because in addition to just juvenile abundance information, what we've seen in the recent marine heat wave is that the condition of the fish at that juvenile life stage is incredibly important to their survival. And so there's going to need to be additional covariates in that model. It's just work that we have to do, and we're not quite there yet in having a product that the council can use at this point in time.
Thank you, Dr. Howard.
Okay, with that, we would just move on quickly through how the tables that we show for trying to show, so we have a number of tables. Again, this is showing you on a cumulative level across one cap and all four apportionment options. The pollock foregone, the overall chum salmon avoided, and the percent reduction annually, as well as just in B season. We tried to pull a cap and an apportionment forward by year as well. There is a table 6-46 that's in your addendum. It's corrected in your addendum that tries to take the same single cap scenario and then look at it by sector by year. And to that table, it doesn't show up well on a slide, so I didn't put it in here, but I would direct you to the addendum for that. To that table, none of these tables show just the Western Alaska component of these by these alternatives and sector apportionments. We have some summary tables that look at when we did look at that individually. But table 646 in your addendum does look at it from the Western Alaska component. But I would note that when we break these down by year and sector and pollock foregone and chum avoided, chinook avoided, herring avoided, most of those tables do not also carry forward the Western Alaska component of it for comparison. We just tried to do it for a couple select examples to just show the implications of that. But again, that's in your addendum. And that's some of the information that's put forward for this, for looking at what the effects of these alternatives are, again, with the caveats of assuming no fleet behavior changes, which we already know is not really, it's all the case. Taking table 646 then and looking at what the difference between the Western Alaska chum salmon saved and by sector as compared to status quo. And that's what the estimate that you get here in this table in your document on 647 on page 224 in your document. And again, that's from that one example and trying to summarize it over the year. And we can do that depending on how we reanalyze these alternatives. We can do that for more or for different summary reasons to try to show what the effect of a closure is. Again, assuming no change in behavior. I have a couple slides then that just, well, this slide that just gives you kind of the summary of impacts. This is on pages 224 to 225 of your EIS in section 6.2.4.2 to try to caveat that the overall impacts that we would assume under this, regardless of the fact that we know it's a retrospective and we don't have a good way of estimating that, but a reduction in the number of chum salmon caught as bycatch in the pollock fishery may have a positive and indirect impact on the overall health of the resource, as more adult chum salmon may return to their natal streams. This proposed action is focused on reducing Western Alaska chum salmon bycatch in particular, and increased adult chum salmon returns could increase abundance, which may improve run strength over time. That's just a general caveat to where the benefits could be. But the analysts are unable to quantify the relative magnitudes of these potential indirect and positive benefits because we're unable to determine the absolute impact of chum salmon bycatch occurring in the pollock fishery on chum salmon returns or the overall run size. We're unable to break out the Western Alaska Genetic Stock Reporting Group, that's the coastal West Alaska and the upper middle Yukon, into smaller river systems or areas because of the current understanding of the genetic structure of Western Alaska chum salmon. And there's an uncertainty in the level of bycatch reduction that would need to be achieved to result in escapement goals being met or improvements in chum salmon harvest opportunities. And we try to caveat this throughout the document. We don't know what that level of bycatch reduction would be that would translate into something measurable in the rivers themselves. This is the table that I was referring to earlier, where this is not in your document, but here we tried to provide some scale of the relative impacts of as compared to the scale of overall removals from other sources of known Western Alaska stock composition removals. So this is looking at, for that one alternative that, again, table 646 in your document looks at the alternative to 200,000 chum PSC cap with the 3-year apportionment and looking at the total. So rather than showing this as it is in the tables as total saved, this is the total amount of Western Alaska chum that would have been taken under that alternative. So basically status quo minus the amount that was saved by imposition of those closures, and comparing it to the Area M Commercial Fisheries June West CWAC contribution, which again assumes a flat 18% contribution from the overall June harvest over all of those years. We didn't make any attempt to interpolate between the previous results of 57% and the current result of 18%. It then also compares it against commercial fisheries harvest combined and the subsistence fisheries harvest combined. And those are the sum of the catches for the commercial and for the subsistence in each column across Bristol Bay, Kotzebue, Yukon Summer Chum, Yukon Fall Chum, Kuskokwim, and Norton Sound Port Clarence. We did not have subsistence harvest information that we could use for 2022. That's why that shows up as NA. And the overall, just to point out that the overall decline you see in the commercial fisheries harvest in 2020 through 2022, summing across all those areas, generally is reflective of the decline in chum harvest in Bristol Bay area, where they switched to higher sockeye harvest. And so that chum contribution declined. And this just shows you the same.
Sorry to interrupt. Mr. Dwight has a question.
Thanks, Madam Chair. Dr. Stram, I couldn't find anything else in the analysis that gave me any additional information on harvest impacts. So I just want to make sure that for me, at least, when I look at this table encapsulates all known harvest impacts on Western Alaska stocks over this range of years, right? So the percentage is, so for instance, the percentage that the alternative to 200K option 1, if that had been in effect, that percentage, I can calculate that percentage of the known harvest impacts just by using this table. That's correct?
Madam Chair, Mr. Twite, there are some sport harvests that aren't reflected here. I'm not sure. That's fairly minor, but that we were trying to get at kind of the major overall sources of mortality: commercial harvest, subsistence harvest, commercial harvest in area M, and as compared to bycatch. So yes.
Okay, thank you.
And Ms. Kimball.
Thank you. Thank you, Dr. Stram. Is this, I mean, I like that you're pointing out when the tables aren't in the DEIS. So you're responding as you hear things, I assume, but your previous slide was where analysts are unable to quantify the relative magnitude of these potential indirect or positive benefits. And that's what you're attempting to do here, is try to provide some assessment of magnitude. Is that correct? And if that's the case, are there other things we could put in there relative to some systems where we know escapement very well that could also provide some, I'm not trying to edge us into an AEQ, but providing the context around it so we can understand that scale that we're missing right now.
Madam Chair, Ms. Kimball, yes, that's exactly what this is attempting to do, is provide some relative magnitude and scale. I think, again, when we talked about the timing of this synthesis aspect of this document that may not be possible in time for the publishing of the document earlier in March, these are some of the things that we weren't able to regroup, to synthesize in terms of overall impact. So I think that that's what we would continue. There are other things we could compare it against. I looked at it in comparison to run reconstruction data. Without having some sort of internal review of the appropriateness of comparing apples and oranges that way, we just thought that perhaps comparing total overall removals. So that's not including, that's not looking at run reconstruction, escapement goals being met, anything like that. It's just looking at overall removals for scale.
And Mr. Sakata.
Yes, thank you, through the chair. A couple slides back, I think it's slide 125, you show estimated total Western Alaska chum saved by sector. And years 2011 through 2015 shows 0 for CDQs. I couldn't help but notice it was very similar to the estimating Western Alaska chum salmon bycatch by sector, where those, instead of 0, there were NAs. And so I was just wondering if you could clarify if there's a difference. Is it really 0? Should it be NA?
Mr. Chairman, Mrs. Sakata, yes, that's a really good point. And I believe if we were to go back and look back at this, some of those zeros should actually be NAs because those are years in which the Western Alaska component. So some of them are zero. But if we go back and compare it with the previous table where you are unable to calculate the Western Alaska component. So in particular, I believe there's 2 years for the mothership. There's a series of years for the CDQ. Certainly, 2020 also falls into that category. So it should really be considered as more of an NA for certain years. In some years, the sector was closed after they'd already caught their proportion of chum, and so that there was no difference from status quo.
All right, thank you.
And Mr. Down?
Thank you, Madam Chair. Thank you, Dr. Stram. I'll start by asking you the question, but maybe Sarah or Dr. Hapala can help as well. So it's a question I've asked many times, and really the basis of this is when we're looking at these estimates of foregone hindcasts like that, what would the foregone revenues had this option 2 been in place of 200,000? The question is, the tone of the question is, the freezer longliners have cut their bycatch, for instance, by 80% halibut bycatch since the 1990s. And it's been really remarkable because of careful release and discard mortality rates and working hard on that by the crew. But really, there's some portion of that, quite a large portion of that, which is just the fact that they're not seeing a lot of halibut. And the halibut that they do see are not near as big as they used to be. So when we're looking at something like this, it seems to me that it's somewhat meaningless I have a hard time getting a takeaway without including those kind of factors. And I've asked this question a lot of times on bycatch issues, and somehow I've never got a satisfactory answer of why it is that we can't find some way to get, because these are pretty far-fetched estimates in themselves. I don't see why we can't take the next step and say, well, there was a lot less chum in a river reconstruction run. And so we've got to take that into factor, that the big part of that wouldn't have actually been lost in those earlier years. Or maybe it would be. Maybe it would be actual loss, then we have more confidence in it. So that's a long-winded setup and that is a short question.
Through the chair, Mr. Down, I think that's a good question. It's sort of a question for all of us, so sort of throughout the course of this analysis, because we all point to those retrospective tables at some point, that Appendix 6. And they're really, you'll hear all of us say and keep saying, we expect behavior to change, and we expect this whole current of external factors to also affect what is happening and what we're seeing when we talk prospectively about what could happen in the future. And I think that's why there is so much under status quo in this paper, is because we're trying to contextualize some of that for you about how abundance has varied over time to the extent that we know these things, and how environmental conditions vary because those things will likely keep changing. I think they're difficult for us to put our arms around, and especially when we get in my section coming up about those potentially foregone revenue numbers that you see, they're there for reference, and then look away because we think a lot of things will change after that. And that might not be a good basis to think about potentially foregone revenue. But it's the numbers that we have is what retrospectively happened. And I think, we try to highlight over and over that there's both an undercurrent of external factors that are changing, but also even within the marginal analysis that we're trying to focus in on, there's certain behavioral responses that could be a direct implication of the marginal change that we're looking at. So all of those things kept together, I think, sort of point to your point right there. It's difficult to quantify all of that, but we try to contextualize it throughout the document.
Thank you. And just one very quick comment, if you would, Madam Chair. I realize people are probably tiring that I've asked several questions here now, and I wasn't in the room for a large part of this, but I just want to assure you, Madam Chair, and everybody that I have tracked this and I've been listening. And I've not missed much, if any, of the presentations today. So I appreciate your leeway. Thank you.
Thank you, Mr. Down. Thank you, Ms. Marion. Ms. Vanderhoven and then Ms. Kimball.
Thank you, Madam Chair. I think this is probably for Dr. Stram. This table was known sources of mortality, basically. Do we have any information about, and I would assume it's probably not reliable, and maybe that's why it's not included, bycatch in the Western Bering Sea pollock fisheries, the Russian fisheries, and because it seems that would be another source of mortality, and maybe we just can't quantify it.
Thank you. Through the chair, Ms. Vanderhoven, and I guess I would characterize this also as known removals. There's obviously other sources of mortality, like natural mortality. We've never had very good information, unfortunately, for that, not on either stock composition or overall amounts. We can certainly try to dig into that moving forward, but I would caution that I know that in the past we have never been able to get a very good sense of the bycatch in the pollock fishery in Russia.
Okay.
So this slide just walks through some of the considerations of potential impacts to communities and regions that are engaged and dependent on chum salmon for subsistence. For the reasons that have been identified by Dr. Stram, the magnitude of the potential positive and indirect benefits for communities that are engaged and dependent on subsistence harvest of chum salmon resulting from the proposed action alternatives are uncertain. Ultimately, the extent to which the positive benefits would be realized would depend on whether the conditions improve to a degree where in-season managers would improve to where in-season managers can provide different opportunities for subsistence users. So as context, as a run develops, ADF&G will develop a forecast and work to predict what kinds of opportunities or what level may be made available, and then makes updates and adjustments to those opportunities as needed. And these decisions can be highly contextualized, taking into account run estimates, prior years' escapements, as well as local knowledge from fishermen along the rivers. The extent to which the proposed action alternatives result in levels of avoidance or savings where Western Alaska chum salmon improves, there could be less restricted or unrestricted subsistence opportunities. And that may have some potential positive and indirect social benefits for communities and subsistence users. And in light of that uncertainty, we took a qualitative approach to reiterate and point back to some of the considerations of social impacts in section 4.3.5 of the SIA. So should conditions of abundance improve to a degree where less restricted or unrestricted subsistence opportunities could be provided, it's possible that there could be positive impacts on the mixed economies of rural and Alaska Native communities, sharing networks, food security, as well as cultural practice, well-being, and the formation of identity that's central to people's overall well-being and community and sense of place.
Ms. Kimball.
Thank you. Dr. Habla, on that point, similar to some other points, are there things that you've thought of maybe over the course of this meeting, maybe after we see the SSC report, that could better get at the first part of that sentence, to the extent that any of the action alternatives result in savings to a level where in-season managers are able to provide less restricted subsistence opportunities, given some of the more concise contextual information and talking potentially to Fish and Game, is there an opportunity to provide us something on the first half of that sentence so we can then decide if the second half is even relevant?
Thanks, Ms. Kimball, for the question. Through the chair, I think that's going to prove to be a very difficult question to answer. As I understand it, we can certainly work with Fish and Game to try to provide some more context for you, but I don't believe there are prescriptive numbers that have to be achieved across the different areas. There are some that are specified in the management plan for the Yukon, so we could maybe look to that for you. But as I understand it, the decisions that are made in terms of subsistence opportunities are just usually highly contextualized. They take into account prior year's information. So we could work to describe that for you, but I don't think it's going to be satisfactory in a way where we could provide you a numerical target that has to be achieved. So in that sense, I'm not sure we're going to get there.
Thank you. And I don't want to support just a description of the fish and game process. I think we know that, and there's a lot of description already in the document. It's just whether there's an opportunity to say, if we can get closer to something like number of salmon returned from 10 to 50,000 Western Alaska chum avoided, would that make a difference in decision-making for managers, even on some major systems? That doesn't seem like a hard question to ask. If it's asked and not able to be answered, I understand, but it might be worth asking.
Thanks, Ms. Kimball, for the question. Understood.
Madam Chair, so under the alternatives, looking at the potential impacts to communities and regions engaged in commercial chum salmon fishing under the action alternatives. This is pretty similar to the conclusions from Kate's slide. So although marginal impacts to Western Alaska salmon returns are not able to be quantified for the reasons we've talked about, to the extent that any of the action alternatives result in savings of Western Alaska chum to river systems of origin, this could have indirect benefits on commercial fishing opportunities in the management area. For the reasons previously discussed, the interconnectedness with subsistence, the limited economic opportunities, the highly localized fisheries, the importance of seasonal flexibility. For example, even a few hundred fish made available to the commercial harvesters could provide a family or multiple families with income needed to support subsistence or cost of living expenditures.
pollock. So we looked at over the range of years overall and cumulative. And then I would say that in looking to the impacts to pollock under these alternatives, 2 and 3, this is the only place where we tried to look kind of more on a thought exercise overall. So understanding that at current levels of pollock abundance, it's well above target levels of BMSY. So it's well above its target biomass. And given our 2 million metric ton cap, the TAC is set well below the ABC. So what we tried to look at is if it's already set well below the ABC under current levels of pollock biomass, it obviously gets closer to the ABC as pollock biomass declines, and you set your TAC level close to the ABC. By default assumption, we assumed that that the pollock stock, that you would continue to set your TAC at certain levels. And so all of our foregone pollock assumes the retrospective TAC level and where the pollock was foregone. So for trying to conceive of the impacts to pollock under the alternatives in which there's 12 to 15% on average additional pollock in the water, we tried to look at what that might entail if over time. So this is not a snapshot. In the immediate sense, you would have more pollock adults in the water because they would not be caught. So it's the idea of under harvesting the pollock stock, but looking at the idea, if you were rather than looking backwards, we tried to think if you continuously under harvested the pollock stock under these alternatives or under the most restrictive by somewhere of 12 to 15%, in addition to what it is below the ABC, what could the potential impacts be? So I would just characterize that this is a little bit more of a hypothetical thought exercise in terms of more adults in the water. What would happen if you continuously had more adults in the water? Then your average size at age over time might decrease due to prey limitation and possible density dependence in terms of the impact on pollock prey. There might be fewer prey items when you have more adults in the water. It could have a greater impact on the competitors. And then in terms of predators of pollock, there would be potentially more pollock as prey for seabirds, larger fish, marine mammals, and fur seals. But additionally, the more pollock that you have in the water, you could also you could over time increase the relative cannibalism that occurs within the pollock stock, and that could potentially over time lead to lower recruitment. So that's how we tried to think about this in the sense of what under harvesting of pollock year after year after year would do. So it's not meant to be retrospective the way the other impacts are characterized.
So Madam Chair, now we're moving into the analysis of potentially foregone revenue for the Bering Sea pollock sector. This analysis applies to, it considers an overall chum PSC limit. So it applies to both alternative 2 and 3. And then I will have some specific considerations for alternative 3 broken out at the end. But this first part of the presentation covers both. So the approach here in section 291 is this is obviously focused on a cost component of the potential action or reduced benefits. We don't have a separate RIR for this analysis. This is sort of integrated. So the costs and benefits are really integrated within the associated resource categories. The approach for this section is it's meant to be a prospective discussion, but a piece of the analysis is those retrospective tables, and it starts with the retrospective tables, which are broader, and there's more information in Appendix 6. In terms of the particular gross ex-vessel revenue and first wholesale revenue associated with the pollock that wouldn't have been harvested if you dropped a PSC limit down on that historical data and closed the fishery at that point. However, as emphasized through the document and in the presentation, these numbers are meant to be a starting point and a frame of reference. We do expect fishing patterns to be altered under constraining PSC limit, and the analysis works to provide that context for operational changes and avoidance, and to characterize the associated avoidance costs. Much of the analysis is qualitative, given the lack of empirical data on costs and our ability to estimate specific marginal changes, given the suite of external factors that we were just describing that can influence pollock harvest and Western Alaska chum caught and avoided. So I'm going to emphasize the importance of the external factors within that context. This analysis is broken up into 5 main sections. So we'll start with a look at the retrospective tables, and then I'll talk about operational changes and impacts, avoidance, fishing behavior and associated costs, and then a discussion of broader implications of occasional or repeated bee season pollock closures, and then, as I mentioned, some of the specific considerations for alternative 3. So I really don't want to dwell on the retrospective analysis too much, but when we look at this, the pollock sector where it would have hypothetically hit the various chum PSC limits had it been in place between 2011 and 2022, not accounting for fishing behavior. This table is not in the document, but it uses the information from Appendix 6 to summarize it in a different way. And so this table shows the allocation and apportionment with potentially the most adverse impacts to each sector. So of course, that's 200,000 PSC limit for each. And for the CDQ and CP sectors, that would be the 3-year average apportionment would be potentially the most impactful. And for the mothership and inshore sector, that would be the AFA apportionment that could generate the greatest adverse impacts. So in this table, just for example here with CDQ, within the 12 years that were considered, if you just looked at the historical data, they would have been closed early in 5 of those years. That unharvested pollock would have represented an average of 11.4% reduction in gross revenue relative to the annual pollock revenue from that sector, which the average was $47 million. But there's wide variation within that annual number. In some years, they wouldn't have closed down, but it ranges up to 46% of total gross first wholesale revenue. And so you can also see the upper bounds You can see these upper bound values for the other sectors within this table. As I mentioned, this is for a frame of reference, but it can really go only so far in terms of understanding future effects, and it needs to be contextualized with additional expectations of future fishing behavior should PSC limits be put in place. Avoidance techniques could delay or prevent a closure, resulting in chum PSC limits and reduced foregone revenue, but they also have associated costs. Also, an evaluation of gross revenue does not account for the multitude of costs of production, so it doesn't quantify the net effect of the action. And future variations in ocean conditions and distribution of pollock and chum and chinook and other constraining species can render recent history a less representative picture. So conditions could be more or less favorable to pollock fishing and the resulting bycatch. So thinking about how fleet dynamics could be different under a chum PSC limit, we use an example here because the AFA fleet is already operating under the Chinook PSC limit. We consider how this additional salmon PSC limit may be different from or similar to the operational response to that PSC limit. Firstly, one way that the operational response could be different is based on how chum is encountered on the fishing grounds relative to Chinook. It's my understanding that Chinook tend to be more intermittently encountered, whereas chum can appear in large pulses and be more intermixed with pollock. So this presents a different picture of risk. There can be increased risk associated with a sudden high chum catch rate. And because of this, it might require more conservative or different proactive measures if the risk is perceived too great. Currently, with the Chinook bycatch limits, there's a different PSC limit based on abundance. We're currently at the lower level of 45,000 fish. But then there's a lower threshold limit, which if exceeded by the sector in 3 of 7 years, means that the sector operates under that lower PSC limit permanently. So although 45,000 fish are apportioned by sector and CDQ group and cooperative by NIMS, the IPAs then further dictate how that PSC limit is apportioned down to the vessel level. And none of the IPAs actually apportion their percentage of that 45,000 fish. They all apportion either a percent of the threshold amount, or they add a buffer in and apportion a further reduction of that buffer amount down to the vessel level. And that degree of apportioning provides vessel level accountability and incentives and ensures that the sector and the cooperative doesn't suddenly exceed its PSC limit. This appears to be an effective strategy as all the sectors have remained under their Chinook hard caps in all years and the thresholds in all but 1 year. Some vessels have hit their individual caps, but as you can see in table 2.4 in the analysis, the sector nearly always harvests 98 to 99% of the pollock tack. There were 2 exceptions within that time series in 2011 and 2020, but always within 90%, higher than 94%. So in a similar way, a chum PSC limit could be apportioned down to a vessel level through the IPAs to decrease the likelihood that the cooperative would not suddenly reach the limit. Since the vessel level cap wouldn't be in place at a regulatory level, they would need to do this with a legally binding civil contract. Otherwise, there could be a moral hazard situation where there ended up being a race for fish. That wouldn't be desirable at the cooperative level, so we do expect that they would put in place some considerations for vessel level apportionments like they do for Chinook. It's difficult to say if this would be as effective. They would be as effective at operating under a chum PSC limit while continuing to harvest the tack. Of course, this depends on the limit that's chosen. It also depends on how that limit is perceived. And in the document, we consider this sort of on a spectrum by using the terms of constraining versus very constraining or less constraining in an attempt to reference that this isn't necessarily a static number. The PSC limit would be a static number, but the way that it's perceived as a risk could vary based on changing behavior and other factors on the fishing grounds. And a very constraining chum PSC limit may be functionally different from the current Chinook PSC limit, which to date appears to provide an operational flexibility that once it's apportioned down to the vessel level, a vessel level is still able to plan avoidance and still harvest their pollock. If a cap is chosen that's constraining enough that a vessel operator is likely to hit their individual limit during the bee season, or the risk is perceived too high, the cooperative operational strategy may be different for chum than it has been for Chinook. So that could look like more proactive measures that we haven't seen for Chinook. It might look like operator choosing not to fish, to tie up a vessel, potentially consolidation, maybe more test tows and stand downs, or it could be similar to the strategies that we've seen for Chinook avoidance and chum avoidance in the past, looking at more of the kinds of reactive measures, communication and vessel movements when rates are high. Alternatively, if a chum PSC limit is chosen that's not constraining, and again, this term is relative to the circumstances and a perception of risk, it may not motivate additional avoidance on its own. However, additional measures in the IPA may. In part because patterns of chum encounters under a chum PSC limit, there may be more of an emphasis on the transferability nature of PSC relative to practices around Chinook. The current alternatives specify that under any PSC limit, the PSC would be fully transferable. However, there are practical and operational reasons why this quota might not be transferred smoothly and efficiently to parts of the fleet that have a demand for it. But a constraining PSC limit may result in instances of stranded pollock between cooperatives, particularly in the CV sector, which has more cooperatives. Finally, one way in which the chum PSC limit would be different from a Chinook PSC limit is that this is additive to a Chinook limit. So these operational decisions are being made jointly. It could be that a vessel now has 2 PSC limits apportioned, and this adds to a complex web of factors that add to fishing behavior and decisions. And Diana is going to speak more to this later in the presentation. The next section of the potentially foregone revenue analysis walks through the potential avoidance costs. Under a chum PSC limit, the cooperative managers in C state would be expected to be monitoring their vessels and chum rates and moving effort if necessary. However, in doing so, there's likely costs that would occur, both for the vessels and companies and crew, and sometimes in case of the shoreside processors. And these costs can incur regardless of whether the overall PSC limit is met. So this table categorizes some of the costs for you. It's notoriously difficult to tease out the precise values associated with avoidance among the other costs. Also, we don't have access to a lot of cost data here. And the analysis is really trying to understand or highlight the marginal differences in increased costs due to increased avoidance. One of these categories, the first category listed in the table, is increased travel costs. Because one of the primary tools here is the rolling hotspot used to direct vessels to pick up and move effort. One of the fuel is one of the top operating expenses for the fleets. And we do have fuel cost data from the Amendment 91 economic data collections. And so Alaska Fisheries Science Center has updated those numbers for me, and they're in the paper. I just want to make one additional note here that with increased avoidance under a PSC limit, there could be differential impacts for the shoreside sector relative to the offshore sector. The fleets have different constraints and different abilities to move. There's an industry standard for the shoreside pollock sector of 48 hours between pollock catch and delivery. So that means a chum PSC limit, depending on the cap and external conditions, could result in different level of impact for the shoreside sector. The second point highlighted here under operational costs is the potentially decreased operational efficiency. If vessels are picking up and moving more often, taking stand downs during test tows, this can come at a cost. This is a topic that comes up a lot in the skipper surveys, which is another part of the Amendment 91 EDR, a redistribution of effort to increase chum avoidance could move vessels into areas with lower pollock CPUE or lower quality or size of product, and for the inshore sectors, areas further from port. Depending on external factors, reduction in harvesting efficiency could extend the season relative to the status quo, and that adds variable costs. And it could have implications for Chinook interactions as well. These kinds of costs also can have implications for crew, and the paper describes a few ways there how it can affect, especially crew that are paid on a share-based wage could be affected by more inefficient operations and lower quality product and additional time at sea. Most of the avoidance costs would be incurred by vessel owners, skippers, and crew, but processors and associated communities could be impacted by avoidance behaviors as well. The paper highlights some of the primary products, filet and surimi mostly, but in bee season, there's also fish meal, minced fish, and fish oil that's produced. And I understand that there's considerable price variation among different grades of fillets and surimi quality. So if boats are being moved to areas with smaller fish or worse quality product, that can affect prices, and it can affect processors and communities in that way as well. And just the other 2 points in this table is associated with avoidance costs is additional avoidance can make it riskier to move to explore in new fishing areas. There's risk with moving to unknown chum salmon areas with unknown chum salmon rates. And if you have a specific allotment of PSC for your vessel, you might be less willing to take that risk. And then decreased flexibility in time or space for pollock fishing could possibly contribute to gear conflicts or safety concerns. Okay, I have a few slides here to cover some of the broader implications of a bee season closure. In addition to the direct impacts of possible foregone revenue, this section highlights economic impacts that could be broader with closures of pollock bee seasons prior to the full harvest of the tack. And of course, the degree of impacts in a bee season closure would greatly depend on the point in the bee season where the closure occurred and how much pollock was left unharvested. And as I mentioned, that we could have a situation with pockets of stranded pollock being pockets of stranded pollock. If one cooperative, for example, hit their PSC limit, that could be another way that some of the bee season closures could have more widespread effects. Not all of the AFA vessels and companies are equally reliant on bee season pollock, so the impact may be more pronounced for some companies than others. And the paper discusses diversification and potential spillover impacts on other fisheries. CDQ groups could be adversely affected by a pollock bee season closure. As we talked about in some of the discussion of the status quo, these groups rely on revenue both from their CDQ allocation as well as additional investments in AFA vessels. Like other AFA companies, CDQ groups still have obligations for certain costs, so decreased pollock revenue could affect their ability to support community programs in the way that they have under status quo. A closure would have adverse impacts for AFA crew through reduced employment and income. If closures become common in the bee season, the variability and uncertainty of employment may lead to challenges with crew retention as well. And these kinds of implications are going to be further discussed as associated with communities as well.
So we just have a quick slide here that captures the way that we conceptualize potential impacts for CDQ communities. As noted previously in the presentation, all CDQ communities are considered as indirect participants in the Bering Sea pollock fishery with varying degrees of dependence, bearing in mind that the CDQ group's allocation of Bering Sea pollock accounted for approximately 59% of total revenues, which does not take into consideration the royalties that are earned from other fishery-related investments. And we don't have any way of quantifying or providing a good amount of information for you on the proportion of revenues that are used to fund programs for communities derived from allocations of bee season pollock or other AFA investments compared to other income and revenue sources. But the CDQ groups and their constituent communities could be impacted by potential changes to regulations under the proposed action alternatives. And two more direct ways, one of which is that all CDQ groups receive that programmatic allocation of Bering Sea pollock and would receive an apportionment of the overall chum salmon PSC limit. And the second is, as we've discussed, many have made additional investments into the AFA sectors. To the extent that the proposed action alternatives could reduce revenue payments or increase avoidance costs to a degree where CDQ groups would be adversely affected and unable to sustain those programs in their communities, which provide benefits for both residents and regional and non-residents alike. There could be adverse and indirect effects, but how effectively those risks could be mitigated by adaptive fishing behaviors and strategies, as Sarah's discussed on behalf of the CDQ partners, is uncertain at this time.
Yes, Mr. Mesro has a question.
Thank you, Madam Chair. Thank you, Dr. Hopla. My question for you is this: I read this analysis a while back, and then I read the comment letters after, and I noticed in a comment letter, one of the CDQ representatives referenced the relationship between the cost of royalties that get paid out and the fact that a lot of the CDQ groups don't own the vessels that are fishing their quota, and that in a reduced PSC situation, it might be in the best interest of the fishing companies to forego harvesting the CDQ quota first and catch the quota that they actually own, because it would be more profitable, which would negatively impact the CDQ groups. And what I didn't do is I didn't go back into the document and see if you covered that particular issue, but it seems like it's worthy of consideration in a future iteration if you didn't cover it, because it's a fairly significant concern that we could do something with PSC that would negatively impact CDQ, and understanding that if that relationship, you can figure that out, might be helpful for decision making.
Through the chair, Mr. Mesereau, I think that's a good point. I also heard that in testimony and saw that in the letters at this meeting. That's a nuance that may be difficult for without additional outreach and communication with CDQ partners. It's difficult for us to tease that nuance out of just looking at the data and the relationships. These are really complicated relationships with different kinds of, each one different kinds of partnerships and associated. I think what was being highlighted in that testimony too is the leverage that could change in that situation if CDQ groups are, there was a reference to the apportionment choice, and if they're being apportioned, if their apportionment aligns them with the CP sector more, and it makes it more difficult for them to make decisions about where they want to harvest their quota. And there were a number of other things highlighted there that I think are important and interesting points that can be real difficult nuances to just pull out of looking at the ownership data. So again, I think that's a piece that, like, with more time and ability to communicate with CDQ reps, could be highlighted in the paper.
And Ms. Marinan, before we move on, I know that earlier you mentioned that it was very difficult to also provide an estimate of the potential foregone revenue of the AFA investments relative to the CDQ royalties based off from that CDQ quota. Is there, through discussions this week, do you feel like there's a better way to capture that, at least visually, in the foregone pollock revenue visuals and models, to at least associate some type of ownership interest in the CV and CPs that are reflective of that CDQ portfolio, rather than just isolating the three boxes from CDQ, CV, and CP and mothership? I mean, is there a way to just at least highlight there's a certain part of ownership that could be associated with a sector, so that connection can be better drawn, even though you can't, I think, extract an exact number for that revenue?
Yes. So I think I see where you're going, Madam Chair. It's still difficult to tease out revenue associated with CDQ groups because we don't know lease rates, and that aspect makes it more complicated to track how much the returns on specific amounts of pollock. But one thing we could do with a bit more time is using that table on ownership, and we could look at in the IPAs, they report the percentage of pollock to each vessel. So we could crosswalk those tables to make some estimates of the amount of pollock associated with CDQ. So maybe not taking it to the step of revenue, but just seeing the degree to which pollock, both in CDQ allocation, but also with additional investments, might be associated. Does that get at the point you're asking?
It does. Thank you. Thanks.
Madam Chair, I have one more slide here on potential implications of bee season closures. So this slide focuses more in on processors and markets. As I highlighted in the background section, in terms of pollock products, these are mostly export markets. So depending on the extent of closures, there may be minimal impacts to U.S. consumers expected. However, if repeated bee season closures occur or erratic bee season closures occur, it could result in more widespread impacts to the viability of processing entities, and this could have cascading effects for multiple species they process and the associated U.S. consumers of those species. And as we discussed before, this could be brought out more in the analysis, but some of the processing plants in the region are affiliated through joint ownership, so the sustainability of one plant could have implications of other plants or other directed fisheries. Other processing entities, like, for example, the crab processing shareholders rely on the infrastructure of these plants for custom processing, and that could be compromised if the viability of a plant is compromised. Bee season closures could exacerbate the current market challenges on processors and associated harvesters and communities. Analysts don't have access to processor cost data, so we can't empirically predict what level of unharvested pollock might be unsustainable, but operating costs are extremely high in the Aleutian Islands and increasing, and this region has experienced processor consolidation. So those underlying factors, combined with the marginal impacts here, are important to highlight.
Yes, Ms. Kimball.
Thank you, and thanks for those statements, Ms. Marin. And so we know what we would expect to see in the future. I think we might also want to qualify some of the discussion about export markets being the primary markets for this product. I think there are definitely individual companies where even if it wasn't over 50%, it's a substantial part of their product for both surimi and fillets go to the US market. And with Russia now very newly being prohibited from harvesting fish and selling into the US market, there is just a huge national push to fill that gap with US product and Alaska product. So it's an important kind of connection to make, and it just might qualify those statements a little bit more accurately for today. Thanks for that. Not really a question.
Thank you. Before we move on, I think this might be a good time to take a mid-morning or mid-afternoon break. So let's come back at 3:30 and resume with the presentation on C2. Thanks. Council members, please come back to order. Thank you. So we are ready to continue our presentation on agenda item C2. Thank you.
Thanks, Madam Chair. The next section of the presentation walks through the potential impacts to communities that are engaged and independent on harvest and deliveries of BCs and pollock. So beginning with the community of Seattle, Seattle has a relatively high degree of exposure to the potentially adverse effects that could result from the proposed action alternatives because this community is affiliated with all at-sea harvesting and processing sectors in the fishery. Under alternative 2 and 3, if the overall PSC limit was constraining to a degree where operators could not modify their fishing behavior to avoid reaching the limit prior to the full B season TAC being harvested, this would result in some level of foregone revenues for the affected vessels. In a scenario where the overall PSC limit may be constraining to a degree where there were repeated B season closures, it's possible that there could be adverse effects resulting from consolidation as firms or vessels may exit the fishery. But as noted in the analysis, it's difficult to discern the degree to which the community of Seattle would be affected because consolidation could occur within Seattle-based firms or vessels. Absent a B season closure, we would still anticipate there to be avoidance costs. So vessels, companies, crew, and in some cases, shoreside processors would incur costs associated with avoidance regardless of whether or not the overall PSC limit was reached. And one of the nuances that we tried to tease out in the SIA is that as operators work to avoid chum salmon bycatch on the pollock grounds, they may incur longer fishing trips or an overall longer B season. And should trip lengths increase, it's possible that this would have a negative effect on crew morale and overall job satisfaction. Finally, while Seattle is a community that's substantially engaged in the harvesting and at-sea processing components of the fishery, the community itself may also be less economically dependent on the fishery when the revenues earned are compared to the scale diversity and general economic resilience of Seattle as a large metropolitan area. But that's not the same as the resiliency of the vessels or the companies that are affiliated with Seattle through their ownership address. This slide covers the potential impacts to Kodiak and Newport. The analysis grouped the discussion of these two communities because they share some similar characteristics in terms of their engagement in the fishery. It's not meant to suggest that there aren't important nuances. Under alternative 2 and 3, if the overall PSC limit was constraining to a degree where operators could not modify their fishing behavior to avoid reaching the limit prior to the full B season TAC being harvested, that would result in some level of foregone revenues for the affected vessels with these affiliated with these communities. So focusing on Kodiak, this community is affiliated with both the inshore and mothership sectors. And as mentioned previously in the presentation, during the status quo period, there were 6 vessels that participated in the B season fishery. Kodiak is Alaska's second largest commercial fishing port behind Dutch Harbor in terms of the volume of landings. And the Kodiak community fleet is large and diverse. It participates in other Bering Sea and Gulf groundfish fisheries, IFQ, salmon, and crab fisheries. On average, the B season pollock fishery contributed just under 3% of the total revenues earned by that Kodiak community fleet. However, as noted in the analysis, interpreting this information is not straightforward in the sense that Kodiak is a remote island where there may be comparatively fewer economic opportunities for potentially affected crew and skippers. And there are also AFA vessels participating in the B season pollock fishery that have permanent stalls and transit dock spaces in the boroughs, harbors, and the community likely receives some economic benefit from harbor fees, fuel sales, and as fishermen are patrons to other local businesses in town as they transit to and from the grounds. And then focusing on Newport, there were 10 unique catcher vessels that participated in the inshore sector with the registered ownership address in Newport. On average, the B season fishery accounted for just under 26% of these vessels' total revenues. Similar to Kodiak, Newport has a large commercial fleet comprised of vessels that prosecute fisheries in local waters, as well as in Alaska's groundfish fisheries. The Newport area is a regionally important town with a significant number of support sector businesses. And on average, the B-season pollock fishery has contributed 20.54% of the community fleet's total revenues, which is a relatively high proportion of that community fleet's total. At the same time, Newport is a community that's on the lower 48 and is connected to the road system, so it may have a greater level of resilience to the potential adverse effects. But one of the nuances that's also we try to tease out in the analysis is that each of these communities holds a sense of place and identity that's built around fishing. And it's not uncommon for those households that do engage in commercial fishing in these communities to have multiple generations connected to a fishery, or they're engaged in it as a meaningful and satisfying occupation, which is attributed to a sense of overall well-being. The next couple of slides discuss the potential impacts to communities engaged in and dependent on the B-season pollock fishery through the shoreside processing component. Unalaska Dutch Harbor is in some way connected to all sectors and components of this fishery. The majority of shoreside processors are located in the community, and it's a primary location for CP and mothership product transfers. If a sector were to close prior to the B-season tack being harvested, the community would experience some level of adverse economic effects. Unalaska has derived tax revenues from direct fishery-related taxes. On average, the B-season pollock fishery has contributed just over $5 million in revenues to the city's general fund. And to put that figure into perspective, those direct fishery-related taxes accounted for just under 16% of the city's total general fund revenues on average. Those figures don't include or take into account the revenues that are derived from fees paid by AFA vessels or companies, say by property taxes or when fishermen patron local businesses, fuel transfers, taxes, harbor fees, among others. Also discussed in the SIA is that the community of Unalaska is a support center for fishery businesses across the BSAI region. If some of the sectors were to experience repeated closures, there could be some level of spillover effects into other fisheries in the region, as the community may no longer be able to sustain the businesses that support these fisheries. Finally, it's also possible that Unalaska could possibly anticipate some positive effects under the proposed action alternatives absent a closure. And this was more of a thought exercise as we conceptualized what could happen if vessels were to take longer fishing trips or more fishing trips, or if a cooperative were to issue a stand down, as Sarah spoke to earlier, because chum salmon bycatch rates were unacceptably high. It's possible that vessels may spend more time in port or on fuel. And should this occur, perhaps it would result in more fuel sales and sales taxes and other forms of revenue. But it's not possible to say whether these effects would offset the adverse effects for the city of Unalaska. Akutan and King Cove are located in the Aleutians East Borough, and these communities are each home to a single shoreside processing entity that has accepted deliveries of B-season pollock during the analyzed period. These communities in the borough would be adversely affected by a potential B-season closure under alternative 2 or 3. As discussed under the status quo portion of the analysis earlier, we did provide some estimates of the tax revenues associated with the B-season pollock fishery for scale. Additionally, a point that's noted in the SIA for all communities affiliated with the shoreside processing component, but it's discussed here because the example is specific to Trident's Akutan facility, is that high volume fisheries like B-season pollock can support the processor's ability to engage in other fisheries, including custom small scale processing that supports local small boat fleets. As an example, the Akutan Trident plant has played a role in supporting the local small boat fleet by processing local halibut deliveries, and the halibut deliveries from the local fleet may not be a significant source of income for the plant, but it is an important source of plural incomes for those local fishermen. This slide aims to capture some of the additional cross-cutting effects for communities that are affiliated with the shoreside processing component that could result from the proposed action alternatives absent a B-season closure. So Sarah has discussed the multitude of challenging global and domestic factors in effect for Alaska seafood markets. And it's uncertain what level of unharvested pollock resulting from a potential bee season closure could tip the sustainability of processing operations. And certainly repeated closures could exacerbate certain challenges for existing processors. Additionally, the analysis discusses the possibility for harvesters to slow the pace of fishing as one avoidance measure, and inshore processors in the communities in which they operate may experience adverse effects if the bee season deliveries from harvesters are slower or lower in volume, such that sufficient quantities of fish may not be provided for plants to operate profitably. Many plants have been designed to use economies of scale in production and to move an optimal volume of fish through the processing plant at the most efficient and cost-effective rate. And given the capacity of the facility as well as expectations of catch and delivery rates from the catcher vessel fleet. If operated at rates that significantly deviate from those at which the plant was designed, those economies of scale would be lost and the plant could become unprofitable to operate in the future. Additionally, the SIA describes a scenario where pollock harvesters are catching lower quality of pollock that could only be processed into certain product forms, and it's anticipated that that would impact the shoreside price that's paid to harvesters and thus the estimated taxable revenue that could be earned from the fishery.
Dr. Hoppola, we have a question for you. Ms. Baker?
Through the chair, thank you, Dr. Hoppola. I wondered if we could go back. I have a question about the potential impacts to an Alaska Dutch Harbor and the Akutan and King Cove slides. I think this is likely my uncertainty about some of the ways that we characterize social impacts in these documents. And so maybe this is for my benefit and hopefully the public too. There's a very clear statement for the potential impacts on Alaska Dutch Harbor about that community having a high degree of vulnerability under the proposed action alternatives. But then when you go to the next slide, there's a different characterization about the potential impacts in terms of that the communities could be indirectly and adversely affected by a closure. And so I'm guessing that the slightly different characterization in those potential impacts has to do with the dependence and engagement information that you went through previously by community level. But how should the council and the public approach that? Because there's a lot of words there that sound, really similar. And so what stands out about Unalaska Dutch Harbor that makes it highly vulnerable to these impacts versus the slightly different characterization versus Akutan and King Cove? If you can help me with that, please.
Thanks, Ms. Baker, for the question through the chair. One way that we considered a degree of vulnerability in the social impact assessment was just the touch points that a community had through the various sectors. So Unalaska is the location of 4 of 6 shoreside processing facilities. It's also the primary port where CPs and motherships make product transfers. So in that sense, it's connected in some way, shape, or form to all of the different AFA sectors in the CDQ program. And I guess one of the things that I didn't speak to in the presentation, but we covered in the document, Akutan and King Cove certainly also have a high degree of dependence on the bee season pollock fishery. And I suppose that the fact that they're the location of a single processor is not meant to imply that they're not. It's just how we thought of exposure to the potential impacts. And that frame of reference or that the conceptual framework for analysis does follow prior social impact assessments or the approach that's been taken previously. Not covered in the presentation, but covered in the document is also some uncertainty with the level of participation in the bee season fishery in the future for those 2 communities. And as we discussed before, under the status quo section, at this time, there's no cooperative that's affiliated with the Peter Pan facility in King Cove, and Peter Pan didn't open for the A season as well, servicing other fisheries. And given the uncertainty with Trident and the potential move from Akutan to Unalaska, it's not clear what the impact of the proposed action alternatives would look like on these 2 communities in the future.
Thank you. Another question, Mr. Twite.
Thanks, Madam Chair, and apologize. I'm back on the same as well. I was trying to read and keep up, and it wasn't working. I was also struck by sort of felt like a somewhat different treatment, but what struck me a little bit was contrasting that, in particular the Akutan and King Cove treatment with Seattle. With Seattle, one of the points that was made, and I think it's a very fair point, is that Seattle probably has a high degree of resiliency and can absorb some economic shocks. That I couldn't find anything in the actual analysis either. It's certainly not on the slide, but I'm also not finding anything about resilience, again, particularly for Akutan and King Cove. And I think, to me, a much more salient point, yes, Seattle's probably pretty resilient, but the really salient point is I don't think there's much, if any, resilience in either Akutan or King Cove, or really Aleutians East Borough as a borough to the loss of this much sort of processing capacity in the potential, and particularly at some of the lower levels of pollock harvest, higher degree of pollock closures. Those I just don't see much. To me, the light should be sort of flashing red, particularly around this slide for Akutan and King Cove, and I wasn't seeing it. So maybe you'll give me the same answer you gave Ms. Baker, but to me, that's one of the more certain outcomes of this is the and the communities that we have to pay the most attention to are Akutan and King Cove. I get your point about the future is uncertain for them, but doesn't that really just, sorry, I'm speechifying. I'll stop.
Thanks, Mr. Dwight, for the question through the chair. I think you raised some fair points. We could certainly do a better job at trying to tease out the adaptive capacity or the resilience to the proposed action alternatives and the adverse effects for Akutan and King Cove. I think it's challenging to do, particularly for King Cove, not knowing if an AFA cooperative would be affiliated with that community in the future. But that doesn't minimize trying to provide more information, to your point, for those small communities and their dependence on those single processors that have been affiliated with the fishery under the status quo.
Thanks. And I appreciate that, but I guess the question I would ask back is, yes, we can't see the future, but can't we say for relatively certain that whatever factors would decrease the revenues to the existing plant would also affect the desire of future potential either buyers of the plant or operators of the plant? Wouldn't it also decrease the attractiveness or the potential value of that to future? So see, you don't have to be able to see the future, I guess. In either case, it's impacted.
Sure, Mr. Twite, thanks for the question. I don't think I'm going to have a more specific answer for you at this time, other than I think those are conditions that are changing under the status quo and would be changing into the future and would be happening regardless or outside of the council's selection of an alternative in the future. So we can do a better job at characterizing them, but we really just tried to focus, at least for this iteration, to the extent that we could, on trying to get for you, the council, the proposed impacts of the action alternatives. So I do see your point, but I also think it's kind of the overarching challenge that we've really had to face is trying to describe the potential impacts when there's a variety of factors and other conditions that are affecting these fisheries and communities, and all of the other impact categories that my colleagues have spoken to, and trying to parse those out from the action that the council is considering. But I do understand your point.
Madam Chair, so I just have a few specific points here for potential impacts under alternative 3. Recall that under alternative 3, you would also adopt alternative 2. They would be adopted together, but alternative 3 adds an additional focus to Western Alaska chum catch by the AFA pollock fleet. And as we've highlighted, the AFA sectors will not know what their status of Western Alaska chum catch is in season. So there may be more of a reliance on historical Western Alaska chum encounter data and any other types of techniques that they've been using recently. Perhaps more they think of to try to minimize their harvest of these chum in particular. So there may be marginal changes in fishing practices, but they won't know the results of those actions until the genetic information is available. So I would say that there's incentives under alternative 3, but the tools may be limited, and certainly the results of those tools can be limited in season. If this results in more conservative fishing behavior or more targeted avoidance, there may be more increased avoidance costs associated with the marginal difference between alternative 3 and the addition of between alternative 2 and the addition of alternative 3. And if there's any questions on that, yep.
Yes, Ms. Kimball.
Thank you. My question was, there were a couple of places in the document where it questioned the legality of this alternative, and that's not in the PowerPoint. That seems important. Should you expand on that?
Thank you for the question, Ms. Kimball, through the chair. So I think the issues, as I understand it, and I'll ask for NOAA GC to weigh in if they would like, but in preparing the document, the issues with alternative 3 result from the fact that the sectors would not know their performance against the threshold in season. So in the implementation section of alternative 3, there is some description of an effort that could be made by the agency to provide weekly in-season management reports similar to what they do now, and use the proportion from the prior year and try to provide an estimate for the fleet of what their Western Alaska encounters might be in real time. But the performance against that would still, against the threshold, would still be assessed after the fact. And so therein lies the challenge with the potential fairness issues and the legal validity of alternative 3.
Through the chair, Dr. Hapla captured it as well as I could. If there's a question I could answer, but that's basically it. It's a huge delay in the effects and then fishing in real time and not knowing what you're catching.
Thank you. Oh, another question, Ms. Baker.
Thank you. So just to follow up on that, my takeaway from that is that the analysis raises these questions, and the council going forward could consider modifications to alternative 3 to address those changes or not, but ultimately we wouldn't get a definitive determination whether the alternative 3 could be implemented until we put that forward for final review, is what I'm guessing. I mean, we're not getting I'm hearing concerns are raised, and what does the council do with that? I guess that's what I'm asking.
Through the chair, yeah, it's not a bright line. I mean, you're highlighting the problem. I think we've discussed this with Dr. Hapla, that it's not a clear line, but it's an awkward situation when you're asking the way it as written to comply with a standard that you don't know in time as you're fishing, whether you're actually in compliance. And I understand technology may change, it might be in development, but that's what we understand the current playing field.
Yes, Ms. Kimball.
Then I'll just pursue that further. Then the things that we might provide more detail on about implementation don't change that fact. There's nothing changing that part of it that is challenging or potentially has a fairness or legal issue.
Right. It would be the consequences imposed on a vessel that creates the problem. So just the fact that there's a delay in understanding the composition is not the problem. It's what happens due to that catch.
Right. Okay.
Yes, Ms. Carroll.
Through the chair, This may be a super naive question, but couldn't this be solved by, and cost may be prohibitive, but by doing in-season genetic analysis? I mean, we're able to do that on the Yukon for chum. It might cost a ton of money, but.
Thanks, Ms. Carroll, through the question. There are some non-agency industry, well, I don't mean it as industry funded, but there's Bristol-based Science and Research Institute. BBSRI has an ongoing project for in-season genetic testing for the inshore component, but that work is ongoing and that project wouldn't be done and the results available in time for the timeline that the council is considering with these alternatives.
Not seeing any further questions at this point. Thank you.
Okay, thank you, Madam Chair. Now we're moving on to the remaining sections of the impact analysis under alternatives 2 and 3 as it relates to the other PSC species, Chinook salmon and herring. And I'll just go through this briefly in your document in terms of the relative trends in Chinook bycatch. You're all very aware of this and the changes in behavior and the relative level of bycatch since the implementation of Amendment 91 in 2011 and the implementation of Amendment 110 in 2016. And then this just gives you, for the years over which this analysis is focusing, 2011 through 2022, the relative numbers of Chinook taken in the Bering Sea pollock fishery. The description of the pollock fishery Chinook program is under alternative 1 in the beginning of your document. This figure is also in your addendum because the title of it just got overwritten by some characters in the PDF. But this is the 2022 stock composition estimates. This is just meant to remind you that, again, for Chinook, unlike chum, the majority of the composition of the Chinook stocks is of Western Alaska origin, which you see in this pie chart for 2022 on the left-hand side, looking at coastal West Alaska in the bright blue, middle Yukon in the red, and upper Yukon in the sort of greenish area. And then to the right is the spatial distribution of the Chinook bycatch in 2022 again. And you did get your report earlier today from Dr. Berry on the 2023 results. This is the figure that I included a little earlier just to explain the general AEQ. We have done an AEQ for Chinook. We've updated it multiple times, most recently in 2022. And when I get to the next slide, I'll explain some of the caveats to that. But again, this is taking into account the age composition of the bycatch and the relative maturity, the estimated maturity. Again, we used a weighted average across Western Alaska rivers to come up with that weighted in-river age composition, so that when you're looking at the difference between the bycatch and the AEQ, like in a specific year, such as 2007, that high year, the difference in that is because of the age composition of the bycatch and the number of fish that would have returned in that year. However, moving forward a year, then we are looking at the amount of the same calculation for the amount of fish in the bycatch and what age composition it is in that year and how many would have returned estimated based on that. But then it's also pulling in the fish that did not return in the previous year because of the relative proportion, so that you're incrementing ahead. And that's why you get this lagged effect. In general, for the pollock fishery, they can take anything from, they can intercept anything from 3-year-olds to very rarely 7-year-olds, but most of it tends to be in the 3, 4, and 5-year age class. And usually it's more peaked at the 4-year-old. So we do see a lag of several years for Chinook. Because of the information that we have from the genetics, then we can look at the relative AEQ. Again, this is just the AEQ going back. I would note that the genetic information prior to, as you recall, the genetic information we used in Amendment 91 was based on those opportunistic samples from, I believe, 2005, 6, and 7. So they're not really comparable to those samples from 2011 on. But this gives you the figure that was updated for the council when you had this discussion in 2022. The one thing I would note here is that at that time, because the council had requested an update to the AEQ, but if you remember, the genetics were lagged in several years in terms of us getting the council receiving the genetic report back, so that you were having a lag of several years before you received the genetics reports. They've since caught up and really increased the efficiencies of getting those reports out. But at this time that we ran this AEQ update, the genetic component for 2021 was estimated forward based on the average of the years before it. So that's why what you're seeing here, particularly, I'm noting this for, this is both for the CWAC as well as the Upper Yukon. I would note that was projected forward and hasn't been corrected for the actual genetics, which you now have for 2021 and 2022. So that Upper Yukon component should come completely down, but it's not updated based on that information. We then do an impact rate, the AEQ divided by the sum of the AEQ and the run sizes, again, by these genetic stock groupings, and that's why we have given you the PSC mortality rate that's associated with it. I would note that the increase in recent years in the CWAC component is not based on an increase in the overall AEQ and the bycatch in that component. It's based on the fact that you're pulling in the run size information. So as the run sizes decline, even if the bycatch stays the same or goes lower, that relative rate is going up because of the aggregate run sizes that are being pulled in. And likewise, to just caveat those numbers for the Upper Yukon, those rate increases are based on a decrease in the Upper Yukon, the run reconstruction information for that, but the genetic component of that was just estimated forward. And so if we reran this, you would not see that for 2021, as you saw in the genetic composition this morning, that those rates have gone down to statistically zeros for the most recent years.
And Ms. Kimball.
Thank you, Dr. Stram. I follow that, and you mentioned it even earlier in the presentation, but I wasn't sure where does this get updated? Do we have to do another Chinook AEQ to update that, or is this you keep mentioning if this was updated, is it going to be updated, or do we just caveat what we have?
Thank you, through the chair, Ms. Kimball. In the interest of time, we did not update this for this version of the analysis, depending on when we are bringing and what the list of things that we need to include. I don't think that it would be unreasonable to expect that this would be updated for the most recent genetics through what was presented to you this morning in the next iteration of this. Moving forward, just to show you a couple of tables, again, caveating these tables with the utility of looking at this in a retrospective and then accumulating over those years. Again, looking at here, we don't break anything out genetically because for purposes of management, it doesn't matter. We know what the genetic composition is to Western Alaska and the Yukon, Upper Yukon, but the cap itself is based on all Chinook. And so for general purposes, for purposes of this impact analysis, we just look at Chinook avoided, the reduction of the percent in the BCs in total, and then the reduction as percent of the annual total. And then as with the other tables, we try to show by individual year, which is what's shown here. Again, for one single, the same cap level of 200,000 under the apportionment for the 3-year average, and use that to get some sort. This is again assuming if you stopped fishing on that day, on that week ending date, and how much Chinook would not have been caught afterwards. And so you can see the relative percentage of those. We'll get into this more. The discussion of the trade-offs in PSC species is not in the impact aspect to Chinook or herring, but we talk about it in the subsequent section because that's more the important thing we're trying to set the stage for, not necessarily the numbers that were in the retrospective, but the balancing act, looking at a portfolio of bycatch avoidance techniques for different species, and how does the council and how can analysts provide you information to help understand the dynamics involved there. Chinook has been your priority and is in your purpose and need as remaining a PSC priority for avoidance.
Dr. Stram, a question, Ms. Baker, or excuse me, Ms. Kimball.
I'm just going to ask now, even though you said we're going to get to some more later, and it'll keep that question. So I understand you said you did the retrospective analysis and it's just based on the date at which the fishery would have closed, and then you save this many chum and this many. And so, and the assumption, even though we've heard throughout, is that you assume behavior would change, but all these retrospective tables assume behavior doesn't change. But in reality, you're telling us to assume behavior will change. And so I can see the utility of doing, and the limitation we all know of doing it for chum, and trying to have some estimates of chum avoided based on that closure date. I really wonder about the utility of doing it for Chinook. And I ask that because later on in the document from those same tables, you say, well, the opposite of this could actually happen. So it looks like we're avoiding Chinook, and yet a couple pages later, well, maybe you could be increasing Chinook because behavior will change. So I'm trying to find, for chum, it makes sense because the direction is always going to be the same in all of your analyses. You save chum. For Chinook and potentially herring, the direction of your impact could be opposite. So it seems very, I'm a little nervous about, I guess, providing something that we know isn't based in reality, but could give it a perception of a complete opposite impact. And I think in the SSC, they talked about perverse outcomes, and this seems like a primary one. So I put that forward because I know you're getting to trade-offs later, but I put that forward so you can give me a response on how we might address that so we're not making perverse outcomes.
Thank you for the question, Ms. Kimball. Through the chair, I think this is one of the things that once we had more time to consider the utility of presenting something in this manner, and given the discussion that we've had with the SSC and in the interim time between posting this analysis and coming here and having these conversations, I think there's a lot of other things we would want to go back to look into, because we did try to provide, especially in the qualitative table that we'll get to at the end, this could be completely perverse. We don't know. We haven't gone back. We just calculated this, and herring's going to be the same situation, the way that we had done the retrospective on the other alternatives. But what we probably really need to do is go back to the kind of the drawing board a little bit and looking at what are the Chinook rates by week earlier in the season? When are different sectors running into Chinook, so that we can get a better sense? I think that we would not do the analysis of that this way at all, because now we have the benefit of understanding that there's all of these trade-offs. And if we're going to try to understand what the impact of a management measure on chum is on the fleet and Chinook, we can't just use this age-old, well, they always get more Chinook in September and October. We know that they're more prevalent on the grounds, but we've also, as we'll get into with trade-offs, that put management measures in place to decrease the incentive to fish late in September and October. But what we don't know is, well, what else are we going to be looking at earlier in the season? Because now we're focusing things on those timeframes. And if we move the fleet around in June and July, could we be exacerbating Chinook by virtue of that, not just by extending the season, but where might they go? So I think that that's what we're trying to sort of wrap our heads around providing in the next time. And again, with all of our caveats that we've all been repeating, please don't take these are retrospective tables. And I think particularly for this and for herring, they're less useful.
Okay, I will avoid asking the same question about herring, but the fact that they're in the presentation, I think is probably good to keep highlighting that this is not our most likely outcome. And we're trying to hone in on most likely outcomes to make a good decision. I appreciate the explanation.
Thank you, Madam Chair. Moving into herring then, I'll just give a little explanation. And again, in particular for herring, because the amount is low, but just to remind the council sort of how the herring savings areas are formulated based on herring migration data. These were put into place in the 90s. There are three different areas. The winter herring savings area, which is that red hashed mark that you see up to the northwest. If triggered, that closes from September 1st through March 1st of the subsequent year. The summer savings herring savings area number 1, which is in green area. The summer herring savings area 1 is in blue, and that is closed from June 15th to July 1. And the summer herring savings area 2 is closed from July 1 to August 15th. So moving around according to what was known at the time of herring migration patterns. And what happens with these closures is, depending on the time of year that they are triggered, that whole series goes into place. So they don't have individual triggers. They have one single trigger that we'll talk about in just a second. That trigger then, the figure to the right is from a forage fish assessment showing those herring savings areas, but also in relation to what the major herring fisheries are in the Bering Sea. The herring spawning populations then are in the table to the left. This is the information that you receive from the state of Alaska at December specifications. And it's upon this information that the council that the PSC limit is calculated as 1% of the annual overall estimated biomass in the Bering Sea, which is provided to you in a document from NPFMC using all of those spawning area populations. The one that fluctuates the most then and is driving the majority of the biomass is the Togiak stock. And I would just note that because that one has an age structured assessment associated with it. The rest of them are done by aerial survey counts. And so you see that there's not a lot of variability across the different stocks in their biomass estimate. In fact, most of them are just carried forward as the best estimate from the previous year. The Togiak one, however, the stock assessment is used each year, but it depends upon age data from the directed fishery. There was no directed fishery, therefore they had no age data and were not able to use the stock assessment to estimate the biomass in 2024. So as a direct result of that, while if you look at the Togiak trend, it looks like the Togiak stock declined dramatically. That's an artifact of how it had to be calculated in 2024. By use of a limited number of aerial surveys. And absent the stock assessment model being able to be run for next year, that will be a similar situation in the subsequent year. So there is indication that the herring stock is increasing based on what we heard from the ESR and a lot of the survey data. Some of that survey data is included in your document, but the actual assessment of it is at a lower level, which results in a lower limit. That limit, again, during your December specifications process is apportioned to fishery categories. This just shows you for 2023, the fishery categories, the total catch and the limits by those categories. You can move those apportionments around during your December specifications. It's one of the tables that you go through in changing around. The overall limit is the one that's calculated based on 1%, but the category apportionments are something that are under the council's jurisdiction to recommend changes to. The pelagic target accrues the highest amounts of herring annually and is the one in which you put the majority of the apportionment of herring PSC. This table just gives you the herring PSC by sector and season. It's important to recognize that the herring PSC apportionment to the pelagic fishery is not apportioned to sectors. So all sectors contribute towards the overall accrual towards that limit. So it's possible when you have differential catch by sector, which you see in this table for a variety of years, that a single sector can drive the accrual of the limit, but the limit once reached applies to all sectors. So those sectors are closed out of those herring savings area, regardless of whether or not their individual sector caught very much of the overall herring. Just to demonstrate that they do fish obviously in different areas, and therefore the closure of different herring savings areas has a differential effect by sector. And you might hear some more of this in public comment as well. This is figure 6-31 on page 160 of your document. And this just shows you by A season to the left and by B season to the right, the overall catch of the herring in conjunction with where those herring savings areas are located. Again, the two of them that apply in the B season, which are closer to UNMAC, and then the A season one up in the Northwest. And then this is figure 6-32 in your document. This gives you the same information, but for the pollock CP sector, just showing you where the herring is caught in that fishery, and with an understanding of when those are triggered, where they might get pushed out of there. Finally, this just summarizes that in terms of the herring PSC, what the limit is by year for the pollock pelagic herring target, and then the percent of the limit. So obviously in red, you can see where those areas were triggered, and the herring savings area series of closures came into place. It matters when the limit is hit as to which of the closures will go into place. And again, I will just really skip past this because the important part of this is that this wasn't as helpful for herring, but the important part of herring is it does affect their behavior. So even if tables don't show that much herring is being saved by virtue of a closure in place, herring is a major factor in their fleet decision-making, because once they lose access to those herring savings areas, they have to make other decisions, and that might run them into different PSC species. Or if it's a limiting factor, they might be catching more herring, because if they move somewhere else, it might be that they run into Chinook or possibly chum. With that, I would move to the PSC trade-off section. So this is a section that we added to the document to try to get at, again, where we're sort of trying to move to.
Excuse me, before we move on, we've had a question from Mr. Tway. He's been pretty patient with me. Thanks, Mr. Tway. Go ahead.
I'm not sure I'm going to reward your patience, Madam Chair, but I have really about this entire section. I have kind of the same question / nitpicky comment that I had for Dr. Berry. And I'm just wondering what your thoughts are about using the actual date of implementation of the regs for Amendment 91, when really the previous 2 years reflect exactly the kind of actual fishery management measures that we've been that were then put into place through regulation with Amendment 91. And wouldn't it be better to be using that somewhat earlier cutoff to really reflect the difference, because it is actually the fishery management measures that actually impact what the bycatch has been?
Through the chair, Mr. Twite, and I have some figures to go through. I personally don't think that using the date before the regulation was in place would be accurate, because the behavioral changes that may have ensued prior to it, yes, are likely a result of the ongoing action at that time for modified behavior under an soon to be implemented management measure. But we also see, particularly for Chinook, behavioral changes since the implementation of Amendment 91, in particular, as you know, and creating and implementing Amendment 110, that while all the Chinook bycatch was much lower from 2008 on, after that high year in 2007, which is what caused the council to redouble down on efforts to focus on Amendment 91, the bycatch actually went up substantially in the first year of implementation, which caused the council to come back to the table to look at, okay, while it's below the regulatory caps, why would that bycatch have increased? And that's when we started looking into individual vessel behavior and whether or not, well, the council's intent was that at all levels of encounter, that to avoid Chinook, we were looking across different vessels and looking at, has everyone's behavior changed as a result of Amendment 91? Or we could have looked before it, or are there some vessels that are still maintaining a higher rate in relation to other vessels? And that was the impetus under Amendment 110 to also put in some additional provisions in the regulations for the IPAs to discourage the fishing later in September and October, and to actually penalize some vessels under those IPAs for continuing that kind of behavior, was to address the behavioral change that we saw after the implementation of it. So I'm not sure how you would quantify what the behavioral change was in 2008 through 2010, that the bycatch was lower without a cap in place in anticipation of Amendment 91. So I guess I'm not sure that I would see the utility in pulling years before. In a similar way, depending on where the council moves with chum, we saw a high year in 2021. The fleet put in some behaviors. We don't know quantifiably whether or not that's exactly why the bycatch was less in the subsequent year or lower in this year. But I think that we wouldn't be able to have a date that's not when a regulation was implemented, that we could quantifiably say, well, this happened in this year, so we should use 2009 on or 2008 on. So I don't know if that addresses your question.
It does. It doesn't resolve, but I think we can have that for future conversations. But I appreciate that response.
Thank you. Okay, so moving on to the PSC trade-offs. Again, we just wanted to highlight that while you're considering this action, it's important, obviously, to balance against the different PSC trade-offs that you have. This summary table is in your document just to look at the trade-offs. We're trying to show trade-offs in PSC here. This is not a value judgment in any way. We're just trying to look at the trade-offs and what the PSC under different alternatives. So we do assume that the fleet would change their behavior under the B season fisheries should a PSC limit be implemented. And this section is limited to the trade-offs under PSC limit. It's not meant to carry forward into what the PSC trade-offs are under alternative 4. I think that would be a different discussion. But the magnitude of these behavioral changes and avoidance strategies and the relative effectiveness of those to avoid chum or all chum or Western Alaska chum are uncertain. So we do know that in general across the sectors, Western Alaska chum are more prevalent in the early to middle. So in the June to July, sometimes into early August, than the later aspects. The council, as you're considering these bee season measures, you're balancing your provisions for Chinook. The tendency, as we saw, for Chinook rates to increase in September and October. But again, we have not gone back to look at different, I think we need to take a much finer scale look at Chinook rates in sectors and where they're moving to in order to have a better way to provide that trade-off. But again, as we already just discussed, that was part of the reason for some of the provisions under 110, not the cap level decrease, but the actual provisions in the IPAs to address that September, October. That was a consistent thing that we were seeing in every year prior to that. So we put together an assessment, and again, this was just very broad-based. I think we need to look a lot harder at this, looking at pre and post Amendment 91. So using the period prior to Amendment 91 up through 2010 and looking at it 2011 through 2022. And we looked at the top panel is Chinook, the bottom panel is Chum. And you obviously see prior to Amendment 91 over the bee season months, that increase, the noticeable increase in the bycatch rates into October. You no longer see that on a broad base. I think, again, we need to look much more carefully at the spatial and temporal resolution of that. But by design, under Amendment 110 and Amendment 91, that is why we were trying to cut down on that high level of bycatch in that time. We don't see that same behavioral shift in these kind of graphs for Chum. So basically behavioral shifts as a result of Amendment 91, we're not seeing that in the decline in rates over that time for Chum. Given the IPA operational structure that delineates the pollock fishing grounds east and west of 168 west longitude, as the Western Alaska chum are more prevalent on the grounds east of 168 and closer to the Alaska Peninsula. Again, you talked to Dr. Berry about that Unimac area. We tried to look at rates by month over those same timeframes, west and east of that line, to see about relative decreases, and just showing again for Chinook, you do see that that's really come down in both west and east. It's still variable for Chum over that same time frame, west and east. So we're not quite seeing in the east. It seems to be much less in the west. I wouldn't say that you're seeing exactly the same thing, particularly August and September. This is table in your table 6-52 in your document, where we tried to qualitatively compare across the alternatives. They're not really comparable when we looking at alternative 4. And again, as you're going to hear in our staff evaluation and assessment of alternative 4, it was on a very qualitative basis, and you're going to hear more from the IPA representatives about how they believe that where that alternative will address these. But looking at some different measures in terms of the Chinook PSC, the Chum PSC, Western Alaska Chum PSC, and flexibility for pollock fishing, we tried to just kind of directionally change. And this is getting at Ms. Kimball's comment where the SSC notes, and we do know that some of these measures could have the opposite effect. And we're saying that, yes, if the bee season extends, we think that is when you run into more Chinook still in September, October. We don't know really if different measures might affect Chinook earlier in the year without beginning to look at that. It's really going to be dependent on fleet movement. Obviously, if a sector or a fishery becomes closed early in terms of PSC, they would no longer be catching that PSC. In terms of Chum, Western Alaska and Chum, it's going to depend on fishing behavior and what kind of reduction and what kind of fishing behavior changes are done, as well as what the overall limit is. So it's kind of hard to say on a broad basis what that might be. We did look at kind of flexibility for pollock fishing. And here we're trying to look at this not necessarily as a lower PSC limit, but as a more constraining PSC limit. And it'll be more constraining depending on the alternatives selected, as well as the apportionment of that to sector level. So some apportionments, as Ms. Marinan and Dr. Hapola were indicating, some of the apportionments for the same limit are much more constraining on certain sectors than on others. And that's what we're trying to highlight here. Again, we are a little bit constrained in our ability to look at alternative 3 for all of the reasons that we had expressed. think I forgot that I zoomed in on alternatives 2 and 3 in here. So I've already kind of spoken to that. Again, for alternative 4, we had most things as neutral or possibly better, depending on how you would assess against those proposals and those measures, but we did not attempt to quantify that, or even we just qualitatively discussed it. And I'll pause there, Madam Chair.
Yes, Ms. Kimball.
Thank you. I wanted to better understand under alternative 2, the effects on Western Alaska chum. I understand the arrows, meaning you kind of don't know what the effect would be if you're just under a cap and the fleet is overall targeting area with low chum bycatch rates. It could be low chum bycatch rates that are Russian chum, and we're not having any effect in Western Alaska. And then I wanted to understand the down arrow. So we expect Western Alaska chum PSC to be reduced if a sector fishery is closed or when combined with other alternatives. And maybe it's like when combined with other alternatives, I need a little bit more on. Are we able to discern kind of yet within alternative 2 where we combine it with, say, alternative 4, and we have a positive outcome for Western Alaska chum versus a negative outcome? That seems like a clear possibility, depending on where those options lie.
Thank you, through the chair, Ms. Kimball. Yes, I think that's kind of reflecting that we know there would be fleet behavioral changes, whether or not you combine it with alternative 4. If you were looking just at alternative 2, we believe that the fleet would modify their behavior to try to stay under whatever cap and apportionment would be applied to their sector. We don't know yet what those avoidance mechanisms would be, but we're trying to reflect that it's possible that it's not that the sector is not closed, but they have put forward additional behavioral mechanisms to stay below a cap and therefore would not catch as much Western Alaska chum, understanding that they don't know necessarily real time where that Western Alaska chum is. And that makes this whole thing very, it's why alternative 3 is very difficult to assess in any meaningful way within that year. But there are patterns, as you see from Dr. Berry's presentations, and there are patterns that do tend to persist somewhat in time and in space. And so developing strategies to avoid those areas or those times for the fleet, if presented with the incentive to do so under a cap, or as you'll hear, under alternative 4, by their own IPAs absent a cap. So I don't think we've gotten to the stage where we were trying to mix and match across alternatives to see how that behavior how those would be combined to estimate behavioral changes. That was just really reflective of the fact that we assumed that there would be fleet behavior, but we don't know what it would be at this stage.
That's really helpful. Thank you. And I hope we can see something to explore that for the Western Alaska chum portion. And in part because it seems like there could be a possibility clearly where you have a cap that's of a level that nobody is focusing on Western Alaska chum anymore. They're just trying to stay below a cap. And that's the crux that I'm worried about, where we lose any attachment to our overall objective. So I'll put that out there, and I mean, you can respond as kind of a half question, or we can just wait and see what we get in the next iteration. But that's an effect that I feel like we haven't brought out that's really quite possible.
Madam Chair, Ms. Kimball, I think this is a point I wanted to highlight here, which has to do with your question, because I don't think, I think we could have been a little bit more explicit at considering the alternatives together, because alternative 4 isn't mutually exclusive from alternative 2. And it's sort of embedded in some of the discussion in the section that I presented about, this sort of spectrum of constraining, very constraining versus not as constraining, which is dependent on factors on the ground. If you've got herring savings area closures and what's happening with Chinook and other things. But I think there is a point like you're describing, if you've got alternative 4 in combination with alternative 2, and you end up in a situation due to whatever factors where you're getting closer to the very constraining, and then you chop that up by sector and by vessel, and the avoidance options available become less. There's less they can do, and it maybe becomes just a little messier in terms of what incentives they're responding to. They're responding to the one that's going to most likely to constrain them first. And so that could be a situation like you're describing where they're responding to the overall chum PSC limit and having less ability to use some of the techniques that they might have thought of to avoid Western Alaska chum specifically under that very constraining place, versus if it's not quite as constraining and they have a little bit more flexibility, they might have more space to use those tools under alternative 4. So thinking about them in combination with each other, you can maybe use that kind of analogy of like the spectrum of where they are in constraining, which we've talked about isn't necessarily, it's hard to say a number because that can, in one year, that can look very different from another year.
Thank you very much.
Okay, with that, Madam Chair, it moves us on to the next portion of the presentation, which is the staff assessment of the IPA proposals under alternative 4. I guess I would just note before we get into it that we're going to try to cover this at a fairly high level for the council, just knowing that you guys are going to receive 2 presentations from the IPAs on their 2023 performance, as well as the content of the proposals. So we're just going to walk through the approach that we use, the common features, and then sort of a summary takeaway of the provisions that are within those proposals for you. So this slide walks through some of the considerations for the current and potential future approaches that could be taken to analyze alternative 4. And you can find more information on this in section 6.3 of the DEIS. So for this iteration of the analysis, we described some of the common features of the different proposals, the provisions that are put forward, and then we tried to provide an assessment of whether those proposed measures could result in some additional level of avoidance of chum salmon or Western Alaska chum salmon relative to the status quo. And one reason for this approach is that the council still needs to provide input at this meeting to determine what content would be added or modified to the current regulations. Many of the proposed provisions to avoid Western Alaska chum salmon could be incorporated under the status quo regulations. If you recall, way back at the beginning of the presentation, we had covered that there's currently a provision that requires the IPAs to describe how they avoid times and areas when Western Alaska chum salmon are present on the ground, fishing grounds. Depending on how the council finalizes this alternative, we might be able to take some additional approaches. So perhaps we could provide some information on past rolling hotspot closures and other information provided within the IPAs. We might also be able to take a look at different bycatch rates and proportions, but I think the expectation that we've tried to set is that we would caution against our ability to be able to model the rolling hotspot system under the status quo, and therefore any of the proposed provisions that are within these proposals. And one reason for that is that the rolling hotspot system is dynamic. So the time and the area and the rates at which they're triggered vary year to year. And a second key component to how this program works is really the contextual and local knowledge of how the fishery works. And that comes into play in determining where to move the fleet and being able to communicate with pollock fishermen in real time about the conditions they're facing on the ground. And finally, some of those provisions have been in place since 2022. And so we would just, I think at this point, be looking for direction from the council and certainly from the SSC, but we haven't had the benefit of seeing their minutes or hearing some of those final comments on what would be the most useful moving forward. So this slide just captures some of the common features of the proposals. As we've discussed throughout the presentation, as well as the analysis, a primary strategy for chum salmon bycatch avoidance is fleet movement on the pollock grounds. And the IPA proposals considered the potential additional measures within the context of how the sectors operate. So some of the specific considerations that are laid out include the fact that CPs are able to harvest and process pollock at sea on the same entity, and they have more flexibility and where they can fish and traveling further from shore to target areas with good pollock CPUE and low bycatch rates. Mothership CVs work cooperatively as fleets around the mothership that they deliver to, and inshore CVs are limited in how far they can travel from shore because processors have a 48-hour delivery requirement in order to maintain high quality products. These delivery requirements combined with vessel size influence how far inshore CVs can travel. Additionally, Dr. Barry spoke to it a little bit this morning, but a trip's worth of catch for these vessels is typically 2 to 3 hauls, which gets delivered to the shoreside processing plant for observers to census, count, and sample. And mothership CVs and the CPs don't have this same kind of data lag where you can end up receiving information on your bycatch for a trip several days after the trip is completed. All proposals considered measures that would minimize chum salmon bycatch with minimum impacts to pollock CPUE, and the reason for that is to not run the risk of pushing vessels into fishing later in the B season when Chinook rates have historically been higher, as Dr. Stram spoke to. And an additional point that is important to note is that the IPA proposals do consider the additional provisions by fishing grounds areas as opposed to the genetic cluster areas, the latter of which were the spatial units of analysis identified in the council's October motion. This is figure 643 from the DEIS, and on the left-hand side of the slide, you can see the distribution of the genetic cluster areas compared to the spatial distribution of the fishing grounds areas. Both are groupings of ADFNG groundfish statistical areas. Each image has for you the catcher vessel operational area in red, as well as the chum salmon savings area with the blue dashed line inside. IPA representatives' rationale for the proposals evaluating these measures based on the fishing grounds analysis is that they're smaller in size. They're more reflective of how the industry prosecutes the fishery and how Sea State considers fleet movement to different areas under the current program. The next 2 slides are really just meant to be a reference for the council and for the public. This slide summarizes for you the provisions contained within the catcher vessel proposal on the left-hand side compared to a related measure under the status quo program, whereas the far right column shows a staff assessment of the potential benefits of the proposed provision at a very high level. The next slide provides for you the same information, but specific to the CP proposal. And then next slide. In terms of the summary takeaways for the council, in general, the provisions that are incorporated into the 2022 CP IPA amendments, the additional provisions put forward by the CP IPA proposal at this time, as well as the additional measures that are put forward by the catcher vessel fleets would likely result in some additional level of avoidance compared to the status quo. The primary changes to the status quo rolling hotspot system identified in the proposals include assessing closure areas for their likelihood of Western Alaska chum salmon historically. So the proposals describe that the council and the public could expect closures to be optimized in the shelf edge area, which you can see here in blue. And the shelf edge largely aligns with cluster area 2, part of which is in the CVOA. Western Alaska chum salmon are encountered in higher proportions in cluster areas 1 and 2, as well as the Unimac fishing area and the shelf edge areas. So this has the potential for additional savings relative to the status quo. A second change that could be expected is that information would be evaluated more quickly. So since 2022, the CP IPA has evaluated closures on a bi-weekly basis, and this is now also a component in the CV fleets proposal. The measures aim to minimize the potential for high bycatch spikes by incorporating the historical genetic information and the CV fleet using a move along rule, as well as through the biweekly evaluation of data and closing areas to all vessels, regardless of their performance when chum salmon bycatch rates are very high, although the proposals define what constitutes very high slightly differently. I guess I would just end and note that the dynamic area closures under the current rolling hotspot system, as well as the addition of these potential provisions in the future, are based on bycatch rates compared at different temporal and spatial scales. So the relative effectiveness of the provisions is ultimately going to depend on fishing behavior and the fleet's dispersion on the pollock grounds as well.
Dr. Hapola, did you do by chance, and maybe I missed this, a cursory review of the recommendations by both the CV and mothership sector and the CP sector on regulatory changes and whether or not there would be required changes or modifications to the provisions, or whether or not they would fall under the existing language, or looking for additional direction from the council before conducting that exercise. Thanks.
Thanks, Madam Chair, for the question. I think both. We didn't have the benefit of being able to listen to the catcher vessel fleet's presentation in the AP, and we certainly haven't sat down as a group to walk through that. I do think there are some distinctions within the provisions that have been put forward in both of the proposals that would be modifications to the current regulations. But if you're looking for sort of a walkthrough of that regulatory language, we didn't have time to pull that all together.
Thank you.
So, Madam Chair, we're just going to wrap up the staff presentation with some of those points for consideration in the summary of the council action. I would just reiterate, as we noted for you at the start of the presentation, that at this time, the council can choose to modify or refine its alternatives, and we've prepared several questions as a point of reference for the council and its consideration in the C2 action memo. A second task is that the council could determine if and how it would like to move this action forward, whether that would be scheduling an additional review of the analysis or making a recommendation that the preliminary DEIS be revised based on the input received at this meeting and released for publication by NPFMC as the draft EIS. Slide. And that brings us to the end of our staff presentation. And of course, we're happy to answer any additional questions, but I think it would be appropriate at this time to say thank you to all of the contributors who made this possible, especially on a shortened time frame. It was a large lift, and there's a long list of individuals that we wouldn't have time to thank and list out, but they're there for all of you.
Thank you. Echo that appreciation, and appreciate all of you for really accommodating to the request to make this happen in the April meeting, considering the concerns we were getting from the public. So really appreciate that. Mr. Dwight.
Madam Chair, could I just join you in thanking the staff? I recognize the pretty high degree of stress that we put on the three of you and your many contributors and collaborators in order to achieve this. I still think April was the right time. June was going to be very difficult geographically, and October was simply too far away. And I am amazed by the quality of the product that you put in front of us. The richness of the conversation that we've been able to have based on the information in front of us, and is really consistently impressed me all the way through both the previous iterations in front of the SSC and the AP. And also, at least as I've listened to the questions, they're not questions that are coming at you because the product was somehow either incomplete or flawed due to the timing. Their questions arising out of the complexity of the information that you've had to try to distill down. And I think they would have been inevitable questions had you had another half a year to work on it, I think. This is a really knotty sort of thing. As I was listening to Ms. Marin and sort of summarize some of the tensions that are inherent in building a program like this, where you're trying to balance between different things. Those require an iterative back and forth between staff and council with a substantial amount of public and stakeholder input. So I'm not saying that the timing was good from the perspective of the stress that it put on staff in general. I think that was really unfortunate, but I did want to reassure you that, at least from my perspective, the product didn't suffer from the timing. You may have all lost a few years off your life, but you produced a pretty amazing product. Thank you very much.
Thank you, Mr. Twite. So that concludes our staff presentation on C2. We do have a brief report and an update from Jim Harmon from C-Share. If you'd like to join us, if you're available, great. And then we will come back in the morning at 8 a.m. and begin our presentations on IPA reports. Then we'll have our SSC report and our AP report. Thank you. Welcome. Hello.
Good afternoon. Thank you for making time for me, Madam Chairwoman, and members of the council. My name is Jim Harmon with C-Share. I also want to introduce Hannah Lindoff, who is our new executive director at C-Share, and she is joining us in her first week. So thank you for having us.
Thank you, guys. Congratulations on your new position.
Okay, thanks again for your patience as we get this queued up. I submitted my report in letter form, but I've also put together some slides to kind of walk you through our actions over the last year. So please bear with me. Thank you for the opportunity to present this update to the North Pacific Council, Fisheries Management Council. The Prohibited Species Program donation program has now generated over 26 million servings of high protein seafood for Americans struggling with hunger. I think it's important to tell you that nobody asks for bycatch, but everyone who participates in our program appreciates the value that these fish can have for hungry families. Food bank clients in Alaska and the lower 48, where seafood is in scarce supply, benefit greatly from this program. Those struggling to feed their families face the burden of not only getting enough to eat, but also accessing nutrient-rich foods that promote good health and help reduce the risk of chronic disease. Seafood, particularly Alaska salmon and halibut, are high quality proteins that contain essential vitamins and minerals. In addition, hunger relief efforts are increasingly focused on waste reduction across the food chain. This program exemplifies that effort and offers a positive example of industry and regulators coming together to do the right thing. C-Share's role has worked with fishermen, processors, and other stakeholders for 30 years now to retain and donate valuable protein that would otherwise be discarded. And we remain the only organization authorized to retain prohibited species catch from the BSA and GOA and use those fish exclusively for hunger relief. To summarize our efforts, we work closely with NIMS to manage the permits for both salmon and halibut, and we maintain the relevant records. Those permits were most recently renewed in June 2023, and I appreciate the help of everyone at NIMS and NOAA who approved those permits for us. We enlist boats and processors who are willing to retain, clean, and donate the fish. The list of vessels and plants changes slightly every year, but the overall participation remains consistent. We also coordinate the downstream services needed to turn those fish into packaged servings and distribute them to food banks and feeding centers. It's important to remember that we receive no government funding to operate this program, but we secure funding to support the costs that are not fully donated from generous financial supporters. I wanted to cover the retention and quality standards briefly. They're up on the screen there for you. This program is voluntary and it needs to be voluntary. It allows the processors to retain fish only if they are wholesome and usable, and when the processors have staff time and line time to clean, freeze, and pack the fish properly for donation. Shore plants can retain both salmon and halibut. At-sea processors only retain salmon, as per IPHC recommendations. Salmon donations include both chum and king salmon. The boats and processors follow strict guidelines for quality, packing, and storage. At a minimum, they agree to H&G, freeze, pack, and record all fish for donation. Here's a list of the current participants: 132 catcher boats, 12 shoreside processors, 35 at-sea processors, 2 reprocessors in Puget Sound, and multiple cold storage, freight, and logistic companies in Alaska and Washington. So here you can see what we've done over the last 30 years on the right, and in the center is last year's results. The total is 164,000 pounds, and over since 1994, it's 6.6 million pounds. Of that volume, 13,026 pounds were distributed in Alaska, and 151,000 pounds were distributed in Washington and California last year. It's important to note that the success of this program allowed us to enroll other partners to work on other donation projects in Alaska and across the country. And we try to utilize seafood when and where it's available, but because of certain freight and logistical constraints, we can't always send fish back to the communities nearest to where we find them. So we work to distribute donations. In order to reach more communities across the state, we access other non-PSC fish. Then we recruit freight partners to send those donations to coastal communities and population centers. Some of our more recent donations, there's a just to back up a second. The freight options are kind of limited because the freight wheel turns counterclockwise in Alaska. So once you get things past Anchorage, it's really hard to get things back to Anchorage. If you're in Kodiak or if you're in Dutch Harbor and you load a boat, there's no way to get it back in the state. It comes all the way down to Seattle. Sometimes we rework it there, and then if we can, we send it back to Alaska. But often we donate it in the lower 48. This is a map of our current distribution in Alaska. The orange locations are places where we have qualified food banks to receive and distribute our product. In some cases, we've given them freezers to hold more seafood. And then the blue locations are other communities and villages that are served from those major distributors. So as I was saying, in order to reach more communities, we have to access other non-PSC fish. And that's important to remember. We sent canned salmon to the Food Bank of Alaska and the Fairbanks Food Bank. Actually, just today, we sent 3 pallets all the way to Savunga to help an emergency there. So canned salmon is an important resource for us. We've sent non-PSC salmon to our freezer in Dillingham. We sent breaded Alaska pollock portions to Bethel, thanks to Linden Air Freight. We sent frozen portions to our freezer in Juneau. We sent non-PSC salmon to villages in the YK region, and we sent non-PSC salmon to villages in Western Alaska, thanks to Coastal Villages. Then some of our PSC salmon and halibut is donated in Kodiak, and some of it's also sent to the Kenai Food Bank, thanks to Carlisle and the ferry system there. We develop partnerships with seafood companies, tribal entities, and freight carriers to create distribution networks that didn't exist before. We're sending food to Nome, Kotzebue, Bristol Bay, Kenai, and the YK region. All seafood donated in Alaska is at zero cost to the receiving agencies. Food banks in the lower 48 are able to support some of our seafood donations with funding, and that is why it's important that we send some of our PSC salmon and halibut to locations in the lower 48. They help finance this program. I need to go back and tell you that last point. Over the last 30 years, bycatch accounts for only 10% of the 270 million seafood servings that we distributed nationwide. In 2023, we spent $106,886 to support this program. The boats and plants who retained fish for donation received no compensation and received no funding from state or federal government. Feeding America food banks in the lower 48 help us by reimbursing a portion of the associated costs. Fundraisers, grants, and other gifts are secured each year to support the program. So I've added some photos here to show you some of our work across the state. And I'll just scroll through those as I tell you about the summary here. We've worked for 30 years reducing waste while providing nutritious seafood to families served by food banks. It's also been a catalyst for other valuable donations in Alaska and the lower 48. Seashore exists to provide food banks and feeding centers access to nutritious seafood. Fish from the prohibited species donation program makes up 10% of our total volume, but it takes probably 40% of our work, of our time. We're grateful to NIMS and all the individuals, companies, and organizations who support the seafood prohibited species donation program. I'm also thankful for you all for your leadership and for the catalyst to help us get this program off the ground 30 years ago. We'll continue to combine the generosity of all of our partners to achieve maximum benefit for everyone. And I would ask you to please let us know if you have ideas or other recommendations to improve this program or expand it. So this is a good example. This is Dillingham. We filled the freezer there. This is the third freezer we're on in Dillingham. And then as they have extra freight going to regional centers like Togiak, these planes will fill up the back with seafood and fly it out to the smaller villages for us. This is the freezer we installed in Bethel. We found out afterwards we had to upgrade the electrical there in order to take 443 phase. So that cost another $20,000. All financed by Seashare. And this is thanks to Jack Schulteis sent these photos of the last 2 years. We've been sending them 3 years. We've been sending fish to the Yukon. Jack receives a lot of it. Fairbanks gets some of it. They break it down and pack it into smaller boxes. They put it on skiffs and send it up the river. Okay, so that's the gist of it. I'd welcome any questions you want to ask, and you can ask Hannah. Break her in.
Thank you very much for the report. We really appreciate it. See if there are any questions for you, Ms. Kimball.
Thank you. Thanks for the report, and I appreciate the difficulty in trying to move anything around Alaska. You mentioned in passing kind of partners to move fish from kind of a central hub to villages. Who's doing the actual distribution from like Bethel or Fairbanks up and down the river? Are you partnering with tribal organizations or with CDQ groups or both? Just a little more detail.
Thanks for the question. Through the chair, Ms. Kimball, we work with a variety of food banks and feeding centers to distribute our food. In the lower 48, everything goes through Feeding America, who has a national network of food banks that cover all 50 states. They only have one affiliate in Alaska, and that's in Anchorage. So any other community, according to our charter and according to our board, we have to go out and approve receiving agencies to take it. So Southeast Alaska Food Bank in Juneau is one. We started a food bank in Bethel, the Lions Club did, to distribute food out of Bethel. We work in Kodiak with 3 or 4 organizations there to move our seafood. So in every one of those smaller locations, we have to go out and qualify, make sure they have the record keeping, the safe handling instructions, and the personnel to safely and efficiently move our seafood. It takes a lot of work in communities like Bethel and Kodiak and all over the state. So it's taken a lot of years to get us this far. We're always looking for more locations to do. It just depends on whether we have freight In some cases, we have frozen barge service that we can send things in on. But in other cases, we have to fly everything, and that's still expensive. We're trying to be the alternative to bypass mail and expensive air freight, but in some communities, we still have to do that.
My only other comment was I appreciate you mentioning Jack Schulteis in your comments at the end. Thank you.
Mr. Sakata?
Yes, thank you. And through the chair, not so much a question, but just a thank you to Mr. Harmon and Ms. Lindoff, Coastal Villages Region Fund, teamed up with Seashare, and our communities are very thankful for the donations and the partnership, and we look forward to working with you in the future. So just thank you very much. Our communities are grateful for the donations.
Thank you. Thanks. And Mr. Twite?
Thank you, Madam Chair. Thank you, Mr. Harmon and Ms. Lindoff, and welcome aboard. I've heard in previous presentations some discussion as well about sort of the disparate amount of work required for bycatch, moving bycatch product versus others, and it's never occurred to me to ask why, and I didn't want you to be able to ride off into the sunset without having to answer that.
Thank you for the question. Through the chair, Mr. Twite, that's such a complicated question. We could spend a lot of time on it, but to put it briefly, there's a couple things. One, bycatch is very hard to distribute when it's in the form that we receive it, headed and gutted. There's only a few communities that are willing to receive headed and gutted frozen fish. So around Kodiak, there's some in Kenai. Most of it has to be turned into steaks. So we have to bring it somewhere. We store it, and then a couple pre-processors in Seattle use this fill-in work for their crews. When they don't have other business, they pull our fish out, they trim them, they steak them, they rebox them, and they put them in family-sized portions that food banks can use. So that's the complication with bycatch. The other thing is that we've gotten into this before, and I don't want to spend a lot of time on it, but some communities, there's a lot of sensitivity around bycatch. And there's a lot of sensitivity around feeding people with fish that they aren't catching themselves. So that creates some complexities in what we send to different places. But at the same time, it's hard to distribute breaded pollock portions in Western Alaska. So there's a lot of sensitivities around species and product forms and types. But bycatch it's expensive and it's great protein, so it's worth the extra effort.
Not seeing any further questions. Thank you again for your report. Really appreciate it. So with that, we'll conclude for the day, come back at 8 a.m. and resume with our IPA reports on agenda item C2. Thank you. And just another reminder to the public wishing to testify on this agenda item, please do follow the conversation and the timing of the conclusion of all of the C2 agenda items tomorrow, and please sign up before the end of the AP report. Thanks.